According to Economics Time, the government of India aims to convert 30% of vehicle on road to electric vehicle by 2030, creating nearly 1 crore direct EV jobs by the decade's end. But if you look at the job market right now, you will find that the current number of skilled EV engineers is way less than if you compare it with demand. And that's exactly what makes a career in electric vehicle a great choice. And I'm not saying this out of my own will. If you search on the internet, you will find that the demand for EV engineers has been on the rise for last few years. And to capitalize on this growth and help you make a career in electric vehicle industry, we have created this EV course. In this course, we talk about almost everything you need to land a job as an EV engineer. Let me take you guys through the agenda for this course. We will start this course by understanding the electric vehicle landscape in India, how exactly electric vehicles are designed in EV production units alongside, and how self-driving EV cars work in reality. Then we will go ahead and talk about how to make a career in EV industry, different career opportunities in EV industry available right now, alongside battery management system in EV. I hope I have made myself clear with the agenda. But before I begin with this career-oriented course, make sure to subscribe to Intellipaat's YouTube channel. That being said, let's get started.
Electric vehicle and its future in India. An electric vehicle is one that runs on electricity rather than an internal combustion engine which creates power by burning a mixture of fuel and gas. As a result, such a vehicle is being considered as a possible replacement for current generation vehicles in order to address challenges such as rising pollution, global warming, diminishing natural resources, and so on. Though the concept of electric vehicles has been around for a long time, it has gotten a lot of attention in the recent decades due to the increasing carbon footprint and the other environmental repercussions of fuel-based vehicles. Why are electric vehicles boon to India? Does not need many conclusive factors. Here are some important statistics. India has 6 of world's 10 most polluted cities. The main cause of this growth in pollution is the use of fossil fuels. India's oil import, overall India's dependency on crude oil imports is 86%, which implies the country meets just 14% of its own energy needs. The rest is imported. Global climate change, heat emissions, the Paris Climate Accord, and the impact of sophisticated artificial technology on self-driving cars are all discussed thoroughly. Electric vehicles market share in India. The Indian automobile industry is the world's 5th largest, and it is anticipated to become the 3rd largest by 2030. According to the India Energy Storage Alliance, the Indian EV market would develop at a 36% CAGR. As India's population grows and demand for automobiles increases, reliance on conventional energy supplies is no longer a viable option as the country imports over 80% of its crude oil. By 2030, Niti Aayog expects to reach 70% EV market penetration for all commercial vehicles, 30% for private vehicles, 40% for buses, and 80% for 2 and 3 wheelers. This is consistent with net zero carbon emissions by 2070. The Indian electric vehicle market was worth $1,434 million in 2021, and it is predicted to grow by $15,397 million by 2027 at a CAGR of 47.09% during the forecast period of 2022 to 2027. Obviously, there are also some drawbacks in the transition to electric vehicles. Some of them are electric vehicle charging infrastructure that may need another huge set of investment from the government and other competitive authorities. The higher costs. There will also be a lack of skilled workforce. The technology that we currently hold is very limited, and also the import of electric vehicle components and materials.
Electric vehicles are the wave of the future. Manufacturing businesses are putting in more efforts into transitioning from traditional automobiles to electric vehicles. There are several advantages to owning an electric car with the appropriate level of functionality and infrastructure.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth. Do you know friends that every great innovation starts with an idea? And electric vehicles are no exception. They are built to head into a sustainable future, removing the rate of carbon emission happening on the roads. The process of manufacturing these vehicles begins with the designers and the engineers brainstorming various concepts to create an electric vehicle that aligns with the needs and desires of the people. Initially, they consider questions like what type of electric vehicle would best suit the urban environment that promotes eco-friendly commuting? Or how can we design an rugged electric SUV that appeals to the adventure seekers and the outdoor enthusiasts? These queries guide the team as they lay foundation for a vehicle that will impact the lives of countless people worldwide. Then we move to the research and development. After we have achieved a clear vision, the next process is to gather data and research. Engineers and designers analyze existing electric vehicle technologies, batteries, and motors while keeping an eye on the latest trends in the sustainable materials and energy efficiency. So you can consider asking questions like what materials do you think would be ideal for building the body of an electric vehicle. After this, we move to the prototyping stage, where skilled designers leverage advanced computer-aided design software to create virtual representations of the vehicle. This virtual canvas allows them to experiment with the various shapes, sizes, and contours until the perfect design emerges. Let's see an example. We all know that aerodynamics play a vital role in the efficiency of an electric vehicle. So engineers meticulously assess the airflow patterns and make precise adjustments to minimize the drag, thus optimizing the vehicle's range. This process may involve countless iterations, each taking them closer to the ultimate electric vehicle form. Once the virtual model is refined, it's time to bring the design to the life through physical prototypes, through testing and validation. The testing and validation phase is crucial for ensuring the electric vehicle's safety, performance, and efficiency. Engineers conduct crash tests, evaluate range, acceleration, and top speed, and also analyze energy consumption. Real-world simulations are also performed at this stage, which helps to identify potential weaknesses. Extensive road test is also performed, which ensures the vehicle meets real-life driving expectations. This rigorous process guarantees that electric vehicles meet the highest standards, assuring customers of a safe, reliable, and eco-friendly driving experience. After rigorous testing, we move to the battery and powertrain integration. We all know that the heart of an electric vehicle lies in its battery. At this stage, engineers optimize the battery's capacity, weight, and cost effectiveness while experimenting with advanced battery chemistries and cell configurations to extend the vehicle's range. Simultaneously, they design the powertrain for efficient propulsion, considering single or dual motor setups, front or rear wheel drive configurations, and all-wheel drive options. The goal at this stage is to harmoniously unite the battery and powertrain to create a dynamic driving experience while maximizing energy efficiency, thus empowering electric vehicle to perform at its best and pave the way for sustainable mobility. After battery and powertrain integration has been done, we move to the next step in the design process, that is interiors and user experience. At this stage, the interior and user experience of an electric vehicle are carefully designed to provide comfort and convenience. Ergonomics play a vital role in ensuring seamless driving experience. Designers focus on creating an intuitive dashboard layout with an easy access to the essential controls and information. Infotainment systems are integrated to offer connectivity and entertainment, thus making journeys enjoyable. Additionally, charging solutions are integrated into the interior design so that there is a hassle-free access to the charging ports. At this stage, engineers aim to create an inviting and user-friendly space that enhances the pleasure of driving. After successfully completing the interior designing and user experience, engineers give a thought on sustainability and environmental impact of the electric vehicle. As the scientific research states that electric vehicles lead the charge towards sustainability, which aims to reduce their environmental impact significantly. At this stage, manufacturers prioritize the use of recycled and sustainable materials during production, thus minimizing resource consumption and waste generation. With zero tailpipe emissions, electric vehicles contribute to the cleaner air and reduce greenhouse gas emissions, thus promoting a healthier planet. Their adoption plays a vital role in conserving natural resources and reducing our dependence on fossil fuels. After completing all these feasibility studies, an electric vehicle moves into the development phase. It is a very thorough and lengthy procedure. However, the design mostly revolves around the set vision for the product. Now I hope that you guys are clear with the fundamental notion of the electric vehicle design process. Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth.
Have you ever imagined cars driving themselves without any human intervention? It might sound like a dream, but guess what? It's becoming a reality. There are already some cars on the road that can drive themselves partially, but the researchers are working hard to make fully autonomous cars. In this particular video, we'll explore the fascinating world of autonomous vehicles. We'll uncover the logic behind them, what they actually are, and how do they see and how they work without human intervention. First of all, let's try to comprehend how self-driving cars can see the objects in the surrounding. For that, let's imagine that there is a self-driving car running on the road. Also, to increase complexity, let's say that it's late night with pitch dark, and on a road, there are few obstacles in front of the car. The car now needs to see and understand these objects to make safe decisions without any human intervention. To do this, the car uses smart eyes called sensors. These sensors work like magic, giving the car all the information about the size, shape, and position of the obstacles in just a split seconds, no matter how dark or tough the conditions are. To achieve this complex task, the car uses a special laser-based tool called LiDAR and a smart communication technology called integrated photonics. LiDAR sends out laser beams that bounces off the objects and come back to the car's sensors, creating a 3D map of a surrounding. It's like a magical blueprint that tells the car where everything is, even tiny details like the button on someone's shirt. But how does it measure the shape and depth of the objects? Well, LiDAR continuously fires laser pulses to measure the distance. For example, if there is a dog in front of a car, one pulse might hit the base of dog's ear and the next one might reach the tip of the ear before bouncing back. By measuring the time it takes for the pulses to return, the car can understand the shape of dog's ear. With a lot of short pulses, LiDAR renders a detailed profile of the object. The most obvious way to create pulses is to switch the laser on and off, but this makes the laser unstable and affects the precise timing of its pulses, which limits the depth resolution. So it's better to leave it on and use something else to periodically block the light reliably and rapidly. That's where integrated photonics steps in. Integrated photonics uses tiny optical circuits to manipulate light and precisely control its path. It's like having a super smart traffic controller for light. So instead of switching the laser on and off, which can be unstable and affect the timing of pulses, integrated photonics steps in to efficiently block the light at just the right moments. This ensures the laser pulses are delivered with precise timing, resulting in a high-resolution depth map. With this powerful duo of LiDAR and integrated photonics, the car can now create detailed profile of every object it encounters on the road. It's like giving a car superpower to see and understand the world around it. As the car continues its journey, it uses this constantly updating 3D map to navigate safely through the ever-changing environment. It can make split-second decisions, avoid obstacles, and keep everyone on board out of harm's way. Besides these two tools, cars also put a multitude of cameras to use in order to have extra distance calculation factor for optimal decision making. I hope now you guys understand how autonomous vehicles can see and sense the environment around them. Alright, now that the car can see and understand its surrounding, it needs to process all that sensory data to make smart decisions on the road. Now let's suppose an autonomous car is running on one-way lane, surrounded by vehicles coming from the opposite direction on one side and other vehicles moving alongside it on the same lane. The car's smart sensors such as LiDAR and cameras continuously collect information about the surrounding environment. They detect the positions, speeds and trajectories of all nearby vehicles, including those approaching from the opposite direction and those driving alongside our autonomous vehicle. The complex algorithms inside cars' onboard computer come into play. These algorithms analyze all the data gathered by the sensors in real time. They consider various factors like the relative distances, speeds, and the predicted path of other vehicles to understand the potential risk and safe options available. The algorithm follows a set of rules to prioritize safety and avoid any collisions. If there is enough space on the lane, the car may continue driving in its designated lane, maintaining a safe distance from other vehicles. The algorithms ensure that the car keeps a buffer zone and adjusts its speed to prevent any chances of accidents. In a more complex situation where the lane becomes crowded or the approaching vehicles are too close, the algorithms might make the decisions to slow down or even stop the car temporarily to allow safe passage for other vehicles. This is similar to how human driver would slow down and yield in such situations. The algorithms also continuously adapt to changing conditions. If there are sudden changes in the position or movements of other vehicles, the car's smart algorithms can quickly adjust the driving strategy to ensure safety and smooth traffic flow. Furthermore, the autonomous car can communicate with other smart vehicles on the road, sharing data about its movement and intentions. This communication helps create a collaborative driving environment where all the vehicles work together to avoid conflicts and ensure safe driving. Currently, we don't have complete autonomous vehicles on the road, but intensive research is going on in the industry. However, even the partial autonomous vehicles have also come a long way. As much as these vehicles drive on the road, they keep learning and improving themselves. I mean, have a look at this footage of Tesla Autopilot visualizing surroundings and making decisions. This is quite magical, isn't it? But there is more to come.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth. So let's start with overview of EV industry. Do you know friends that the electric vehicle industry is a rapidly growing sector that produces vehicles that run on electric power rather than traditional fossil fuels like gasoline or diesel. EVs are powered by rechargeable batteries that store electrical energy and convert it into motion, offering a more sustainable and environmental friendly alternative to traditional vehicles. EVs are important because they have potential to significantly reduce greenhouse gas emissions and improve air quality, which is critical for mitigating climate change and improving public health. Traditional vehicles are a major contributor to air pollution, which can cause respiratory and other health problems and are also responsible for around 15% of global greenhouse gas emissions. By contrast, EVs emit no tailpipe emissions and produce lower emissions over their lifetime, depending on the source of the electricity used to charge them. In addition to their environmental benefits, EVs offer other advantages such as lower operating costs and reduced dependence on fossil fuels. EVs are typically more efficient than traditional vehicles, which means that they can travel further on the same amount of energy, thus reducing overall cost to ownership, as they also require less maintenance and have fewer moving parts, which means that they can be more reliable and cost-effective in the long run. The growth of EV industry is also driven by government support, including policies such as tax incentives, subsidies, and regulations to reduce emissions from vehicles. Many countries have set ambitious targets to phase out the sale of traditional gasoline and diesel vehicles in the coming years, which is likely to further boost demand for the EVs. Overall, if I had a say, then the EV industry represents an important and exciting shift towards a more sustainable transportation with the potential to improve public health, reduce emission, and create new job opportunities. With that being said, I hope so you would have got a fair idea regarding the overview of EV industry in today's scenario. Now let's move forward and understand the types of job in the electric vehicle industry. The electric vehicle industry is a rapidly growing sector that offers a wide range of job opportunities across various fields. And here are some of the types of jobs available in the EV industry. First one, if I talk about, is engineering. Electric vehicles require a wide range of engineering skills, including electrical, mechanical, and software engineering. Engineers are responsible for designing and developing the different components of an electric vehicle, such as battery, motor, and power electronics. They are also responsible for testing and validating the performance of the electric vehicle components and ensuring compliance with safety standards and regulations. The second one, if I talk about, is manufacturing. As the production of electric vehicle increases, there is a growing demand for workers in the manufacturing sector. This includes jobs such as assembly line workers, quality control technicians, and logistics and supply chain management. Manufacturing jobs in the electric vehicle industry requires specialized skills, including knowledge of electric vehicle components and assembly processes. The third job is of sales and marketing. Electric vehicle manufacturers and dealerships require sales and marketing professionals to promote and sell electric vehicles to the consumers. This includes roles such as sales representatives, marketing managers, and customer service representatives. Sales and marketing professionals in the electric vehicle industry require knowledge of electric vehicle technologies, market trends, and consumer behavior. Fourth one is infrastructure development. If I talk about infrastructure development, as the electric vehicle market grows, there is an increasing demand for the infrastructure development such as electric vehicle charging stations and grid management. This includes roles such as electrical engineers, project managers, and energy system analysts. Infrastructure development professionals in the electric vehicle industry require specialized knowledge of electric vehicle charging technologies, electrical grid management, and renewable energy sources. Fifth one is the research and development field. Electric vehicle manufacturers are constantly working on improving the performance and efficiency of their vehicles, which requires extensive research and development. This also includes roles such as scientists, researchers, and development engineers. Research and development professionals in the electric vehicle industry requires specialized knowledge of electric vehicle technology, battery, chemistry, and material science. There is one more additional job which is associated with the booming of electric vehicle industry is of education and training. As the electric vehicle industry continues to grow, there is a growing need for education and training programs to develop the skills and knowledge required for working in the industry. This includes roles such as trainers, educators, and curriculum developers. Education and training professionals in the electric vehicle industry require knowledge of electric vehicle technologies, adult learning, principles, and training methodologies. Overall, the electric vehicle industry offers a wide range of job opportunities across different sectors, with the potential for growth and advancement as the industry continues to expand. Jobs in the electric vehicle industry requires specialized skills and knowledge and offer the opportunity to make a positive impact on the environment and society. Now let's move forward and understand skills and qualifications needed for a career in electric vehicle industry. The electric vehicle industry is rapidly growing, as we all know, and it offers a wide range of job opportunities with a diverse set of skills and qualification. The industry encompasses various fields such as automotive engineering, software development, marketing, and sales. So if you are interested in working in electric vehicle industry, here are some of the skills that you would be required. The first one is technical skills. The electric vehicle industry is primarily based on technology and it requires people with technical skills. This includes expertise in electrical engineering, mechanical engineering, and software development. You may need a degree in electrical or mechanical engineering to work as an electric vehicle engineer or a software development degree to work in electric vehicle software development. These are some of the technical skills that you would require. The second one is that you would require a knowledge of battery technology. Electric vehicles are powered by batteries, so it is essential to have a good understanding of battery technology. This includes knowledge of battery chemistries, charging technologies, and battery management systems. A degree in chemistry or physics or material science may be beneficial for the same. Next is, you should also understand the electric vehicle charging infrastructure. Electric vehicles require a charging infrastructure to operate, and it is essential to understand how the charging infrastructure works. This includes knowledge of charging station types, charging protocols, and grid integration. A degree in electrical engineering or energy management may be very useful for the same. The fourth one is you would be requiring a project management skills. Electric vehicle projects involve multiple stakeholders and require effective project management skills. This includes the ability to manage budgets, timeline, and resources. Project management certification or degree in a project management will be very helpful. The fifth one is the marketing skills. Marketing and sales skills are very important in this industry. Electric vehicles require effective marketing and sales strategies to increase adoption. This includes understanding customer needs, developing market campaigns, and managing sales channel. A degree in marketing or sales may be very useful to excel in this industry. The sixth one is the communication skills, which is very important. Effective communication is an essential skill in the electric vehicle industry, particularly when working with multiple stakeholders. This includes the ability to communicate technical information to non-technical stakeholders and the ability to work in multicultural environment. A degree in communication or related field may be beneficial. The next one can be your passion for sustainability. The electric vehicle industry is driven by passion for sustainability and reducing carbon emissions. So if you are interested in working in electric vehicle industry, it is essential for you to have a passion for sustainability in the world. Now let's study the qualifications which are required for you to excel in the field of electric vehicle industry or to make your career in the same field. The first one is you could have a bachelor's degree in engineering. A bachelor's degree in electrical engineering or mechanical engineering or another relevant engineering field can be helpful for a career in the electric vehicle industry. Then you should have a master's degree in engineering. A master's degree in engineering can help you specialize in the specific area of electric vehicle industry such as battery technology or power electronics. The next one is master's degree in business. A master's degree in business can be useful for a career in management, marketing or sales in the electric vehicle industry. Next is you should have the relevant certifications. Certifications such as Project Management Professional Certification, Certified Energy Manager Certification, or other industry-specific certification which can demonstrate your expertise and commitment to the field. And finally, you should have a relevant experience. A relevant work experience in the electric vehicle industry or related field can demonstrate your skills and qualifications to potential employers. Overall, while qualifications are important, skills such as technical expertise, project management, marketing, and communication skills are just as crucial for a career in the electric vehicle industry. I hope so guys, you would have got a fair idea regarding the skills and qualifications needed for a career in the electric vehicle industry. Now, let's move forward and let's discuss the conclusion of our today's session. The electric vehicle industry is a rapidly growing field which offers a wide range of job opportunities for people with diverse skill and qualification. From engineering to marketing, there are many different roles to play in this industry. Technical skills, knowledge of battery technology, charging infrastructure, Project management skills, marketing and sales skills, and communication skills are some of the essential skills which are needed to make a career in the electric vehicle industry. A passion for sustainability and desire to make a difference in the world are also crucial factors for success in this industry. You could have qualifications such as bachelor's or master's degree in engineering or business or relevant certifications and relevant work experience which can also be beneficial. However, skills and expertise are just as important in the electric vehicle industry. So it is essential to focus on developing those skills as well. As the world moves towards a more sustainable future, the electric vehicle industry will continue to grow and provide opportunities for those interested in making a positive impact on the environment. By developing the necessary skills and qualifications and demonstrating a passion for sustainability, you can build a successful career in the electric vehicle industry.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth.
So let's start with what is EV? An EV is an abbreviation for an electric vehicle. EVs are cars that are partially or entirely powered by electricity. Electric vehicles have minimal operating expenses since they have fewer moving parts to maintain, and they are also very environmental friendly because they consume little or no fossil fuels, which means no petrol or diesel. While some EVs employ lead acid or nickel metal hydride batteries, but lithium-ion batteries are currently regarded as a norm for modern battery electric vehicles since they have longer lifespan and are exceptional at retaining energy, with self-discharge rate of only 5% per month. I hope so it's clear to you what is an electric vehicle. Now let's move to the next part, which is career opportunities in electric vehicle. The EV industry is expected to provide numerous work possibilities for the trained candidates. Research, design, development, production, vehicle maintenance, and infrastructure development are all the major profiles in the EV industry that required skilled workers. As previously said, there are several employment needs in the electric car business. There are few. So, the first one is research and development. To improve battery charging, recharging, technology, fuel, all material sources, the electric vehicle industry requires a research and development team to recognize the latest technologies and concepts that are emerging globally. The research and development team conducts electric vehicle technology research and testing. Typically, chemists and material scientists test and analyze the battery life. Material scientists also assist in the discovery of novel materials to replace the existing materials. The researchers conduct numerous studies to develop fast charging technologies in order to make electric vehicles superior to the conventional vehicles. The research and development team, on the other hand, contributes to the advancement of different aspects of battery charging, electric car materials, and battery fuel utilization. People with backgrounds in chemical and material sciences can take advantage of this job opportunity in the electric vehicle business. Chemists are well versed in the chemical qualities, reactions, compounds to utilize in battery charging, and a variety of other fuel and chemical substances. With this knowledge, they conduct several studies to find alternative eco-friendly chemical usage in the batteries as a fuel. The chemist's major priority is to collaborate with other engineers on the batteries. Similarly, material engineers focus on electric vehicle materials. They investigate the various properties of material and attempt to implement a new material product using the existing one. They strive to create strong materials that are yet lightweight and environmental friendly. Material scientists and engineers strive to create the best material, and hence they are getting the best components in the electric vehicle.
Now, we will discuss some of the major job responsibilities in the research and development. The first one comes the chemical engineers. Chemical engineers are mostly concerned with improving the design and production of the EVs. They work with the batteries and are concerned with the composition of battery fuels, their chemical interactions, and development of new eco-friendly batteries. The second one is electrical design engineers. As the name implies, they work with the electrical components. They concentrate on the essential work of the electrical circuits in automobiles and allow gas engines to charge. They also work on the HVAC systems, lighting, and digital displays. And the third one is the material engineer, which they strive to create strong material which are lightweight and environmental friendly. I hope so. It's clear to you what's a job role in an research and development would require and what kind of candidates with the background of chemical or electrical or even the material engineering can join the research and development team. Now, let's move forward to the next domain, which is manufacturing. Now, if I talk about the electric vehicles manufacturing, the manufacturing team is responsible for machine design and production design. They put together labor and machinery tools. Machinists, industrial managers, machine tool operators, equipment assemblers are among the specialist workers who are needed in the EV manufacturing sector. Now, if I discuss the major job responsibilities, it includes the industrial engineers which supervise the workers and ensure that the activities run smoothly. The computer controllers are necessary for manufacturing of EV materials. They make plastic and metal components as well as the critical elements. If I talk about the electrical and the mechanical engineer, they work basically in together to put diverse electric vehicles together in a single line production. They focus on enhancing programs and automated technologies to boost productivity and speed up the production, while general assemblers work on electric vehicle parts which are not electrical or mechanical. I hope so. It's clear to you what's a job responsibility is required in the manufacturing of electric vehicles. Now we will move forward and we are going to learn about the third, which is design and development. Everyone who contributes to the initial vehicle modeling phase to the final developmental process is included in the design and development sector. This industry typically employs engineers, software developers, industrial designers, technicians, and drafters. They find cost-effective and result-oriented solutions to the automotive problems. The design and development team seeks to create automobiles that are accessible to all individuals from wealthy to middle class to low income households. Chemical, electrical, electronic, mechanical, industrial engineers, and software engineers and designers are in high demand for this industry career opportunity. Now let's discuss the major job responsibilities associated with design and development. The first one is the chemical engineer. Chemical engineers mostly focus on improving the design and production sections of EVs. They work with the batteries and are concerned with the composition of battery fuels, their chemical interaction, and development of new eco-friendly batteries. If I talk about the electrical design engineers, as the name implies, they work with the electrical component. They concentrate on the essential work of electrical circuits in automobiles that allows gas engines to charge. They also work on HVAC systems, lighting, and digital displays. And if I talk about software engineers, they are mostly involved in applying the computer application theories to develop and analyze software applications. They work with the industrial design engineers on the electric vehicle components and enhance the production process of these vehicles. I hope so. It's clear to you what the job responsibility in the design and development field is of the electric vehicle. Now we will proceed forward and we are going to understand how engineering students in particular can start career in EV. Hands-on experience working on an engineering problem linked to EVs can help a student attain a requisite fit for the industry. Students can obtain hands-on experience and ace the job selection process by doing the following things. The first one is the projects. A modest project such as constructing an energy-efficient DC-DC converter for an EV application can demonstrate a candidate's suitability for the post of R&D engineer. Making a project necessitates an awareness of the overall vehicle design and allows students to fine-tune their conceptual knowledge. Electric vehicles are being built by college students across the country for the project work. Internships can also be extremely beneficial since they allow you to work closely with engineers on the live projects in the industry. Students learn how to solve practical technological challenges while also getting a sense of corporate culture. Research project and teaching fellowships are both valuable contribution to an engineering student's skill set. For example, a mechanical engineer can learn about embedded systems and work on developing hardware for the battery management systems. Try to get knowledge on the hands-on experience and on the subjects depending on the chosen job description, you can get your chosen job. And the final thing is the certification. You can acquire certification from an institute such as Coursera, Udemy, or Intellipaat, which provides a particular course in the electric vehicle design and development. Now, I'm going to tell you about the Intellipaat certification program. This program basically aims helping learners to develop a strong knowledge of electric vehicle design and analysis concept. This course is an advanced certification program targeted toward an enabling next generation of sophisticated automobile designers and EV enthusiasts. So, who can apply for this certification? Basically, the freshers and engineering grads. Then, mechanical and automotive engineers, systems and network professionals, electrical engineers, and also non-IT professionals can take this certification program. I hope so you would have got fair idea of who can apply for these certification programs. Now, let's proceed further and let's talk about career transition from ICE vehicle to the electric vehicle. So these guys who are into this domain, basically here engineers with the prior industry experience have a valuable and developed skill set. These practical abilities are valuable because they are not taught in the textbooks and must be learned via experience. An example of such talents would include an overall understanding of the automobile business, domain standard operating procedures, supply chain management, and customer behavior. And when it comes to working with these electric vehicles, such automotive abilities will be equally crucial. When interviewing with the electric vehicle firms, professionals should emphasize these softer talents. Professionals who also have been in certain professions for many years need to review some basic electrical and electronic engineering ideas before transitioning to the EV realm. Then you can add certain good projects and your relevant experience, or also go for certification to transition into electric vehicle design and development program. So I hope so it would be very easy for the guys who are looking to do career transition from ICE to EV. Now we will discuss how to skill yourself for a successful career in the electric vehicle. There are numerous options available today for upskilling or reskilling oneself and building a good profile for a profession in the EV arena. The first one is, if you are at home and you are looking for a certification program, you can go for. So you can skill yourself, but the first way is you can go for the online courses. Informative and thorough courses created by teachers from the world's top universities or colleges are available on the internet. Example includes NPTEL's Introduction to Electric Vehicle, Coursera's Introduction to Battery Management Systems, and Udemy's Free Introduction to Electric Vehicles. So you can go over these courses and you can skill yourself and learn a little bit about electric vehicle management, the battery management system, and the electric vehicle design and development. Then you can also go for learning softwares which are used in the automobile sector. Professionals in the automotive industry use softwares such as ANSYS, Creo, GOMSpec, and others. Working on or learning about them can provide you an advantage during company interviews and the job selection process. And finally, you can look for contacts on the LinkedIn. Contacting people who are already working in the field on LinkedIn and get advice on what skills you should learn to have a successful career in the EV market. In this way, you can always upskill yourself and you can have a successful career in the EV domain. Now, I want to discuss the current scenario of the electric vehicle industry. According to the experts, they say that firms such as Tesla, Ola Electric, Mahindra, and TVS Motors are making strategic top-level hires in accordance with their business strategies. As Tesla firms has its plan to roll out its first all-electric car in India this year. Ola Electric is also stepping up its effort to develop an electric car. Ola Electric has already hired 9 times more people in the last year, and it expects to quadruple its workforce by the end of the year. It has increased hiring in the areas like artificial intelligence, big data, and analytics, app development, and IoT. The EV push will raise demand for the sales and service support, resulting in a 12 to 15% rise in employment generation across the pre-sales and also post-sales in the EV ecosystem. Aside from the increase in the direct employment at manufacturing side, the thrust is having an effect in the component space. Increased local battery manufacture will result in a 15 to 18% increase in the employment for skill set such as product design and development. According to the experts, this would result in jobs for specialized activities such as product design of lithium-ion battery packs, product design and drawings of various software, target products ready to sell to the end product design such as battery packs. So you can expect a very great demand for the electric vehicle industry, and there are a lot of jobs which are going to come up in the future.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth.
First of all, let's talk a bit about electric vehicles. The term itself reveals its true essence. In simple terms, it's a vehicle powered by electricity. Lithium-ion batteries are used in EVs, which contain cathodes and anodes that helps in charging and discharging of electricity. Cathode is used for charging, whereas anode is used for discharging. This extraordinary mode of transportation gathers the power of electricity to move itself forward. In essence, an electric vehicle is a wondrous creation that operates mainly on the energy of electrons. Now, let me tell you guys why EVs are the future and why they are important for sustainability. Basically, electric vehicles are comparatively best because they don't emit harmful gases such as carbon monoxide, carbon dioxide, sulfur nitrogen dioxide, etc. that play a major role in greenhouse effects, which in turn causes global warming. Basically, electric vehicles are comparatively best because they don't emit harmful gases such as carbon monoxide, carbon dioxide, sulfur nitrogen dioxide, etc. that play a major role in greenhouse effects, which in return causes global warming. Global warming could be a really big issue if not taken care of, as increasing surface temperature of Earth could cause the extinction of living organisms. And as we mentioned in the beginning itself, electric vehicles do not emit harmful gases, which makes them a great asset towards an eco-friendly and sustainable future. Alright, now let me move on further to the batteries of electric vehicles. We will try to comprehend the notion of battery management system and the purpose it is meant to serve. Electricity in an electric vehicle is stored with the help of a battery which acts like power banks. But small tiny cells will not be able to move a huge vehicle, right? Hence, to power the entire vehicle, all individual batteries are taken and joined together using attaching terminals. This formed structure of different individual batteries is known as a module. Now, a number of modules along with a sensor and a control unit further forms a pack. Basically, the energy stored in these packs is further used by vehicles to run a vehicle engine. But wait, what's the purpose of battery management system when the process seems so simple? Let me elaborate about that a bit. Every battery has its own state of charge and state of health and requires a lot of maintenance in the background. Battery management system is an essential component to ensure optimal battery performance and safety. Usually within a pack, numerous cells with different capacities make it challenging to monitor individual cell performance. Factors like temperature, current and voltage influence cell behavior. If we are considering 10 cells in a module, and even if one cell is not performing well, then it can affect the performance of the entire module. All lithium batteries generate a lot of heat when charged. It is always a disadvantage when batteries heat up. Some of the disadvantages are non-uniform charging and sometimes explosions. Maintaining heat is a crucial part. Not only this, if a cell is charged with an imbalance in voltage and current, it could result in shortening of battery life and explosions. In order to keep our batteries healthy, we need to manage the temperature and the flow of voltage and current, and this could be managed with a battery management system, where we have thermal management and charge balancing to tackle this problem. Thermal management involves managing heat flow within the battery pack, vital for safety and performance. Temperature sensors and coolants, like water or air, regulate heat to maintain efficiency. Sensors are attached, which helps in sensing the heat and cooling the battery down with the coolants. Next, we have the imbalance in charging, which can be resolved by the charge balancing technique. Imagine a scenario where one battery in a pack charges and discharges at a different rate due to manufacturing defects. To maintain this, charge is transferred between cells, equalizing the charge distribution and ensuring optimal pack performance. This can help all cells to charge and discharge at the same time. To conclude, the battery management system is like a guardian for the battery in an electric vehicle. It monitors and controls various aspects of the battery such as temperature, voltage, state of charge, and energy distribution. It prevents overcharging, balances the cells, and ensures the battery operates safely and efficiently. The BMS plays a crucial role in extending the battery's lifespan and maximizing its performance. Since this field is comparatively new, the research for optimizing BMS is still in the phase of evolution. There is more room for improvement in the coming future, but in essence, BMS is going to be a crucial factor to optimize battery lifespan and overall performance of an electric vehicle.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth.
So MathWorks is the organization that is providing you with the beautiful product or the software MATLAB and Simulink. And every year it update the software, and every year you can expect two products or two versions of MATLAB Simulink from the organization. So last year, usually it comes with the terminologies like 2022A version, and later by the second half of the year, it goes by the version of 2022B. So this year it came by 23A, and that's the recent version which we are working on. You can see it over here, right? What's the latest release of MATLAB and Simulink? So many of you might be having questions like, what is MATLAB and Simulink, and whether it is two different softwares. It is not two different softwares. So one thing which you need to understand is like, it's basically like the two sides of a coin, head and tails. Okay. So MATLAB is an interface which you can work on to enhance your skill on programming side, or let's say it is called M scripting. Basically, programmers can work on that interface. And Simulink is a interface which, or environment in the same software which you work for modeling and building the system design. And there are other sub interfaces as well, or subdomains as well, like SimScape, Stateflow, etc. We will be looking into all these aspects today, just like an introduction part. Okay. So MathWorks is the site. I should say that MathWorks is an organization which provides a product, and this product is actually being used for all kind of mathematical computing software or mathematical computing applications over the globe. So it's worldwide product. Even in aerospace, starting from low level application, or let's say simple mathematical modeling or calculation, starting from that to even aerospace application, this product is very much useful. So this product is actually applied, or let's say relied upon a variety of key industries. As I have mentioned, software and internet can use it, railway systems can use it, even in semiconductor devices it is used, energy production it is used, then it can be used in communication, uh, even in biotech and pharmaceutical companies, which companies or the domains which need simulative environment or simulation, they can use this product completely. Okay, and it also provides a student version. You might be knowing it for certain universities, or you can actually download the student version or a trial version from the organization or from the website for free, and a trial version exists for 30 days. That's called a student version. Now, what are the key characteristics of MATLAB and Simulink software? So, MATLAB stands for Metrics Laboratory. Basically, it is used to analyze data, develop algorithms, and it is kind of a high level programming language used for development of algorithm while you work with a certain product or a system. For example, we can take the EV, right? So we know that the battery is a combination of many cells connected together as a battery pack or a module. Then the battery is integrated with a power converter or power modulator. Then power converter consists of a lot of semiconductor devices. Then that is integrated with a motor unit or motor drive, right? So a lot of integration is happening among the systems or between the systems, and that's how you build a product or develop a product. So you need multiple level of numeric computation aligned with each system. If you are working on battery, the battery itself will throw you a lot of mathematical computation, right? You have to model the battery completely. Then you have to check whether it is providing you the expected results. So basically, this software is used in a one-dimensional way or one-dimensional modeling, where you use it for the simulation purpose or creating a virtual environment for testing your product. Now, what is the advantage of going for a virtual environment? We already have discussed, like some of you might be knowing who have attended my previous classes. Rather than going for a hardware or development of a product directly, you need to check whether this product is working fine or not.
Let's have a quick quiz question, guys. Which of the following is a widely used product by MathWorks for numerical computing and programming? AutoCAD, Photoshop, MATLAB, Microsoft Excel. Please mention your answer in the comment section.
You can modify the product according to the results it is throwing in the software. For example, if you are working on a motor drive system, you have already configured the system and you have given certain values over there and you are trying to simulate it. Simulation means you are checking whether the product works or not, or whether the system works or not in a virtual environment. All other parameters you have given will be similar to a hardware setup. Now, while you're simulating it or while you're checking the performance or functions of the system which you have developed, let's say there is a small error coming up, or there is a delta deviation regarding the results which you are expecting. If you have directly gone to a product development or hardware development, there it will be difficult for you to reiterate the results or build the model from the scratch, isn't it? So, in order to avoid that situation, to be very cost effective, we go for a virtual environment before you start with the, or before you make your hands dirty, before you start with the hardware development. That's why we are using a virtual environment to check the performance of your system, to ensure that, okay, everything works fine, you are getting the expected results, and all these data which you have manipulated or manifested from the software, from the product, can be used for developing the hardware with more confidence and more cost effective way. That's the reason we are going for a virtual environment. And for us, MATLAB and Simulink will give you wide extent of rebuilding your product. Okay, let's just go through this product one more time. I hope everybody have opened this site. It's simply like mathworks.com. When you scroll down, you can see like a lot of solutions. They are providing a lot of solutions and model-based development. And there are webinar videos. There are certain lecture videos, tutorial videos that is aligned with their product. And what are their product? It's n number of products. It's all related to mathematical computation. So the physical modeling, what I have mentioned, like the subdomain, you call it as SimScape. Then event-based modeling, like creating an algorithm, you call that interface as state flow. Then Simulink is something which is related to mathematical modeling of system. And you have other domains like optimization, database, code generation, system engineering, then embedded system, application development. So if you start learning with MATLAB, it's kind of a ocean, right? So you cannot complete learning it within 1 day, 2 day, or 3 sessions, or 1 month or 2 months. So it's been like around 7+ years I'm working with MATLAB and Simulink. Still I'm learning. When they upgrade their version, when they add more toolboxes, still I'm learning with the new toolboxes which they are adding. Similarly, it's kind of a continuous process or consistent process in which you keep on learn how to model your product in different perspective, or they will be adding a new feature similar to your mobile phone or a laptop or some app. There will be an extra feature that is coming up with the updated version. Same is applicable for MathWorks products. They will keep on updating their product, and you feel really interested to work on those products. So that's regarding MathWorks and their products. You can just explore this page completely. It'll take only like few minutes to explore the pages. If you go to products, you can just see the toolboxes which are added. So it even includes wireless communication, aerospace block set, everything. And you can even type here and check whether a specific model is available. Let me see whether I can provide you some idea regarding what are the tool packages or already developed models. So they also provide default models. Whether like the MathWorks engineers or MathWorks application engineers, they already have worked on certain products, and that is also available for you to explore. All right, so see, you can just keyword over here in the search bar, and you can just go and explore the videos and the lectures and the products which is available in this page. Okay, so this is one activity which you can do that will help you to have a good grip on the products that is available. All right, so that's about the MathWorks page. Now, what are the key characteristics of MATLAB and Simulink? So let's come back to the first position or first point where we were discussing MATLAB and Simulink as a single software. And I told that it is kind of two sides of a single coin. So there are certain characteristics that is aligned with MATLAB as well as Simulink. Now, MATLAB is a platform which is usually used for computation purpose or numeric computation. It can also be used for data analysis and visualization. So in terms of plotting or visualizing your results in graphical mode, or in case of plots, that can be done, or that is that is possible in the interface of MATLAB. So you do the programming, you write the code, or in terms of MATLAB language, you say you write the M script. And finally, if you want to see something over a graph, or if you want to plot your results, you can use the command plot, and you can use the variables which you want to see in a or visualize it. You will be able to see that. So data analysis and visualization is possible. And there are a lot of toolboxes that is related to signal imaging, or signal and image processing, then optimization, application development and deployment. So all these can be done with the help of MATLAB. Basically, I can call it as a language of technical computing. All it do is just computation. It just do mathematical calculation with the help of the simulation engine, and it will help you to go for any kind of application deployment, starting from a simple application like college project or simple software development or app designing, to even aerospace and defense. Now, what happens to Simulink? What does Simulink do? Simulink is more kind of a model-based development or model-based design, where you can visualize or you can play with the block sets, you can create block diagrams and visualize the result more in kind of a real-time testing. So this can also be used for code generation. It can also be used for creating the entire architecture of a product. So architecture meaning the way in which things are being connected or things are being integrated. So you can entirely build the architecture of a product, even into the level 1 part where you go and analyze how many components are there. You can start building from the component level, even to the the system level. So everything is possible in terms of Simulink. Stateflow is another interface where you work on event-based development. It can be called as a flowchart mechanism. So if you want to keep some algorithms in your system, let's say, okay, when input A is working, B should not work. Or if input A and B is true, the system should be giving out you positive signal. So in that way, some kind of flowchart algorithm can be integrated with the help of Stateflow. So keep in mind, MATLAB, Simulink, Simscape, and Stateflow can be the key words which you can play along while you're working with MATLAB Simulink software.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth.
Okay, so let's just take a quick note, or let's just go through what we have discussed regarding MATLAB Simulink. You can make a note of it if you need. MATLAB Simulink or MATLAB software is basically used for numerical and simulation and mathematical computation. It is provided by the organization called MathWorks, and you can do wonders by using MATLAB. And Simulink, basically, it is used as a visual design tool, which can provide you with a computational environment, and it also facilitates model-based development. Okay, so graphical modeling environment, I can call it as a visual or visual design tool, or I can call it as a graphical modeling environment. That's what MATLAB is about. And why MATLAB is required? MATLAB helps you with a lot of time-saving constraint where you can create complex circuits, complex products, or complex systems with the help of this tool. And you can also develop complex algorithm with the help of this tool. You don't have to do any calculation, or you don't have to put that load into your head. The simulation engine will help you to do all the calculation and integration with itself, and it will be helping you for the deployment or development and deployment of any of your products. So that is why we are going for MATLAB. And the fidelity of the software is also very high. Fidelity meaning the degree of accuracy, right? So if you're trying to build a model, before building the model, as I have mentioned, if you are putting your product in a simulation environment and checking it, especially in MATLAB Simulink software, the accuracy of result it gives you is kind of similar, like almost comparable with the hardware results which you will be attaining. So that's one reason we are going for MATLAB software. All right. So that's about MATLAB software. And okay, so if you have opened your MATLAB software window, this will be the first diagram which you'll be seeing. Okay, so there will be an editor, or there will be a workspace, and there is a directory which you can see in your left hand side, and there is a toolbar. So in the toolbar you can see multiple options where you can add new file, you can open new file, and you can save your file. Then lot other functions are there which we will be exploring in our later classes. So this is the first window that comes up while you are opening MATLAB. Okay, so let me just migrate to the actual version of MATLAB. Let me just help you with it. So mine is 2022A version, and this is the original window which I have, and this is the command window. This is the directory or current folder directory, and the workspace which I have. Now, what is the use of command window? Command window is the space which actually talks to the simulation engine from the user, or user can write the code in the command window, and the interface or the software will pick it up from the command window. It act as an interface, or it act as a medium between what the user has to tell the engine or simulation engine to do, or the compile the interpreter to do, that you can type it over here. So that's why we are using a command window. Basically, it is used writing down your program. Now, what is the purpose of the workspace? While you are writing your program, you will be using n number of variables, right? So this is a program. You cannot say that, let's say I have 8 number of apples, or Rahul have 9 number of apples. Even if you talk like that, while you are going for a interface of programming, you have to provide the values into a variable. So variable is that person who will be, or variable is that, black box will be holding the value, or what you are trying to implicate, isn't it? So that values which you are adding in your program, those variables which you are using in your program that holds a value, or a meaning, or a string, or anything, that will be displayed, or that will get saved into the workspace. So workspace is kind of a space where it will save the values of the variables which you are adding into your program. Now, current folder is kind of the directory from which you can find your files and open it. So while you're working with MATLAB, the files which you're working will be in the extension of .slx. So .slx files will not get opened, or you cannot use it like a image or a video unless the MATLAB window is open. Even the MATLAB window is open, you have to ensure that that particular file is under this current folder directory, then only it will be able to open. So MATLAB will search for the file only in the current folder of its own interface. Even if you have saved it in your laptop or system in your D drive, E drive, MATLAB doesn't mind it all. It will not take it directly from your folders. It will only be constrained to its own directory, and it will be finding the files or searching for the files from its current folder. So whichever files you want to open through MATLAB, whichever files you work on, make sure that you are adding the path into this current folder. So how can you do it? You can use the small arrows, right? So if you click on here, these are the folders which I have in my laptop. So I can click on any folders over here, and that folder will get added into the current directory. Now, if I have saved my files in a MATLAB folder, which is under the documents, I should be finding the files, or I should be aligning that file into my current directory here. Then only the MATLAB will understand, or MATLAB will actually pick it up from the files. And I can right click on it, and I can even check whether this is in the path of my current directory. So if I'm clicking like remove from path, select folders and select subfolders, that means that you can see the opacity of the folder has changed, right? That means that even if it is showing in the current folder, this is not added into the MATLAB directory. Only if I'm adding it into the path of the current directory, then MATLAB will be able to find the files or open the files as expected. So right click on it again. You can see an option called add to path. Click on add to path. Then you will have a sub icon popping up, which is current folder. If I'm clicking on it, you can add it. Add path, select folders and subfolders. Now again, you can see it has been added. Okay, so while you're working, or whenever you are working with MATLAB and Simulink, make sure that the files which you want to open to your interface or to the MATLAB Simulink software environment should be added, or the path should be added in your left-hand side under the current folder. All right. So command window is kind of a paper or a canvas where you can write your program, and that helps for you and the simulation engine or the software to communicate each other. Whatever you are writing it as a script over there, that will be picked up by the interpreter. Workspace is a space where you save your variables and the values. Current folder is the path or directory through which the MATLAB will search for the particular file you want to work at. It will help you to open it or work with it. Unless you are adding your file in the current directory path of your current folder, MATLAB will not be able to find the file or open it. Okay, and there are a lot of other options over here. So if you want to open a new script, you can click over here. You can just see and edit it. This is again the same, like you can just type your programs over here. So this is again a canvas, or let's say a paper, white blank paper, where you can type your program over here. Then if you want to open any previous files, you can just open it from here. And live script meaning it's like it will be giving you live interaction with the scripting part. Run and time means you can click on it and simulate your program. So all these icons we'll be just exploring in our next session in detail, where we explore with MATLAB. And here you can see a little person sitting on top of it. So he is Simulink, right? So he is actually the other face of MATLAB. If you want to open Simulink, you can just click it over here. You can see that interface is starting. Okay, now this will take you to another window where you can see other options, like if you want to open a blank model, a blank subsystem library, etc. So all these subsystem blank library, we'll just see how to work on it in our Simulink session next Sunday. Let's just work on the blank model now. So blank model is something which is related to a canvas, or it will open you to a white canvas or a white space where you can start working on your project. So I'm requesting you to just go through your command window, current folder, and workspace. Just have a good look at it. You don't have to start working with it. Just have a look at it. See that, okay, where you can find workspace, where you can find the current directory, where you can find the command window. How does the window looks like? The introductory window or introduction window of MATLAB, how does it look like? And where you can find the Simulink, click on the Simulink icon, click on blank model, let the model open. So while you're downloading the toolboxes, I'm suggesting you to go with MATLAB and Simulink toolbox. So initially it was different, like Simscape Essentials were the block which I started using. It's called Simscape Essentials. Now I think it's compiled together to MATLAB and Simulink blocks. To toolboxes, it can be as per your requirement. Suppose if you are working in a communication domain, if you wanted to build your product in digital electronics or communication, you can just go through the toolbox and download it. For trial version, it expires within 30 days. You can use your email ID to download it. And for that, I suggest you go for the basic package, like MATLAB Simulink Basics itself will be enough. While we start exploring it more, you will get to know it in more depth. And later, if you want to go for a licensed version, you can purchase it from the organization itself. Actually, it's quite expensive. So if you want to continue, you can just go for a licensed version, or you can download it again, like the trial version is downloadable. But every time after 30 days, it is it's expired. So after the software expires, you can use your email ID, or if you have other email ID, you can use it to download it. Again, it hopefully it will be accessible again. Yes, so while installing, definitely you should be like downloading both, right? MATLAB and Simulink both packaged together. That might be the reason you might have missed it. So if you do not have Simulink, no worries, or try with this shortcut, type Simulink. If you are able to open Simulink, then well and good. If you are not able to open, please observe. You can make note, and later after the session, you can re-download the software one more time, and there you can add Simulink toolbox. Okay, so coming back to my MATLAB window, I would like to show you a few demo, very, very simple and very, very basic demo to provide enough proof that what current folder and workspace will be doing. All right, so we are going to have a small mathematical formula. Let's just understand, or let's just align a value to x, type x equal to 3. I'm just typing x is equal to 3 in my command window, and I'm just adding a semicolon. So semicolon is usually used when you want to end the statement. All right. So there are certain commands which you should be aware about while you are working with MATLAB, and semicolon is one such command which help you to end the statement. So basically, it means that you are assigning a value to x and you are stopping it over there, like full stop. So MATLAB is a software, unlike C programming, where it will be reading all the codes line by line. So if you look at C programming, what does it do? It's kind of a compiler, right? It read the whole code as a one, and then it will execute it together. But MATLAB is something like it read it, so like all the codes are read one by one. So if you forgot to keep a semicolon as an end of statement, if you keep enter in order to type the next line, what does it do? It will throw you the result directly saying that, hey, x is equal to 3. So we didn't finish our coding, right? So we didn't finish our complete tool or statement that, okay, I'm going to do a mathematical formula. X is equal to 3, y is equal to 4. I want z is equal to x plus 3 plus 5 or something. But before that itself, if you want to write the next line, if you are not putting a semicolon, then the MATLAB will throw your error because it already read your code, or it already read the command which you have given, and it is giving you the results. Okay, so always if you want to go for a coding, like if you do not want an immediate results, or if you are not looking forward some variables or something, just have a semicolon at the end of your statement. So I'm just typing it again. I'm just typing x is equal to 3 semicolon. Now if I'm pressing enter, it will not throw me a result. Now I am just giving one more value, y is equal to 5 semicolon, enter, and is equal to x plus y. It's a very simple statement. So here I'm not putting any semicolon because I wanted to see the answer. And what happens if I press enter? I'll get the result. No, I haven't put semicolon after space. It's the just the next character. So this is command window. I just changed my configuration setting for maximum visibility for you. That's the reason you are seeing it in wider screen. I have my current folder over here. I have my workspace also over here. So this is my command window. Okay, what I have done is like I have given simply I have typed x is equal to 3 semicolon, y is equal to 3 semicolon. So after x is equal to 3, you can press enter. And as a practice, if you want to see how does this work, you can also eliminate semicolon and type enter. So what does it do? The code is immediately read by the interpreter, and it will be like throwing you the results. So let's avoid that. So once you are done, now look at the workspace. So I'm just showing you the workspace over here. Can you see the values of the variables which we have given there? X is saved as 3. Y is saved as 5. Z is saved as 8. Now the purpose of workspace might be clear. So workspace is that space in the MATLAB where it will be using in order to store the value of the variable assigned. So it need to remember the value, right? So let's say you are writing an exam, a maths exam. You might be having a scribbling paper with you, or you will be writing down, okay, x is equal to y, or even in your meetings, like if you are working professional, in your meetings, you'll be scribbling now the MOM. So there is a certain space used by you. If you are assuming you are the compiler or you are the simulation engine, you will assign few values, or you will note down the key important point for that particular process to complete. And that space, you call it as a workspace. So Z value, which is the answer, that is also being shared here. So later, if you want to assign something, okay, so let me just take something else. I'll just go for one more point. So I will write A is equal to Z plus Y again. So let me check how does it come. See, so from the workspace, the MATLAB actually, or MATLAB simulation engine or interpreter or it found the value of Z or Z, because it was saved in the workspace already. And then when I wrote my next command, it took the same value and it gave me the result. Clear? Just practice this. You can use any variable. There is no restriction that you should be using x is equal to 3, or you can also just take any kind of variables and also values. Whatever we practice in command, it will show in workspace. Whatever values you are assigning it into variables, only the values that will be saved into the workspace. Okay, so one command I told you is semicolon. Okay, so if you are not putting semicolon, then as I have mentioned, that statement will be considered itself as a command and will immediately execute the command. Otherwise, it will be kind of a sentence which is half spoken. Okay, we didn't complete anything, but still we got the results. Something like that. Interpreted it in that way. Now, I want to clear everything. So I just, okay, I understood x is equal to 3, y is equal to 5, etc. So I'm going to work on a different program. Now I have to erase this part. Similar to we erase our paper and pen, or we make more space for the program to work on, or maths to work on, formulas to work on. I want to erase this space. So what I do is like I'll type CLC. Can you type? And if I'm pressing enter, I cleared my command window. CLC. CLC. Great. Now check your workspace. So I'm just showing you the workspace over here. All the variables are still staying. I told my MATLAB interface or command window to clear off or provide me with more space, but my workspace didn't listen at all. He is still having the values which have been saved. So after I cleared it, again I'm typing x is equal to x plus y. Simply I'm typing. See, it is giving me the same result, right? Because I already had the value saved over here. Or let me just, give a different formula. B is equal to, so I didn't initialize any other variable. X and Y is not initialized now. Let me just clear it again. Okay, so this is a blank page I have. I'm just writing B is equal to, I have few variables in my workspace, right? I'm not going to write it again. I'm just writing X minus Y. See, I'm getting my result. Why? Because what did the interpreter do? It read the code and it already had the values of X and Y saved in the workspace, which I didn't clear off. So it immediately gave me the answer. Okay, so this is basically kind of a storage space. The workspace is a storage space which adds all, or which saves all the values of the variables. So even now I want to clear the command window and I want to clear the workspace also. So I cleared the command window with CLC. I want to clear the workspace. What I do, I type clear space all. Can you do that? Clear space all. So your all, or the word all will be highlighted in purple color. Now click enter. So in visibility, nothing happened, right? And there is no magic happen now. But let me check my workspace. So the magic actually happened in the workspace. The workspace variable got cleared completely. Okay. So let me do it one more time. Let's have a practice. Okay. I like X a lot. I don't know why. So X is equal to, I'm just putting 56 semicolon. So for those who are following me, this is asterisk. This implicates multiplication. Okay. So if you are putting slash, it implicates division. Okay. Okay. I'm done. Okay. Okay. Now I'm going to do my magic. I'm going to look at the workspace. I have how many variables like Z, Y, X, S, A. I have all my variables over here and I'm going to clear it off. So I'm typing clear all, clear space all, enter CLC. That makes my magic complete. So I just cleared off my command window as well as I cleared off my workspace. I'm just addressing the previous question. So let me write a few variables again. y is equal to 5 again, and a is equal to x plus y plus 5. Okay. Then I just wanted to know how many variables are here. Assume that I have written 100 number of codes or 100 number of lines of codes. It's just 3, but here we are assuming it's like 300 number of codes. And I forgot how many variables I have used. Now I have to assign a new variable. So out of the 26 variable, I have used a lot of it. Now I want to, give it a different number. So what I do is like, I wanted to check how many variables I have used in this code. I'll just type who. Who is that? Knock, who is that? So it will throw me the option like, okay, you have used A, X, Y, and Z. Now I wanted to know how much is the size. So I'll again type knock, whose. Type who, just type a few lines. Type who and whose. So the size is like 1 by 1, right? It's just, what do you say, a bit. And how much does it occupy? So all these int values and all, I'll explain it in our later. So for now, just remember, if you want to understand how many variables you have used in your lines of code, you can just type who and it will throw you the result, and whose, it will throw you what is the size as well. You can also type close all. That means like if any windows or many applications are being opened, everything will be closed and only this window will be open. Okay. Yes. So I wanted to type something. So just type along with me. A space is equal to square bracket 2 space 3 space 3 close bracket. Okay, please type along with me. You can use any variable. It can be X, Y, Z, SB, whatever. I just used A. And you can type 3 numbers or integers here. Do not put semicolon. I'm going to call it now. Enter it. So this is a row matrix. So this is how you can initialize a row matrix. Now, if you want to add or I want to have a column matrix, when you work with more numbers for calculation, again, B is equal to 2 semicolon 3 semicolon 3 close bracket. See, this is a column matrix. I can also get a column matrix by putting a transpose. So if I'm typing A and an apostrophe, which actually means transpose, that give me the column matrix form of this A. Square bracket, you can just simply type it from your keyboard. You can find the key over there. With curly braces and square bracket, there will be a key function shift. Use the key shift and just, add the square bracket. Unrecognized function error, that might be due to some space or anything. So let me just retype it again. X is equal to square bracket. I'm just typing a few numbers with space, close bracket. If I'm clicking on enter, that will give me a row matrix. If I'm just clicking X and adding a transpose, click enter, that will give me a column matrix. So there is no option that you can load your deleted data unless you have saved it as a M file. So MATLAB scripting, you can save it as a M file, .m file, and you can just safely load it in your system or laptop. And after you can close it, and when you come back the next time, you'll be able to open it from your current directory. Otherwise, if you're just clearing it off, it's kind of a temporary space which we are using. We are not able to gain it back. Zaid. This is matrix addition. I have given values for a row metric, matrix H, then G, then I again gave a variable which is adding both the row matrix, and this is what I got. Okay, if I want to have the column matrix S transpose, Okay, it will be giving my answer in a column matrix. All right, fine. So let's just clear it off. This is just a first step or level 1 understanding regarding. Oh, did you mean clear or? Yes, I meant because I have used a uppercase over here. MATLAB is just scolding me. So clear all CLC. I just cleared my command window. Just multiplication, division, addition, subtraction. You can practice for initial familiarization purpose. You can also just check with row matrix and column matrix. That will be enough as of now, today. Then we'll quickly jump into Simulink. We'll just have what does Simulink offers. The introduction window like this, where you have the directory, the editor, command window. The editor and command window is like both. You can just add your script over there. If you are just typing in your editor, your option or answers can be viewed in the command window, or you can directly work in the command window, no worries. And you have workspace where all the variables are being saved. So if you want to load array of values also, that is possible. Then your editor will be called as array editor. So this is something which is called plotting, right? So you can see figures over here while you are writing the code and working with the code. And the variables and things which you have saved over there will be saved in the workspace. Again, you can see the size of the data which you have load as well. So this exercise will be doing, no worries. And how MATLAB is different from other programming language, you do it like if you are not adding end of statement semicolon, it will be immediately reading the code. So the interpreter translate the source code like line by line. So if you want to complete the coding, you should be adding semicolon. And every time you are writing one line, it will be immediately picking up the data from it. It's very flexible and it has a wider extent of programming. Then a C program is something like it will translates the entire code and then run it together. So that's the main difference between MATLAB and C program. All right. So what does Simulink do? So Simulink is something which will help you to create models, or it works on block diagrams or model-based development. You can provide a modeling environment with continuous time, discrete time, hybrid systems, like battery systems, anything, and it will be kind of block diagrams which you'll be using it. So Simulink contain a set of block libraries or block of components in which you get it from the library, and then you develop your entire system or product with the help of these blocks. So these blocks will provide you with an environment or with an option to configure the values, then simulate it, then revisit, reiterate the values, then a variety of test method is possible with the help of the Simulink. So where you can use it in physical system, in control algorithms, in filters, in semiconductors and sensors, whatever possible. Okay, so it's kind of an extensive or kind of extensible feature, or it's a very flexible custom feature which you can develop. And it also supports the integration and custom different domain as well. For example, if you want to work on a certain product in mechanical domain and you want to integrate it with the electrical domain, that is also possible in Simulink. Okay, so model-based development is usually done in Simulink, and now we are going to see how does Simulink work. So if you're not Simulink, no worries, just observe what I'm doing, write it down in pen and paper, and then we will, start with the modeling part. So to revise what I have done from the MATLAB screen, so this was my MATLAB screen. I just migrated to my Simulink interface with the help of this button. You can see Simulink over here. So if you are not able to find it, if you already have installed the package, you can also type Simulink here in the command window, press enter. You can see suddenly another window popped up. From here, I can open blank model and I'll be able to get a screen similar to what I have shown you before. Otherwise, if you are again looking forward for installing Simulink, just go to add-on, get add-on, click on add-on, and in the search bar, please type Simulink. So the product will be appearing, and from there you can download it and add it into your existing software package. Okay, so I'm just typing it Simulink. So this is the package which you or tool box which you have to add it along with your existing MATLAB, which is simulation and model based product. So I have also sent you the product page in the chat box. You can just check. This is my blank model. And again, I have toolbars over here like simulation, debug, modeling, format, apps, etc. We will use each of it while we are building the projects and the products. As of now, the first part which you should be familiar is with the library browser. Imagine that you are going to write a book or you are going to write a test. For writing the test, what do you need? You have to refer other books. You have to refer the topics and answers. You read it, you understand the concept, and then you attempt a test, isn't it? Similarly, consider library browser as a library, similar to a library which we go for reading the books. What do we find inside a normal library? A lot of books for reference. Similarly, in the library browser of Simulink interface, you can find a lot of component, lot of tool packages, or let's say a lot of block sets, which will be helping you to build your product or which will be helping you to build your system. Click on the library browser. Just a single click. You need not do a double click over there. Click on it, a single click, and the library browser will pop up something like this. All these list of names are components which you can use for it. Imagine the heaviness of this library browser or depth of this library browser. You can have all and everything. Almost everything, which is like 99% of the tools and components which you are actually working in a hardware design setup, you can find it in this library browser in Simulink. Let's just get through this. So first one, you can see is a commonly used block. So commonly used block are like general blocks which will help you to build any product. Then it has the ground is there, then logical operator, an integrator, a multiplexer, mux is multiplexer, product means multiplier, then saturation block, a scope. Scope is a block which we'll use for visualizing the graph. I'll show you an example. Similarly, you can click on each of this tool set or block sets, and you can just see how many blocks are available. So everything is one or other way related to the mathematical operation, or you can even create a dashboard of your electric vehicle. You can create aerospace application. You can create whatnot like lamp or domestic circuits, whatever, with the help of all these block sets. So I was just talking about library browser. So what I did, I just clicked on this library browser. Once I clicked it, I got a list of components which is available. Okay, so I was just talking about the list of the components from here, which is commonly used block continuous, dashboard. So dashboard, you can just explore, like it can create an automotive dashboard or whatnot. And you can just go through it. Like you find it interesting with the terms which they have used and click on it and check like what are the block sets it has. Logic and bit operators like and combinational, then what, and, or, not. So all those here, then ports and subsystems. Sync means the output blocks which you will be using while you are creating certain circuit. So some of the blocks will be using it. So we'll not be able to use all the blocks, right? Because it's like hundreds of blocks available. We are not going to create hundreds of products over here. So we will be using certain blocks in our sessions. So later it depends upon what kind of application which you are deploying with. You can use other options. Like you have to explore these block sets as per your application setup. Familiar with powertrain. So powertrain, drivetrain components available. Then again, going back, sensors, right? What type of sensors are available? Then propulsion system. So it's all in the form of blocks, block diagram. Okay, so I'll quickly go through it 1 minute, and we'll just start with the modeling part. Like we will take the same formula which we have used for MATLAB scripting, M scripting, and we'll see like how is it being reflected into the Simulink interface. 1 minute, go through the library blocks and library browser. Okay. So let's just build a small model. Let's just begin with the modeling part of Simulink. So for that, I can do two options to get these blocks into my blank model. So I'm going to work in this blank model, and whenever required, as per my application, I'm going to drag those blocks or components and I'm going to integrate over here. So consider this as my workbench or the space you are going to work, and I'll take the components from other space and put it over here. That's what I'm going to do. So two options I have to drag these. Either I have to go to library browser, click on library browser, and I have to choose the components from the library browser itself, from these, and I have to drag it to my blank model. So first, for the easiness, I will start with the formula which we have used, or the uh, playtime which we have used for M scripting in Simulink itself. So I have used, if you remember, I have used the variable x, right? So I can write also over here. So there is a annotation box in your left hand side. You can see it over here in your left hand panel. There are small options or little options available. One is like magnification, where you can magnify your product. Then auto scale means that if you are working with 100 number of components, if you want to fit it to your screen, like to give you a better view, you can click on auto scale. Then other thing is like annotation, which I'm going to click over here and I'm going to write it. So my formula I'm going to use is like x is equal to 3, y is equal to 4. Okay, I want to see what is x plus y. So this is the formula which I'm going to start building in my Simulink. Okay, let me make it bigger. You can drag it. Okay, so you can just also change your size. I believe now it's more visible. Let me drag it a little bit, make it a little bit beautiful. Take it over to here. All right. Now, in Simulink, x is a constant, or it is the input which I am giving to start with my modeling. X is a constant, y is also a constant, and I'm using a mathematical operator here, which is addition. Just remember three things. X is a constant and it is an input. Y is a constant. Again, it is an input. So both X and Y are like constant, which has a value. Or let's say you are going to use a block, which is called constant, and it has a value which is 3 and 4. Then you have to do a mathematical operation, which is addition, in order to obtain the result. And how you are going to view the result? It's not just by clicking on the enter button, you'll be able to view the results. You should have a output block to view the results. So while you're modeling in Simulink, there should be input initialization of block, then output initialization of block. All right, so it will be more clear once we are starting with the modeling. So I can go to library browser, click on the library browser, and I can take the constant block. So what I'm going to do, I'm going to take I'm going into commonly used block. This is my block which I'm looking forward for my X and Y. I'm going to click on my right button, like mouse right button, drag it over here into my blank model. Either you can drag it. So you see my constant block that came to my black model, right? So if I'm just clicking on here, which is auto fit, it gave me a better vision. Like it made the screen a little bit more organized. That's all. So if I do not want this constant block, I'm just clicking on it. So if it is selected, it will be like throwing a blue border. That means it is selected. The block is been selected. I'm just clicking on delete. So it just got deleted. Again, I'm going back to library browser. So what I did is like, I just clicked on the constant block, a single click with my mouse, not right button, sorry, left button, and I dragged it. Otherwise, right click on it, add block to model. Okay, so immediately popped up. This is one option where I can go to my library browser and I can check for the blocks which I have to take for modeling this equation, and I can drag it to my blank model. Otherwise, shortcut is something like I can double click. I'm clicking left, double click on anywhere in the space, and if I'm familiar with the block name which I'm going to use, I'll simply type it like constant. Okay, you can see n number of blocks. I'm keeping constant. I got the block. Now double click on the block. It will open a different window where I can configure the value or add the value of x. So I'm considering this as x. And what is my x? X is equal to 3. I'm adding the value 3 over here. Apply. Okay, you can see the number actually changed. Now, I'm clicking onto here. I want to change this as x. Just select it, backspace, x. This is my x value. And drag it and keep it over here. So use your left mouse click to drag it anywhere and clip it over here. So I want y also. Y is also a constant. Either I can go to library browser, go to commonly used block, click on constant, right click on it, add to blank model. Or what I can do, I can just drag it to my blank model. Otherwise, I can double click anywhere in my workspace or blank model and I can type constant and I can get it. Or I already have the constant block. I just have to click control and I can drag it and make a copy of it. Okay, just press control key along with the left mouse button and drag it. You can make a copy. So if the people who are working with Simulink, if you are able to do this copy, please let me know by putting a thumbs up. Okay, control key. So click on the block with your left mouse button, mouse left button, then keep it, align with control key of your keyboard. Press control key, press the left button in your mouse, drag it. Okay. Otherwise, you just right click it, copy. Then again, paste. So this is very lazy, man. A lazy method. Let's just, interesting is like drag, 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 drag. Okay. So make y. So make sure you are having y. I'm dragging it. I'm just clicking it over here. Backspace, y. Let it be y. Double click on the block. What is the value of the y? 4. Apply, okay. So there might be certain other options. We don't have to use all these now, like interpret vector parameters as one dimensional. No, we don't have to use it. It's simple constant. And sample time infinity, we are not going to change anything because, we don't have any complexity in configuring this block. It's just a value. It's just an integer which we are assigning. So keep it very simple. Just go make the changes for whatever you need and come back. Okay. Okay, how to take constant? You can double click on the workspace and type constant. Then, you can just take the first block. Otherwise, go to library browser. Under commonly used block, you can just locate constant block, drag and drop it over here. Double click on it. Go here. Only the value has to be changed. You are not going to look at any of the complexities in the configuration over here. We are going to make it very simple because the model which we are doing is very simple. So change the value. Apply, okay, come back. So I'm going to delete this. I believe this is done. So these are input block, right? Because, from this block, the signal is going to flow. Now, I need something which is equivalent to x plus y. So what should I do? I should add this block with this block. So which block I should be looking at? I should be looking at an addition block, like add block. Double click somewhere in the workspace. Write add. Okay, let me check whether this will work. Perfect. This will work. Okay, this is my hero. I have taken this guy. Otherwise, go to library browser. You can definitely search in the search bar. Type your block name in the search bar. Click enter. It will search by its own. Okay, this is taking some time, but it will be throwing you the possible blocks, which is, similar to your keyboard. Okay, you're going to take an additional block. Simple. See, don't worry if you're not finding it, easy or it is getting confused or not. It takes time. Okay, no worries. This is a fabulous software. You will get interested more while you are practicing. You come up with a lot of questions, it will be getting more good. You can also take this block, sum block. Addition block is fine. Sum block is also fine. Both of it you can take. Okay, we'll do it with both. So I'm going to comment it out for some time. So commenting it out means that I'm not going to use it, but still it sits on my window or blank model. I'll tell you like how to comment it out and all. So you can take add block or sum block. Whichever is suitable, you can use that. All right. Now, what should I do? It's modeling. So you can see there are certain connections that is coming out from the blocks. So I have to connect it. Now I'm going to connect 3 plus 4. So ideally it has 2 icons, but it means that 3 plus 4. Okay, let me try to add only one symbol. Then what happens? I'll show you what happens. So I just double clicked on sum or add button. Instead of 2, I just made it 1. Like as per the mathematical operation, I'm just doing it 1. Now what happens? There is no space or no port available for the signal from Y to connect with X. That is the reason we have two signs. Okay. So you cannot interpret directly like you write a formula. Modeling is lightly tricky. Lightly. So if you get hold of that logic, it will be easy. Okay. So here 3 should be given into this block, or let's say 3, the value of 3 should be going into this block, as well as the value of 4 should be going. Inside this block, the addition happens. Okay. Yes. So let me just auto scale it. I'm not going to magnify it. Right. So I'm just keeping this guy away. Now, where should I see the result? Like what happens with my result? So this is like simply dragging. You can just click on the mouse, like left button, you can drag it. You can see a red signal coming out. This is also like dragging and connecting. Okay, I'm deleting it. See, click on here with the left button in your mouse, drag it, drop it. It will automatically connect each other. Now I want to see the result, like what is the value here. So there should be one more block that is helping me to see the result. So which block I should be using? It should be a display block, right? So I should be just seeing the display of the result. Okay, I just added a display block. Double click, you can click on display block and drag and drop it, connected. It get automatically connected. So what I have done, my X value, I have taken it as a constant. Y value, I have taken it again with a constant block. I used the add block, addition block, or you can also use a sum block. And from the output port, I have connected into a display box where I can see the value. How to create 2 input to add block? Double click on it. You can see list of sign. You can add n number of values. Like if I'm having minus, I'm adding minus over here. One more block actually, or one more port actually popped up, right? So here if I have one more variable like x plus y minus z or minus z, I can add that over here. So double click on the addition block and then you can add 2 add signs or addition signs over there. Okay, I believe that's done. How do you write x and y? Great. So just click on here, backspace, write x. Okay, click on here. Make sure you have the cursor over here. Backspace, y. Use of sum. Use of sum is for the arithmetic operation x plus y, right? We are going to model the equation x plus y. So for x and y to get added together, you need a block, extra block. The mathematical operation of addition is done by the blocks sum and addition. So sum also you can use. It's the same actually. So where is sum? Let me just search the guy. Okay. So here is it. Okay, he also do the same thing. If I'm just taking out a summer, I'll connect this guy and let me connect this guy to here. He also do the same thing. So you can also just make him rectangular, round. So if I'm making him rectangular, you will recognize him. Let me show you how does he looks like when he is rectangular. See, he's the same guy. So it's basically like same guy with a hat. So add or sum, you can use both blocks. It basically do the same thing. So you keep a hat, you get sum block, and you just take out the hat. It's like addition block. Or you can make it, okay, let me make it round. It looks a little bit, nice. So you can just do it. So this is sum block. You can also use add block. Both of them do the same purpose. Let me know once this is done. So we are going to see what is the value of x plus y. Okay. I believe this is done. Now, what I have to do, I have to run this model. I cannot click enter. If I'm keeping on clicking enter, nothing will happen. This is not an M script. Mathematical modeling is done using block diagram. Now I have to tell my compiler or simulation engine who is sitting over here. So he is called a solver. We'll talk about solver in our later classes. So this is the guy who is actually helping in compiling the data which we have given and providing us with the result. He is sitting in your bottom right hand side. Now he is called by the name variable step auto. He is called a solver. Output block name is called a display block. Display. Okay, now I have to tell him like, okay, chalo, it's like, trigger or simulate it. So where should I do it? I should run the model. How much time I'm running the model? 10 seconds, like the simulation engine will take. So it's not the 10 seconds for us. Like you don't have to count 1, 2, 3 to 10. This is the time bound of the solver to solve it. So it's kind of a parallel universe. Okay. So you are staying in one universe and the solver is in another universe, and both will have a time like difference in the time and dimension. So I have given 10. You can also give like 1 or 2 or whatever. The default value which you can find in your simulation or Simulink model will be 10. That's fine. Like let's go ahead and I'm going to run this model. Click on run. Now you can see something is changing here over. Okay. So it was very quick. Okay, let me run it one more time. Run. So see, it's very quick, right? So you can see. Okay, let me run it step by step. 1. See, it started compiling. So the machine actually, or engine, the simulation engine, which is this guy, started to read, okay, what are the input I have? What am I going to do? Okay, I need to collect the value of X. I need to collect the value of Y. Now I have to add it together. That's what this guy did. Now what did he do? See, in a step of point 2, he actually is compiling the input data which we have given. So this is a mathematical machine or mathematical solver which is reading the input which we have given and throwing you the result. So we are seeing it in slow motion. What is happening with the compiler? So you can click on step forward, forward, forward. You can see the steps are 0.2 seconds and done 1, 2, 3, 4. So you can see the time steps changing over here, right? Otherwise, if I'm just simply clicking over here, it's like in a snap of time, it's completely done. That's the time in which it is actually using for the simulation or completing the simulation. Now, the last block, this is called display. For people who have missed it, no, we don't need Power GUI here. It is actually running. So Power GUI is used when you are working on component level blocks. For the constant block or commonly used block, you doesn't need Power GUI. All right. We are seeing the result, which is 7. Good. We have done a good job by adding x plus y. So this is how you create the models over here. Okay. Now I need to create one more block, which I'm just, okay, let me make a copy. And I'm just writing it Z, and I'm going to write it 1. Okay, and let me just minus it. I'm adding a subtraction over here again. Okay, let me run it. See, my value changed. So now what did it do? X plus y, it took x plus y, then minus z. Okay, and it gave me the result. Now, if I want to visualize something, I can use a different block. So displaying is basically used for viewing numbers or integers, whereas if I have to visualize a certain plot, I want to see a graph, then I have to use a different block. So that block is called as a scope. See, these blocks are very common while you are using a Simulink model. Scope is the block which I'll be using in order to see the plot or result as plot. So I'm just, keeping a connection over here. So this block is called scope and I'm connecting it over here to my output signal. So if you are just, changing the values like this, click on apply OK. No, it will not change because nobody is aware that you have done the change, right? Simulate it again. Run it. Now it is changed. Okay. So I have kept a scope block and I have connected to my output signal. Now what I am expecting is like I would like to see a plot. How does my 5 looks like? So just imagine I don't know how does a 5 look like. See, it's a small point over here because it's just a value, right? So because it's a small value, it's just showing like, okay, this is somewhere over here. Instead, let me just, take you through a sine wave block. So I'm just creating a sine wave. Okay, I don't want this one. I go for, yeah, this one. So sine wave, I took a block called sine wave. It should be looking like this. How did I do that? Right, like double click on it. I typed sine wave. So this one is, so look at the path also. There are different types of sine waves available. So take the sine wave from Simulink sources or you directly go to library browser and you go to source and from there you can take sine wave. Where is sine wave? Or sine wave or pulse generator, whatever. It's like I would like you to just see something, see some signal in scope. You can take anything, repeating sequence or pulse generator or step signal, sine wave, whatever you like. It should be a dynamic block. Okay. I'm just connecting it to the scope. Let me try to run this. Okay. I ran it. Click on the scope. See, I got a sine wave. So scope is basically used in order to provide you with a plot. This is the x-axis, which is always time. Sample-based time is 10 seconds, meaning that you have simulated the model for how many seconds? 10 seconds. And what is your y-axis? The y-axis value is picked up from the sine wave block. See, amplitude is 1. So this is the same thing which is being reflected over there. Let's change it to 2. Apply OK. Look at scope. Okay, the maximum value has been 2. Okay, so scope actually helps you to visualize your signal and display will help you to get the value of your signal. Okay, that's the difference.
Let's have a quick quiz question, guys. Which component in DC motor is responsible for producing a magnetic field within the motor? Rotor, armature, commutator, stator? Please mention your answer in the comment section.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description below and take a first steps towards a career growth.
So what does MATLAB do? The full form of MATLAB is Matrix Laboratory, and basically the software is used for numerical and simulation computation where there is a solver in the interface or the software which helps you to calculate or find the solution for any kind of complex problem or complex mathematical computations which you would like to do as a part of your product or a system which you are developing. It is a very friendly, user-friendly interface where there is no complexity in using the software. You have to just be familiarized with the commands which you are using in M scripting and the blocks which you are using it. So anybody can master it within very short duration of time. It's just the practice you need, the right time to practice, and right logic that has to be applied while you are practicing some models that will help you to go through the software in a very smooth way. N number of applications are there regarding MATLAB software, starting from simple calculator even to aerospace application. This software has been used. It is a very, very helpful tool for the industry. It is completely an industry-driven tool where it will help you for the entire simulation of your product. So why we are going for simulation? Because virtual environment and adding your product well and before you start building the product in hardware helps you to understand the performance of your model, as well as if you want to reiterate any values or reconfigure the values, or if you want to make any changes regarding your input, that is also possible while you are going ahead with the virtual environment setup first. Later, if you want to add any more performance result, that is also possible. So all over, you can understand the entire dynamics of the system which you are building. Then you can finalize the model, finalize the product design, and then go ahead with the actual hardware setup. That's the reason we are going ahead with virtual simulation. And this is the interface this is the first introductory window which you will be seeing while you are opening your MATLAB screen. And here you have the directory where whatever files you are saving or when you are working on the program, that folder should be added into this directory. Then only the MATLAB will be able to those files and run it and give you a solution. So if that files which contains your program is not saved or added into the directory, the current directory, then MATLAB will not be able to fetch that file and give you the result. So that is the reason we always have to make sure the path of the product, right? So path of the product should be something like this, like you should be adding the folder over the directory. This is the editor space where we as a user will be communicating with the software, where we will be just adding the commands and we will be asking the simulation engine to do what we prefer. If you are starting with a coding part or if you're building a product, if you want to plot the results, whatever you want to do in a coding language, you are going to type it over the editor. Command window is again one such space where you can just type the lines of code over here. But if you want to save it as a file, then you'll be using the editor part. And workspace, something where you can see the values which has been assigned to that variables, it's been saved. And if you're just working on a mathematical problem also, the solution will be visible in the workspace. We discussed that this is kind of a storage space while you're working with a problem, where it will give you the visibility of what are the values that has been assigned with each variables. I believe this is clear. And yeah, so there is something called array editor. We'll see what is array editor and how this has been taken. And while you're plotting or while you have written a program which actually needs to be visualized as a plot, this is how it occurs, like some figure or plot will pop up while you are running the program. And you can just simply go ahead and plot any values. Now, what is the difference between MATLAB and other programs? The MATLAB will be reading the code line by line. So it will be executing each line and then it will be reading the next line. But in case of a C program, the program will be considered as a whole. So the compiler will be considering the entire code once and it will be a single run. But in MATLAB, you have the flexibility to add a semicolon which terminates the statement. If you are not adding a semicolon, that means that the MATLAB will immediately print the results of whatever codes which you have written over there. That is the main difference which I could tell you. And MATLAB is more kind of flexible, where you can keep on adding 100 number of codes, and you can also add breakpoints where you can debug each line by line and understand where you have gone wrong. So for working on the M script, so M script is a technical term we use for the coding or the codes which write over the MATLAB file. So .m is the extension we use while we are saving the file. So M scripting will require certain commands and syntax. There is a certain syntax in which you have to write the code, and you must be familiar about the common syntax. Like if you want to clear the workspace, if you want to clear the editor, what will be the command, and if you want to plot or if you want to see some random numbers, there are certain syntax and commands which we are commonly using. Now, later we saw regarding the Simulink part, where we opened a blank model and we tried to visualize the addition or the arithmetic operation between two constant block, and we added a display, and we also checked with the scope results where it can provide you a visual design that we have done in Simulink. We also have seen how does a library looks like. So inside library, there is one more tool set called Simscape. So Simscape, I'm not covering, we'll directly go into programming. We are going to jump into MATLAB programming, as everybody is like excited to work on programming. It was just an introductory session and we were not having that much hands-on practice on the tool with a few examples. So we'll start with our examples regarding MATLAB basics. So first example which we are going to do is we are going to provide simple equations. It is going to be a simple equation or calculator, which we are going to add few values according to the formula. And we are trying to print the values according to the formula. And we see like how does it look like how you can build a simple calculator in MATLAB. And we also will try to plot the values and we'll try to label the plot. So that is the first exercise which we are going to do now, right? So this is your introductory window. Just open the MATLAB and you can just clear if you have practiced earlier, if is there any variables which you have saved or anything which is remaining in your command window or editor, you can just clear it off by adding a clear all command here. And you can also just type CLC, that will clear everything. Please be ready with a MATLAB screen. So we will start with a simple calculation by 7:15. So what is the difference between editor and command window? See, command window, you can write the code, you can do the coding, but if you want to save the file or run the file while you are printing a value, or if you are writing like more than 3 or 4 number of lines, then it is not possible to save the file or run the file properly. So before running the file, the simulation engine will be asking you to save the file. So that will not be possible while you are typing in command window. So command window can be used as if you want to print the value, or if you want to check the values of a variable, that can be used as an interface. Better we go for an editor if you really want to write the code. Okay, so I believe like majority of you have okay, opened it. Okay, some of you are facing problem in opening the editor. So if you do not see the editor over here, go to new. You can see the toolbar over here, right? I believe my mouse pointer is visible to you. Please look at the screen for a minute. If you are just looking at your MATLAB screen, please look at my screen for a minute. And you can see the toolbar over here. You might be in home, plot, apps or something. So just go to new script. Okay, so if you are in home tab, go to new script. That will add a script over here. Otherwise, you can directly go to editor and you can click on new script. Both are same. So you have to add or you have to open a new script. That's what is needed. So I'm just doing the same. So here I can click on new script. That will add one editor over here, or you can directly click on here. I believe you are ready. Great. So most of you have given me a yes to go ahead. Okay, guys. So let's start with our first program. So this is going to be a very simple calculation. I'll give you time to write the code in your screen. So initially, I'm just requesting you to write down the code in a notebook, or if you are good to remember the code, that is also fine. You can just look at the logic and then you can go and type it in your window. Okay. So I'm just going to start with a very simple calculation. So always I recommend to write a comment when you are writing codes, because once you completed the code and after a month or so, if you want to come back and look at the code one more time, if you have written 100 lines of code or 50 number of lines of code, then at some point you will be doubting yourself, and you might not be having a clarity regarding, okay, what was this step, right? So I suggest you, it's like in your initial coding practice, you just write the comment like what you are going to do that, and what does each step means to you. It will be easy for you to decode it. Okay. So for writing a comment, or otherwise, if the interface doesn't have to read it as a program, what you have to do is you just type a percentage symbol. So I'm writing a percentage symbol over here, and I'm just writing something like simple calculator. You can see my screen is, or the letters I have written or the sentence which I have written is green in color. That means that the simulation engine or the interface doesn't consider it as a line of code. It is simply considering it as a comment or a text, a simple text. Okay, so I have written percentage symbol. I have just typed percentage symbol and I have added a comment over here like I'm going to do a program with simple calculator. Now, if I'm just removing it, you can just see I just clicked on here. I made my mouse pointer, and when I clicked on backspace, see the mode or nature of the program changed. Right now the interface is actually reading it as a program. So if I'm just writing something over here and trying to run it, definitely it will throw a error, because the interpreter or the compiler will not be able to understand what I have written over here. I haven't assigned any variables. I haven't assigned any values. So I'm not going to, the compiler will not be able to read or understand what do you mean by simple calculate. Okay. So I'm just again going to add it as like comment or a text or a line, which I'm just simply writing like what is my um, line of code means. So I just clicked on end. So I'm going to just give a value, and since I'm very interested to write about voltage current, I'm going to assign a value to a variable which is called voltage. So you can also use a variable called V, or better, since we are practicing it for the first time, I suggest you to go ahead with the full name itself. So it will be easy for you to read. So I have written voltage is equal to a value which is 5. Now, what should I do? I should add a semicolon over here. Now, second, I'm going to write like my current value is equal to, let's say, 0.1. Okay, again, I'm just adding a semicolon. And next, I'm going to write my power value. I'm just going to use this as a simple calculator. What should I do? I should just, write the name of the parameters which I have already initialized in the command window. So if I'm just writing or typing half of the command, the interface itself or MATLAB itself is asking me, hey, whether are you going to add voltage, or I can see a prompt where it is providing a suggestion to me. Okay, are you going to consider the parameter which is voltage? Yes, I'm going to consider the parameter which is voltage. So I'm going to just add it over here. And I'm going to, what is the equation of power? Voltage into current, right? So I'm going to give an asterisk over here and I'm going to write current. Okay, so this is a very basic calculator I'm going to run. So if I'm just click on enter, okay, now this is done. So I'm going to find it to run. Okay, so how should I run it? I can just go to my editor plot and I can just try running it. So when I'm running it, or when I'm just clicking on the run button, it is actually asking me to save the file. Unless and until I am saving the file, I will not be able to get the answer. So I am writing it like simple example. So I should not keep any space, because if I'm just keeping a space over here, the file will not be saved. Let me show it to you. So I'm just adding it like simple example, and where I would like to add it, I'll just add it over here in the folder. Okay, let's say in MATLAB. Okay, I'm going inside and I'm just adding it over here, which is called MATLAB. Or also, like, I can go into any of my document. I can just create a new folder and I'm adding it. I'm just simply adding it in the code. So if I'm just saving it over here, see, it is asking me that MATLAB will not be able to run the file because it is not the proper syntax I'm using to save the file. As I have mentioned, the extension of saving the file is .m, and I should not be keeping any space over here. Rather, I can keep a underscore. Underscore will work for me. So I'm just adding an underscore and saving it. Okay, that got saved. But again, as I have mentioned, I should add this file into the current directory. Then only again the compiler will be able to fetch the program and run it and print the results. So I have to add, or I have to either add it to the path or I have to change the folder. So change the folder means the folder which I'm using over here is not in the path of, or the program is not in this folder, right? I have just saved it in a different folder. Now I have to change the folder over here, and then let me try to run it again. So you can see the entire folder actually thrown up here, right? So all my folder is visible over here. Now what I could see over here, it gave me the result. Now what is the power? What is the value of the power? It is 0.5, and you can also see that the value of power is being saved into the workspace. Okay, so this is very simple calculation. So first, add a text or add a comment like what you are going to do. It's a simple calculator which I have done. You can also provide it like, okay, power equation or voltage equation, whichever is convenient to you. Use the percentage symbol so that it becomes a comment. And then after that, click enter. You can provide a variable voltage, assign a value. If you are not adding semicolon, then immediately MATLAB will print the results. Rather, you can add a semicolon, then you can add the current value. So values are not mandatory. Whatever I have used is like random values. You can use yours. So instead of power, you can also just calculate resistance. What can be the formula over there? So let me just write it again. So I would like to calculate resistance, right? So I am again writing is like voltage by current. Okay. Okay. I'm again running it. Add to path. Okay. I got the value of resistance as well. So if you look at your workspace, I could see the value of current, power, resistance, voltage, everything is being saved in your workspace. How to run the program? So you can see there is a run button over here, right? So go to the editor tab. So in the toolbar, there is home, plot, app, editor, publish. Go to editor and you can click on the run button. So before you say, if you haven't saved the file, it will ask you to save the file first. So save it in a folder which is convenient to your, create a folder for dumping all your practice files into there. Then add the path. Okay, Vineet, I believe that answered. So Vineet, what is the first step after opening MATLAB? Okay, so I think we are far behind. So open the MATLAB and then you open a script. So you go to here, new, open a script. So that will help you to open a new script and you start writing the program. Now, I want you to look at something. See here, when we typed voltage, right? Or let me type it again. So when I'm typing voltage, can you see something like the size of that variable is coming up? It is showing like 1 into 1 double. So double is a data type in which the MATLAB is actually storing that variable. And 1 into 1, what does it mean? It's kind of a matrix, right? It means that the value which we have assigned to the voltage or the variable voltage is a matrix of one row and one column. That is what it means. That means, again, whatever values we are assigning into a variable, everything is being considered as a matrix. So you can assign multiple values for voltage, and you can, consider it as a matrix also. Now let's do that exercise. Go back to your problem. Okay, click on the value which we have written as voltage. I have clicked a square bracket. I have opened a square bracket. You can see why I have opened a square bracket, because I want to write a matrix. Okay, so I'm going to write a matrix, meaning that I'm going to assign multiple values to voltage, the parameter voltage. Initially, we have assigned only one value, that is 5, but here I'm going to assign random values 5, 10, 15, 20. Now, how the MATLAB will be, or how MATLAB will be reading it, this is again a matrix, right? So if I'm typing voltage again, okay, it is not showing the 4 variable. It is still showing the previous variable which we have saved. And in the workspace also, it is the same value. That means that I haven't run the program, right? So every time when you are making changes in your code, if you want to overwrite the data, you have to run it. Now let me run it now. What you are expecting, or what I'm expecting, is an error. Okay, so see, what happened? The error didn't throw up, but I could see the voltage value has been overwritten. Right now, I could see the new values which I have given, and see my resistance value is also a matrix. Surprisingly, what did the MATLAB do? It actually acted as a simple calculator where, how did I get resistance value and power value? 5 into, the value of 5 multiplied by 0.1 give you this value, power value, right? And the value of 5 divided by the value of current will give you the resistance value. So each time my MATLAB calculated the value of resistance and power, and it gave me a matrix, or it gave me the results in matrix itself with the value of current, even though I haven't provided current value as a matrix. The MATLAB was able to do the mathematical operation, right? Multiplication and division was done by MATLAB. Now I have 4 values of resistance, or 4 different values. So ideally, how should I read this program? When I'm changing the voltage, let's imagine I have a voltage voltmeter, or I'm just having a voltage source, and I have a current source. My current source is a fixed current source, or a constant current source, where it is providing the value of 0.1 only. Imagine I'm just changing the voltage knob, and now the value is 5. Now I'm getting a respective, or like corresponding value of power and resistance. Now I changed it to 10. Then I'm getting a corresponding value of resistance power. So in that way, you have to interpret the line of code. Okay, is that clear? You can just try changing the value of voltage, and please run it. Unless you run it, it will not give you or overwrite the data. And you can also see the results have been printed in your workspace, right? And sorry, not workspace, command window. And you can see the name of the program is also being printed over here. So every time you are running, you'll be able to see the results over here. Now, next, what I'm going to do is, like, if you have just changed the values as a matrix, I'm going to add current also in matrix. I'm going to see like how it, I wanted to go for a matrix addition or matrix multiplication. I'm going to add random 4 values to current also. So I opened a square bracket. I added the value of current. I'm just adding semicolon, and I'm going to do the mathematical operation. Okay. So I repeat, first we have just assigned the value of voltage as 5. We gave the current value as 0.1. Then we gave the formula like power is equal to voltage into current, and resistance is equal to voltage by current. When we run the program, we got the output was saved in the workspace. Then I wanted to explore where my MATLAB will be able to print the results if I'm just changing the voltage into a matrix, meaning that I am going to provide multiple values, and I'm going to see whether what is the result I'm getting, like resistance and power. That's what you're seeing in the workspace now. I got the results in a matrix format itself. Okay. So how does this matrix look like? So let me just type resistance. See, the resistance is 1 into 4, 1 by 4 data type of double. So data type, we'll see it later. Don't worry about it. So 1 by 4 meaning what? It's like a 1 row and 4 column, right? So it has 1 row and 4 column metrics. That's how the MATLAB is interpreting the data. Now, let's just do the calculation again. So finally, what I have done here is like I changed my current values also into a metric format. I have given 4 values to my current random values. You can give any values which you like. I have given 4 random values. So my voltage is 1 by 4 matrix. My current is now 1 by 4 matrix, and I'm going to try with the multiplication. Like I'm going to try with the same calculation. So let me run this. Hey, I got the error. So if there is an error in your line of code, you can actually view it in your command window. See, as a programmer, or if you're working on MATLAB Simulink, if you are encountering an error, first thing you should do is like read the error and understand the error. You should not panic that your code is not working. You should not ask for help. You should not call technical support. You go through the error because MATLAB provide you a clear cut information about what went wrong about your line of code. Okay. So let's just read it over here. So reading and understanding of error is the best practice you can do to improve your coding skills. Okay, it means that error using asterisk. Okay, and where does the error persist? It persists in the line 4. So this is my line 4. I'm requesting everybody, please look into my screen. Please, for a minute. If you are practicing along with me, please give it a pause and please look at my screen. So error using asterisk, using the operator asterisk, like multiplication. What I have done is something is not correct. Incorrect dimension for matrix multiplication. Check that the number of columns in the first matrix matches the number of rows in the second matrix. Number of columns in the first matrix, which is the first matrix voltage. So that is 4, right? 1 by 4. And have I given 1 by 4 matrix over here as well? Yes, my current is also 1 by 4 matrix, right? So it is 1 row and 4 column. That is correct. Now, to operate an element, operate on each element of the matrix individually, use dot asterisk. What does it mean? It should be an element-wise multiplication or element-wise mathematical operation that should be done. I believe you remember the matrix multiplication and arithmetic operation which you have done in your college days or school days. What do? You just go element-wise operation. You will not consider the matrix as a whole and do the calculation. You will take one element from the first row, first column, then you add it or whatever calculation you have to do. You take the corresponding element from the second matrix, which is a B matrix. Here it is a current matrix. So for that, this should be a dot product, right? If I'm using a dot, or it should be kind of an element-wise operation, which I should have given the syntax of dot. So where should I give it? Over here. Now my operation should be working. Again, simple line 4. So 4 line is the problem, like, power is equal to voltage into current. So I cannot give a complete matrix operation. I should be providing it as an element wise operation. That was a mistake. So this mistake, okay, let me run it. Let me see. Okay, so now what is happening? I got the result for power, right? So power has been reflecting over here. I think the matrix operation is completed. Can we check whether this calculation is correct? The first element-wise operation is like 5 into 0.1, 0.5, correct, right? And then 10 into 0.2. 2, my power value is also correct, but it didn't change for resistance. Now, what is the issue for it? See, resistance value didn't change because the resistance value was not actually run by the MATLAB. It didn't even consider the operation that actually happened, right? So let me like overwrite it again. What did I do? Again, I added a dot here. So this is like element-wise division. Now, if you look at my resistance value, yes, the element-wise division happened. And for each value, since due to the variation of the values which I have given, I'm getting resistance 50 because I have given, such kind of pattern in my voltage and current. So my total resistance stays same, right? So while you are doing or while you're going for a calculation with multiple number of variables, it should be element-wise operation. It should be element-wise division, multiplication. For that, you should be doing a or adding a dot over there. So it should be like dot product and dot division. Okay, I'm just adding a comment over here. Multiplication and division using matrix operation. That's what we have done so far. So I can write it like in any length of comment. I can write it over here, or I can just write it somewhere over here as well. It doesn't count. It doesn't matter. Okay, because this is not going to get added into the program. MATLAB will not be taking into consideration of any of the comment which I'm giving. This is just for your information. See, just go there, click on your mouse, and you can make the editing. It's simply like you edit a Word document. Click on the mouse pointer over there. Vasant, run option will be available. Can you check editor? Like go to the tab editor and check. See, look at my screen. In your toolbox, there should be an editor option over here. Click on editor and there should be a run option. If there is no run option also, you can just go ahead with run and advance in the matrix operation. Now I'm going to plot it. I would like to see how does my plot looks like. So how should I plot it? I should write plot. Oh, sorry. Plot is a command which I'll be using definitely to plot my variables. And I have opened a bracket where I will be adding the variables. So which are the variables I would like to plot? That's what I'm going to type over here. So let me type it in single braces. So single braces means it will help to identify the parameters and it will help me to plot it. So look at my screen and you can type it simply like plot is a command and you open like a bracket and you just use single quotes for adding your parameter. Whichever parameter you want to plot, you can add it and you can just view it. You can also use double quote, but like it's a good practice. You go for single quote. Okay, voltage, comma, current. So these are the two variables. Okay, my voltage spelling was not right. Okay, and current. Now I would like to see it in a different color. So I can also give colors to my plot. What should I do? Again, I should just add it color, meaning that I'm going to color my plot in single quotes. Okay, I'm going to color it red. Okay, let me color it red. Okay, let me see whether this runs. Is there any error? Okay, syntax error. Something is wrong over here. Line 6. Okay. Okay, invalid expression, missing multiplication operator, unbalanced delimiters, construct matrices. Okay, what was wrong? Did I use anything? Oh, there is a syntax error again. Invalid expression. No, I don't need any multiple operators. Okay, plot. Okay, is there a closing needed? Missing a closing. Okay. Might be needing a closing. Okay, let me just check with my codes. Okay, so here I didn't add. Let me run it. Okay, again, I should be just providing. Let me see whether I should give a comma. Okay. Okay. Again, it's not. Okay, there is something wrong with my syntax. Let me write it again. Not. So if anybody is getting the answer, please let me know in the chat box. So if you are able to see the plot of your voltage and current, let me know. So I'll just type plot voltage. Okay, so this is something related to the plot function. Okay, the plot function is not working. Let me just check with the already existing program. Okay, for that it is working. Okay, for some reason my plot looks okay. Yeah, so I think my plot came. Okay, this is the plot I'm getting. And I can just, drag it. And I could see that, okay, this is my voltage and current. Okay. So for many of them, it's working. Single resistance, okay. Great. So people are getting right. Okay, so I believe my plot is visible now. So you can also add labels to it. So how should you add labels? Let's go back to the program. Okay, so the X label. X label is you can just add X axis, whatever it's your X axis. So let me call it as voltage. Okay. Again, you should be using the quotes voltage, and I'm going to provide a semicolon. Then Y label is my current. Semicolon. Okay. I'm going to turn on the grid. Okay, grid on, meaning that you can see the lines actually. Okay, and you can also like plot resistance is equal to voltage by current or power versus resistance, whatever you want to plot, you can plot it accordingly. So this is a program I have written, and I think I already have the plot. Okay, can you check whether the X label and Y label actually worked? Can you see your voltage and current which has been labeled? Okay, so this is something like I'll keep it. Now I'll be able to see the label. Okay, so this was one of the program which we have done. So I would like you to just go ahead with a similar program where you can just add any of the equation like torque or speed characteristics or anything, and you can just try for the practice. See, if you're typing, just one thing which you should be looking at. If you are just keeping X label and Y label before the plot, that will not provide you the x-axis and y-axis label. So if I'm just keeping x label, y label before the plot, if I'm running it, my you know my plot will not be providing me the x-axis and y-axis. The names are not projected because the final line is like plotting, right? Only after plotting you should be able to name it. So my structure or construction of the code is different if I'm providing or I'm writing the code of x and y before. First you plot, then only you provide the labels of x-axis and y-axis. Okay. So after plotting, you run it. Now you will be able to create a grid. Okay. So I'll jump on to the next one, which is for loop. So you can just copy the program. You can just write it or anything, right? So how do you want to visualize the plot? In that way, you can provide your code. So if you want to visualize it like voltage in x-axis, you give it like x label voltage. Or, okay, let me just, I'll try to inverse the plot. So here I'm going to add current in my x label and voltage in my y label. Now I can see like what happened. Okay, every time I type different, my code ran, it seems. So here, since it was like directly proportional, it didn't make much change. Current and voltage was linear, right? So, but the labeling changed. So it depends like which parameter you're plotting and how you want to visualize it. You can add your X label and Y label. Okay, so let's just jump into the next syntax, which is or the command which is called for loop. So how can you use a for loop or what is the use of for? So what I'm going to do is like I'm going to type clear all and CLC, clear all and CLC. So that clears everything. Like if something is there in my program that clears, let me just clear the workspace. Okay, clear all CLC. Everything is gone now. Code performance. That is okay. Fine. Let's go ahead with for loop. So for loop is something which is interesting. So instead of like explaining what is for loop, let me just jump into the program itself. So I am going to assume that there are 5 lights which are turned on in my room. Okay, that's my statement. I want light 2 to 4 to be turned off, or let's say dimmed, turned off. I'll go into it turned off. So 5 lights are there which are turned on in my room, and I am going to control, or I am going to write a program so that my lamp or my lights, light number 2 or lamp number 2, 4 should be turned off while I'm simulating or running the program. Okay. Now for that, first I should initialize the starting light and the ending light that should be turned off. So starting light, which one is that? So light 2, right? So light 2, I'm initializing it like, okay, light 2. That's my second light. That is a starting light. Or I'll just write it like starting light. Starting light is light 2. Now ending light, see, don't put space there, then the code will not work. Ending light equal to 4. Okay, there also I initialized something. So my starting light is 2 and my ending light is 4. I'm going to turn it off. Just by printing the results from 2 to 4, I assume that I have turned it off. Now I should be using the command for starting light to ending light. Okay, see, this colon actually means that 2. It essentially means you are fetching the data from starting light to ending light. Okay, so this essentially means starting light to ending light. Okay, that's what that colon means. Can you just type the code for me? Can you start writing the code? Just do it along with me. So we are going to see with for loop what it is actually doing. Or starting light, ending light, I have just given. So I'm going to turn off the starting and ending light. Okay, so I want to display turn off, or I want light number 2, 3, 4 to be off. So just by printing it in the command window, I should be able to get the context. Okay, my lights are turned off. Okay, you can add a underscore over there. Light underscore 2. That works. So percentage means we are writing a sentence, or we are commenting it. It doesn't mean a code line. Rather, we are giving information about what does that code mean. It's basically a comment line. Percentage is the symbol which we use in order to just, it's a syntax which we are using along with the comment. If I'm not using percentage, then this, this is considered as a code, which actually prints an error. So it's a syntax which we are using, okay? Okay, so starting light I have initiated, and ending light also initiated. So one more way which you can do is like, I'm just writing it over here. You can also write something like light, you can give the number like light underscore 2 is equal to 2, and light underscore 4 is equal to 4. Instead of starting light, ending light, I just gave light 2 and light 4, and I have given the number like lamp number. This also you can write. Okay, so I'm going to comment this one out. I'm going to go with this command. Okay, so light underscore 2 is my second light name, and light underscore 4 is my final light name. Now I have written light 4, starting light to ending light, or let's say for light is equal to, since I have written a separate code, equal to light underscore 2, 2, which is represented by colon, light underscore 4. That means starting light to ending light. What I have to do is like I have to print or display the turning off process. So I am going to write display. So DISP is the code for display, displaying the result. Light turn off, right? Or turned off. You can use your own syntax over there. Let me just put it in quotes. This is something which I want to print. Again, let me add a underscore over here. Okay. So I want to print light is turned off. Okay. And I can also display what is the light, right? So what is the light number? That also I can just write it in quotes and I'm ending it. Okay, so this is my program. Simply like there are 5 lights in my room. I want to turn off lights number or light number 2 to 4. What I did, I just initialized what is the number of the first light I should turn it on, or the starting light, then the ending light. Then I wrote a for loop command like, okay, from starting light to ending light, I would like to print it like display the light is turned off. Let me try to run it. Okay, light underscore off can be the program code. And when I run it, I can see my light, it is printed 3 times, right? So how many times, or it just represent like how many times or how many lamps are being turned off. Okay, so I have light turned off 1 time, 2 times, 3 times. So that ideally means that, okay, light 1, 2, 2 and 3 is being turned off. Okay, I just missed a semicolon over here. Let me run it again. So the same thing, like 3 times it should be printed, meaning that 3 lamps have been turned off starting from 2 to 4. Okay, I believe that is done. So this is one for loop there. So it means that it fetches the data, it has a starting point and it has an ending point, and you can actually print your results as per the condition which you have given. Here I just have given a concept like, oh, I'm turning off the light. It can be watering the pot as well. Like you have 5 number of pots. You can water the pots, or you can start watering the pot from the second pot, like 2, 3, 4. That logic also can be used here. So if you look at the workspace, see light 4, and the last slide is like 4, right? So because I have written light, it's like the last one which was turned off is 4. Now first and second, it's been printed. Okay, let's just clear it again. So instead of light, what I can use over here, or instead of starting and ending, okay, there are fine, I'll give you some time. So there are some requests to give some time, so they'll finish the program. Okay, so 2 minutes, please finish the program. So what does a for loop do? It repeats an operation with a set of number of times. So we have to initialize like from where it should start and where it should stop, or from where it should fetch the data till where. Okay, and each time when it is executing, it changes the value. And when you go for a syntax, there is not a semicolon. So semicolon was not added into the for loop. If you look at your program, we haven't added any semicolon. We haven't terminated the program, right? So according to the syntax, the semicolon is not required. And every time it holds on the command, like it first execute one cycle of code, then it again go back and execute it. So it just retains the results and print it until it reaches the final value. So 2 to 4, if I'm just initializing, 2 is the first value and 4 is the second value. 4 is a final value. So similar to turn off light, you can also use a different program, like you can find sum of integers, or sum of or uh, you can multiply the first set of 5 numbers from 1 to 10 if you want to get the results of multiplication, or if you want to multiply the first 5 integers and print your results, that is possible. So every time if you want to go for a repeated action, or operation which has to be looped, or which has to be iterated again and again, then you can go for a for loop. See, for loop is used if you want to fetch a certain number of data, or if you want to do a certain set of operation out of a large number of data or large set of data. For example, if you have numbers, or if you are considering numbers 1 to 10, and if you want to sum up or add the first number of or first 5 number of integers and print the result, out of the 10 number of variables, or out of the 10 integers, you will only consider integers 1, 2, 3, 4, 5, because that is a set of operation which you are going to do. Similarly, if you have a set of variables in any application, if you only want to operate or do a kind of cyclic repetition or kind of operation with that set of variables, you go for a for loop. So it's kind of a repetitive loop which you are creating, and each time the code is being executed as per your command. The program which we have used over here is like, I have 5 lights in my room, and I wanted to print like my lights from lamp number 2 to lamp number 4 is being turned off. That is a logic which I have used here. What I have done is, first I have initialized which is my starting light, which I would like to turn off, and which will be my ending light. So total I have 5 lights. Out of that, I want only 2 to 4 lights to be turned off. So that is the first command which I initialized. So here, let me go back. Instead of going for light 2, let me try. Okay, I'm commenting this out. For light is equal to what? I should just fetch whichever lights I want to turn off. So this one, yeah, starting light, which is light 2, to ending light, which is light 4. Okay, so this colon means 2. Like it is in pure English, it means like, okay, starting light to ending light, or the first set of, or first variable which we are considering to the final variable which we are considering for that particular operation. Okay, now I want to display the light is turned off. That's all. So how many times I should be expecting the results to be printed? 3 times, because 2, lamp number 2, lamp number 3, lamp number 4. Whenever it is turned off, or according to the logic it is assumed to be turned off, I'll get a result printing that turned off, light turned off. That's all. Okay, light off. Okay, line number 7. Okay, write it 2 and 4. Okay, so now I'm getting a result of 3 times printed, like light turned off, and light turned off. Or light numbers, if I'm just writing. Okay, that's all. So it's a simple program. Yeah, so why we use a colon is, in pure English, as I have mentioned, it's like it states 2 from the starting point to the ending point. So instead of using 2, the word 2 will not be readable by MATLAB. We are using a colon. It says syntax. So underscore, the space will not be read by MATLAB. So instead of the space, we are using an underscore, a character there for the MATLAB to understand the word. Okay, let's go into next problem, which we will be, writing a program for finding the sum of integers. Okay, so I didn't mention one more thing. See, this one we have written very elaborately, like starting light is 2, ending light is 4, right? But in other words, what you can do is, like, most of the time when you write the program, instead of light, or instead of explaining it in elaboration, you can also use a variable I. So I'll just show you one program. It's like you can use for I is equal to, you can give the starting light 2 to 4. Then you can use light turned off or not. So let's just go into the sum of integers. One more question where we'll be using the variable I instead of elaborately writing, what is the scenario there. Only home, plots and app. Go to home, click on home, new script. Click on new script. A script will be added over here. Yes. So let's just move into the sum of integers. So I'm just showing the program here. So instead of the sum of integers, what I have written as the variable I itself. So the question is like, I wanted to find the sum of first 5 integers. First 5 numbers, like 1, 2, 3, 4, 5. I wanted to calculate the sum. So that is the problem statement. Now what did I do? So you can write the command like find the sum of 5 integers. Then next, what did I do? You can directly see. I'll explain what is this variable or what is this line. Like what is the meaning of the line? So how do you do that? You want to find first. You want to find the 5 integers, right? So 5 integers. You can just assign it like 1 to 5. Or if you want to find the sum of 5 to 10, also you can initialize it like for I is equal to 5 to 10. So whichever 5 integers. So I'm just going to erase first over here. Sum of 5 integers. It can be any integers which would you like to fetch. It can be from 1 to 5 or 2 to 6 or 5 to 10, 10 to 15. Whichever integers you want to prefer, you can just go ahead. And this time we are not writing it very elaborately. Rather, we are going with a variable which is I. So I is the variable that holds the set of integers which you are considering. I have considered 1 to 5. So colon means 2. Here, let me write. So I considered the integers from 1 to 5. Okay, that's what it means over here. So if I want to consider 2 to 6, 5 integers, okay, that is possible. Okay, so I meaning that what is the set of integers you have considered? What is the first integer and last integer? I holds the value of that set of integers. You can prefer your own way. Now, what is the logic which I have to use? Let me try to write it over here. I am going to use the logic like if I have considered 1 plus 2 plus 3 plus, right, 4 plus 5. That's what my program means. So if you have used 5 to 10 integers, it will be like 5 plus 6 plus 7 plus 8 plus 9, whatever it is, right, or 10. So this is what ideally I'm going to do. Now, how does it do? First, my program should fetch the number 1, right? Then my program should be executed like, okay, my program or for loop fetch it like, okay, first integer which I have considered in my I variable or the matrix is like 1. Now I go back and fetch the next variable. Correct? Then I should multiply it. Now, where will I store it? Because I have only given a variable which is I, which stores the set of integers only. So I haven't given a variable which can store the value of this summing or addition. That's why I have given a dummy variable like sum is equal to 0. So sum is equal to 0 means it is a counter. So it can be assumed like a storage space where I'm going to like execute the program one by one, and whatever answer I'm getting with each number of cycle, I'm going to store that value over here. So this act like a counter.
Let's have a quick quiz question, guys. What's the primary purpose of a for loop in MATLAB? To define functions, to create GUIs, to execute a set of statements repeatedly, to display plots. Please mention your answer in the comment section.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth.
I believe that's clear. Okay, that's a dummy variable I'm providing. Sum is equal to 0. Or you can provide like counter is equal to 0. Or n is equal to 0. Z is equal to 0. A is equal to 0. Anything. So it's kind of a dummy variable which you are providing in order to store the value of the addition or the answers which you are getting each time when you are adding it. So how many operations should be done? How many cycles should be completed? First, it has to fetch the first number, one cycle. Second, it has to fetch the second number and add it with the first number, second cycle. Then it go back, fetch the third number and add it with the existing result of 1 plus 2, right? And it should keep on doing that. So that is why we use a for loop over here. So the first line says that for I is equal to 1 to 5. Just I'm considering what is the set of integers I would like to add. Now, initially I have provided a dummy variable, like whatever I'm getting as a addition result of each integers, I'm going to store it over there. It's kind of a storage bucket. Now, what should be the arithmetic operation or what should the for loop do? Every time it should go to the counter and it should add one value, right? So first it will be I is equal to 1. First the program will execute I is equal to 1. So what will be the sum value? 1. Second time it goes again and fetch the value 2. So what happens? I is equal to 2. Now the program will be sum plus 2. So now what is sum? 1. 1 plus 2, 3. So that value is stored where? In the sum itself. So it goes back to the counter. So the value that has been stored after the second set is like 3. Now it go back and again fetch the third value, 3. That is I. So I value is 3. And now what is sum over there? It is 2, right? Or 3. Yeah, 3 plus 3, 6. So in that way, it should execute until it reaches the final value, 5. Okay, that is the logic over here. You can write the program and you can try to run it. You can use any number of values. So what I'm ideally doing, like, okay, first integer, I'm not using first. Sum of 5 integers. Display sum of 5 integers, and I would also like to see what is the sum value, final sum value. So this is the text which will be printing. And sum will be the value which it will be printing. Okay, let me go to my editor, try to run it, hopefully. Okay. It worked. So I got my results, like since I have used 1 to 5, my sum of 5 integers is like 50. That means 1 plus 2 plus 3 plus 4 plus 5. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 50. That the answer is correct. Okay, let me change it. I would like to fetch the numbers from 5 to 10. Now trying to run it. Okay, now my answer changed to 45. What does it mean? The first number was 5. My I is 5. Then it fetched back and went for the next value, which is 6. So 5 plus 6 goes into some value and it repeated. So I'm getting a value of 45. So we can do it for, okay, 15. So I'll just go with 20. Okay, so here I'm only using 5 integers. If you want to use 10 integers, you can use like 10 values you can give and you will be able to get the result. Okay, I'm going back to 1 and 5. So this is how for loop works. So it always, fetch the variables and it will help you to repeat the operation as per your result. Okay, Krishna, that's great. You are getting the answers. What first? How can I reserve dot if file save in wrong name? See, go for Atul. I'm just answering your question. So you can just go to save as, and you can save the program in a different name in the same folder. How to write if want to add odd or even number. Okay. Now you have to find the logic, right? So writing odd or even number, what should be the case? It should be +2, right? So every time it should fetch the even number. So that was your homework actually, assignment question. So it should fetch the even number and then it should get added. So think about the logic. Since it has been added as your assignment, I am just hand tied to show you over here. The logic is something like first you fetch which are the even numbers and then you add it together. Okay, so let's just move ahead with different syntax command line or program. So I just a quick revision, like we talked about metrics, right? So if we are typing a is equal to 5, okay, let me type it and show you. So how do you just assign column and row? Or how can you fetch column and row from a particular matrix? That's what we are going to see next. You know that whatever you are assigning to a variable, like let's say it is a is equal to 5, it is kind of a matrix that will be running, right? Or the MATLAB will be taking it as a matrix itself. Okay, while you are adding or if you are naming your program, if you do not name it properly, then also your program will not run. So one chance is that if you are providing the same name as a command name, or there is a command called plot. So if you are saving your program as a plot, then the MATLAB will have a conflict with the command and your program and it will throw an error. So better you save your program in different names. So here I am going to write example 3. Okay, that works. Okay, so A is equal to 5 is a matrix which has one row and one column. I can also initialize the matrix like 5 and 6. That means A has two value, 5 and 6. If I'm running it, you can see the value of A is like 5 and 6 simply. Again, this is a matrix of one row and two column. And when I'm writing A, okay, here itself, if I'm clicking on the workspace, it will open to a, see, array editor. Hope you remember the array editor, which I have shown you at the beginning of the session. This is what an array editor looks like. Like if you are double clicking the values in your workspace, if it has multiple number of values, or if it is actually a matrix, then it will help you to understand. It will provide you a data where how many columns are there and how many rows are there. It will be more clear to you. So this is kind of an Excel sheet, right? Or a printing as a column where you can know you can see from here A has the value of two column and a single row, isn't it? Now, if I want to take the value of A into column, or let's say I want to add 5 in the first column and 6 in the first column, first row, and I would like to assign the value of 6 in the second column, second row. So how do I do that? I can add a semicolon over there. And if I'm just running it, see, it became a column matrix, right? So this column matrix will have two rows. Again, I'm just going into the array matrix, double clicking on the workspace. So it is a 2 by 1 matrix. So initially, I'm going back again. Initially, if I haven't kept a semicolon in between the values which I have assigned to A, it was a matrix of, how was it? Like it was a row matrix, right? Like 1 by 2 matrix where it has one row of variables and two columns. Now, if I'm changing it with the help of a semicolon, that becomes a change the matrix structure from row matrix to column matrix. So that is the use of semicolon. An array is usually used to create a group of values of same type. If I say that A is the mark of a student, okay, let's just type it like physics underscore mark will be like 45, 46, out of 50. Just imagine it is on 50, 48, and 50. So this means that the mark assigned to 5 different students, but it's the same physics mark, it's the same subject, it's the same data or same type, is 45, 46, 49, 48, 50. So first student got 45, second student got 46, 49, 50, according to the student head count. And these are all similar type of value, right? Or it just concentrates to a single subject. Similarly, I can create, let's say I want to create an array for maths. So mathematics mark equal to, okay, again I'm creating an array like 45, okay, 40, then 43, 35, or let's say 46, 49, and 50 again. So the final student or the last student which we are considering, student number 5, is so bright that he got full mark in maths and physics. Okay, so by looking at the program, what you should read from the program is that I have an array of marks from different subjects for 5 different students. Okay, now I can also create something like this. So, like student 1. Okay, I'm creating a database for just the student 1. So, how should I write it? 45 and 40 are the marks that is being obtained by student 1, isn't it? Or I can also create a database with an array combining all the mark, like in spite of which subject I have assigned the value, I can provide it like 46, 49, 48, 50. Then I'll keep a semicolon, meaning that this is all same type of data which goes into physics. And next is like the marks obtained from maths. So I keep a semicolon in between the array. Then I'll go with 43, then 46. The same values I'm just copying, 39 and 50. Okay. If I'm running the program, you can see maths mark, physics mark are separately stored. And what happens to my student database? Okay, students database is a 2 by 5 matrix, right? So 2 means 2 subjects which I have considered and 5 students I have considered. In similar way, whatever data you have, you can create a database with the help of matrices. And if you run the program, you can see in the array editor, how does that look like, or how many columns and how many rows does it have. Now, I'm assuming the marks which I have given. So let me just delete it as a subject. I am assuming that John scored this mark for a different subject, 5 different subject. Okay, so this is not physics mark anymore. This is the mark scored by John. And this is the mark scored by Jim. They both are classmates and they have scored this value, right? So see, overwriting didn't happen. Like maths and physics are still in my workspace, but along with that, I got Jim and John mark. And now I have to access the data for a single subject. So assume that this 5 subject is like physics, chemistry, biology, maths, English. Let's assume something like that. I want the mark that is obtained by John for let's say only one subject. So how do I do that? What I can do is like I'm going to access the data from John equal to, or okay, let me not give the same variable. I'll give student 1. So I am assuming John as student 1 and I'm going to access the data like 1 comma colon. Okay. So 1 comma colon, meaning that I'm accessing, okay, the data here. So 1 is the first row and colon is the entire column data which I'm accessing. Okay, hopefully this will throw an error. Let's see what is that error. Okay, it didn't. Okay, student one. One is the mark. So how does it came one? I would like to know. What is one? So that means that I have done something wrong. So this is not the right syntax, right? So if I'm just writing one, comma, semicolon, that doesn't make any sense because I haven't accessed any metrics. So if you want to access any metrics, you have to write something like this. And let's see like how this works. Again, let's run it. Okay. Okay, so what I got is like what it printed is something okay, which is like random, right? So I got Jim's mark. So 40, 43, 46, 39, and 50. So is the same thing which I have asked for? No. So let me try to access it again. Okay, student equal to. I would like to access. Oh, I think I have made mistake in colon. Let me run it. Okay, invalid use of operator. Okay, what is the app operator here? That is invalid. Let's just see. Okay, still it might throw an error. Okay, let me just write it down again. Okay, so let me provide, yeah, student data 1. No, still it is throwing an error for some reason. Okay, let me just give it like marks. And I want to access first column and comma colon. Okay, colon. Well, it has some invalid operator. Okay, this, let me figure out. So I think the syntax, it's like I will write it like from Jim's mark. Yeah, let me just fetch. Now it should run basically. Oh, fine. Okay, so okay, again. Yeah, no. Still it's like throwing an error. Okay, let me see. So I think again it's just showing one. Not sure why it is. So the program is running, but it's just showing one. Okay, let me just check again. Oh, okay, let me try with the column metrics. Okay, so this is just fetching one data. Okay, let me just go back and then let me, okay, student data, I don't want, let me just, okay, so I understood. So this is like, okay, so from which array I have to just fetch, that was the mistake it seems, comma, hopefully student one, okay. Okay, yes. Okay, so I think this should work. Not sure like why it is showing. So even if I'm just accessing the data, simply like John Marks is equal to the column matrix. If I just want to access first and second row, it should be actually providing me the result. Okay, I'm not sure whether I'm doing some other mistakes. Okay, from John. Anyway, so let me try it one more time. If anybody has got the result, well and good. I think here indexing a variable parenthesis. Okay. No, this doesn't work. I'm really sorry, like something is wrong with my command line. Okay, let me just quickly take, yeah, so if somebody has got the results, Well and good. Okay, you got 45. Oh, great. Okay, so Zaid, fine. Okay, so anyway, you can just work on this. And like if everyone is getting the same error, please give me some time. Let me just work on this again and I'll get back. Okay, so by the same time, let me work on the syntax. So I would like you to do an exercise by the time. So let's just generate a sine wave or let's just plot a sine wave. So I'm going to show you the question which you can work on. Please work on this question and by the time I'll just get back. So I would like you to plot a sine wave. So you can use the command which is plot and you can use the equation like sine of x equation for plotting the sine wave. Yeah, so this is my program. So what I have done is like I have just provided the x value like 0 to 2 pi. Okay, so this column actually helps you to differentiate, or it's the step size which I have given, or set points. Like I want to calculate from 0 to 2 pi over a step size of or an interval of pi by 100. Okay, so when I'm running, my sine wave also will be having a set points equal to pi by 100. Then sine of x equal to whatever value it's fetching. Like each time, whatever set points it is fetching, it should be provided in the plot. Let me try to run it. Hopefully, this should not throw an error. Okay. Yeah, so my x value is defined and my y value is also defined. Okay, so it's a matrix of 1 by 201. And okay, am I getting any plot? Okay, my plot is showing up. I can also label. Okay, so if I change pi by 10, what happens? Okay, my values changed, it seems. So 0 to x value, I'm going to define like plot x label is x for me. And y label is y. Okay, if I'm running. Okay, I'm getting x and y functions here. Just plotted it. Then, okay, let me just check on grid on. So the PPT which I'm using now, it's not added. Okay, so this is my sine wave. If anybody haven't got, please copy the same question. So let me just give it 5 by 100. What happens? Okay, 0 to 2 pi. Okay, what happens if I give 0 to 3 pi? See, the interval which I have given was like as per my assumption. So you need not exactly go with 0 to 3 pi or anything. Like you can go with any values which actually can generate or which actually matches with the set points of a sine wave. That is possible. Okay, so here I have given 0 to 3 pi. So if it is 3 pi, then I'll be able to see uh, three parts of the wave, right? Of the sine wave. So if I'm giving 4 pi, yeah, I'll be able to see two complete waves. So similarly, you can just work on it if I'm just giving pi. Okay, let me try pi. Not sure, but let me try it. Okay, this is only half cycle, right? So it should be 2 pi. You can use any equation to generate plot. If you want to go for cos x also, you can do that for your practice. How to see the graph? Please run, save the program and run it. and it will actually pop up. Otherwise, go to your MATLAB icon in your toolbar at the bottom part, and there you can see the second window. Okay, so that is one such practice problem. Okay, then. Okay, let us just also play with one more plot, and we will just see how does plot is interesting for us. See, I'm going to use the command which is random. So I would like to plot random numbers. That's what I'm going to do. So how to plot it? Random numbers? You can just use the random command and plot it. Okay, so let me just show you how to plot. Okay, so I first should be initializing a program or the set points. So here I have just taken the numbers from 1 to 5 using a for loop. So what does a for loop do? I have initialized the variable k, and k will be accumulating the integers from 1 to 5. So within 1 to 5, like 1, 2, 3, 4, 5 integers, I would like to plot 20, or I would like to fetch 20 random values and plot it. Okay, that's what I'm going to do. I don't want plot and all. Okay, let me just try to run this. Okay, save it. It's a read-only file because the naming is not right. Okay, what does the line says? Okay, let me just open. Okay, give me a minute. Let me just open the program once. Between 0 to 20. So rand is one such command which you can use to plot random numbers. So here I have taken 1 to 20, 1 to 5 and 20 such or let's say set points. So let me also just see where I can just keep it like, okay, let me close this. Okay, 30. So, and try to run this. Okay, here I have 30 random numbers. So you can keep on adding, whichever value which you need. You can just try to get it. So what happens if I'm not using a for loop? So let me just quickly take it off. So I'm trying to just simply plot it. Okay. Let me see like how does this work. So this is incomplete, right? So first you should be initializing a set of variables, and then you can give the command like to plot it within that. Okay, so this is very simple. So I haven't divided anything. I just initialize like what is the range of my x values according to the sine wave equation. And I just provided the sine function of the values. That works. It is basically the interval points which we are defining. So 0 to 2 pi is the range of sine wave. And let's imagine imagine a graph sheet, right? So graph sheet, it will be having set points like y-axis and x-axis. So you initially put dots over there and then you plot it. Correct? So that dot points will be the interval for completing that entire waveform. That's what it is provided over here. So since we have used till pi, we have used the variable pi, we have gone for the interval of pi by 100. Okay, so let's just work with bar. So it will provide you a bar chart similar to you work with a presentation in Excel sheet or something. You can actually see a bar graph over here once you complete the coding. So initially I just have given the command line for days. Okay, so 0 to 35 are the number of days I'm considering, and I'm considering it over an interval of 5. So if I'm writing a program like 0 to or 0 colon 5:40. That means that the range of variables which I'm considering here is 0 to 40. And the intervals which I'm considering is like 5. Usually we take this command for plotting or creating any kind of visual aid. And if I'm just writing is like 10, 0:10 to 100. That means that I am taking or I'm considering the range of values from 0 to 100 over an interval of time. So I'll be having 10 values in my plot, like 10, 20, 30. That will be my graph points or axis points. Okay, that's the meaning of the code. So here, what I have done is like, I have just initialized the number of days and I'm going to just go for a bar chart. You can ignore this line. So this was like earlier done from me. So that's the reason I'm just showing it over to you. So what you can do is like initialize days. It can be any day, like 0 to 30 or 0 to 100 in any interval which you need. Then the logic is like I'm trying to plot the temperature of those days. Okay, so temperature I gave a array. I gave same data type values. And if I'm just using the syntax like bar instead of plot, if I'm using bar, days and temperature, that means that plot x and y, it's similar, it's similar to that. It's kind of an analogy. It's like I wanted to see a bar graph here. So the axis of my bar graph should be days and temperature. That's what it means. So just ignore the comments which I have given here. So this was supposed to be a program with plot and as well as bar. You can ignore the other comments. Just try it with this three line of coding, where you have initialized number of days and some other variables. It can be days, temperature, or it can be like humidity, or it can be like your steps, like walking steps. So 7 days a week, how many steps you walked. So you can initialize any data and you can convert it into a bar chart. Let me just save this into a proper file name. So every time when I'm just fetching old files, it's showing a temporary mode. Okay, the program is running. Okay, this is what I'm getting. Okay, this is how my bar chart looks like. So you can see the x-axis is my days, number of days which I have initialized. Please ignore the right hand panel because I have other line of codes. So just ignore it. Just go ahead with only what you have in x-axis and y-axis. So x-axis, I have my days, which were initialized like 0 to 35. My set points or axis was like with an interval of 5. 0, 5, 10, 15, 20, 25, 30, 35. Then it is showing the points, right? So first, my temperature was initially for 29. Then I gave a value of 23, 27. It's showing the same. Let me just keep the code and the plot side by side. We can just practice. Last program not working. Plot P, can you give it as a small letter P? MATLAB is case sensitive as well. So if you are providing capital P, it will not sense the command. Please provide it in small letter. Okay, now let's see what happens if I'm just commenting this out. Yeah, so this doesn't work. The program is broken. So better I comment it again. So let's just concentrate on the 3 lines of code where it shows the bar chart. Okay, let me share the bar chart again. So let's change the values and see how does it reflect. So I wanted to go for 0 to 30. Then how many values or points will be there? It's the same, right? So let me just change few values here. I'm going to put 7 as my last number. Okay, now you can see the value changed. So the value corresponding to 35 is just 7. So look at the left hand panel. The right hand panel, we are not using that code. Okay, hope that is done from your end. Okay, so if I'm writing the entire code, if I'm just providing a plot data also with a different set of variables, this is how it looks like. So I'll get a plot as well as, I can also see the values which is corresponding to days and like concentration, something as a plot. So bar and plot both I can use. Okay, so I hope that is done. Basically, I added two more lines. That's all. I just initialized two more variables and I plotted it. Okay, let me just change it to temperature. Okay, steps. I'll give it steps. Simply, I'll give it steps. Okay, let's assume that these are the days which I walked, and the temperature and the walking steps I had. Okay, y-axis is a command which we use. So for the question which I picked up from the chat, it's just a command which we use. It's a syntax which we use for getting the measurement over left side and right side as a panel. Like x-axis and there will be two y-axis which you can just figure out the data. Okay, so this is the page or the documentation page from MathWorks itself. And if you just scroll down, you can see that there are, okay, my screen is stuck. Yeah. So here you can see that there are a lot of commands which actually helps you to plot different types of data, right? So you can click on examples and you can see like how to plot sine wave. So this is the same program which I have used for with the sine wave generation. This is an example program. Then again with multiple waves or multiple graphs which you can just project, that program is also there. So the link for the page I have provided in the chat box. Please go through it. And this example is something like the command which you can use for creating a matrix like equal matrix 4 by 4 or 5 by 5, 6 by 6. So why I'm giving you this page reference is like everything we like all the command and all the options which is available in M scripting. It cannot be discussed within 3 hours of time because the application is it's in such an extent. So at minimum, you need 5 hours of time to understand the basics, like fundamental commands that we can use over a program. But take some time to go through this page. And there are certain other examples also which you can follow from the MathWorks site itself. Okay, so magic 4 is one such command which you can use in order to create a magic matrix, like matrix of 4 by 4 size. So if you go here like magic 5, then it will create a random number matrix with 5 by 5 dimension. Okay, so the numbers are not initialized, but it will be like random numbers picked up. And if you want to plot again with multiple variables or parameters, you can also use the command called figure plot y. Okay, it's kind of a 2D line plot which you can generate. So how you can open these is like try this example, or you can copy the command from here. You can go to MATLAB and open it. I'll show you how to do that. Or you can simply try to copy it from here. Let me go back to my MATLAB screen. Let me try whether this works, copying. Sometimes it doesn't work because of the space and the spacing and the syntax. Sometimes it doesn't work. Okay, it's working. Yeah, you can simply copy the command and you can just copy paste it in your editor window. So that also works, right? And you can just read the code. So initially, try to develop the code. That's okay. Like if you're getting error, and sometimes if you're out of practice, also like the error prints up. Best way is like go through many problems, like go through as many examples as possible, copy it in your editor window, run it, and then read the code line by line. So it will give you a good understanding about how to construct the code. So developing a code need practice and logic so that you can actually practice over the time, like multiple examples. So this is one such example where you can see It's almost the same line of codes which we have used to generate a sine wave, right? 0 to pi by 100 into 2 pi. But again, along with y, which is sine of x, we have defined a delay in the waveform, right? That is like 0.25 minus 2 points. So x minus 2, 0.5 will be the function that generates the wave. So similarly, if I'm adding, okay, let me try to edit a little bit, not sure. Okay, let me edit it. Okay, x minus 0.75. Now what happens? I should be expecting the third plot, right? Or the final plot. So before that, I should also plot it over here, like x comma y comma x4 comma y4, the coordinates. Okay, character vector not terminated properly. Fine, and terminated. Okay, again, error. Okay, where is it? Okay, x4 y4. It's fine. So let me go back. So this programming tutorial, it's not available in MathWorks directly, but few examples are available where you can just go through the examples, find the code, and then practice it from your end. Okay, so this is okay, I'll show you like how to open this. So try this example. You can click on there, or simply you can copy the command and you can open it in your MATLAB. So if you're just trying this example, it will help you to open the MATLAB online interface. I believe you are able to see my online interface, right? So what I did from the code, I just clicked on try this example. Okay. So it helped me to open up my MATLAB online interface, and here I can see my graph. Otherwise, if you have to open it in your installed MATLAB software, copy the command, then go to your command window. Okay. And okay, here in the command window, you can place it. And if you click on enter, yeah, that will open it in your editor window. Okay. So I'll show you one more time what I have done. So from the MathWorks site, two ways you can open the program. It's like try this example will take you to the MATLAB online and copy the command. Just click on it, copy it and come back. Just paste it in your command window. Click enter, then this will open up. Okay. Yeah. Okay. So again some. Okay. We'll sit and see what is happening. Okay, let me just. Okay. Going back. So this is another way where you can generate or highlight the points. Then, okay, this is some similar to what we have done, right, earlier, like generating sine wave. And linspace is also a command which you can use in order to just initialize the spacing of the variables which you are using. Okay, so earlier we have used 0 colon. Okay, let me go back. So we used something like this one, right? 0 colon 15 colon 50, right? What does it mean? So this code or line reads like, okay, it will be reading a variable from, let's say, x is equal to 0 to 50. It will be reading or it will be fetching the data from 0 to 50 integers with a step interval of 15. So first variable should be, or first value will be 15, then it will be 30, right? The step intervals will be something like that. So linspace also provide you the same command. So only the syntax is slightly different. So while you are using linspace, ideally both are same, but it's a command which we are using. There you use a square bracket. Then the same thing can be put in this way with a comma. So if I'm using linspace command, I'll be just writing it like 0, comma 15, comma, how much? 15. Close bracket. Yeah. So both are same. Okay, let me write it like A, Okay. So both lines are read in a similar way, where I should use a square bracket here as well. So here I use a column. Here I use a comma with the command linspace. Okay, so that's about the linspace command. So just go through these examples for plot and or at least like read through it. Yeah, so this is something which we have created, right? Random numbers. So random numbers we have created, and you can create bar, graph, charts. So there are certain commands which you can plot. You can use the plot command, and you can actually create visualize in multiple ways, right? And you can use different colors for your plot if you're using multiple variables that will help you with different colors, etc. Right? Just go through this page, and along with that, you can also just go ahead and see like what are the syntax, what are the tips, right? How you should create the program, like probably what error can throw up, and 2D and 3D plots. So there is a page itself where they have given many examples. So you can try the examples. So this one we have tried, right? So overlay bar graph. This is something which we have tried with a different program set. So here they have you temperature and X value, and the color, everything has been defined, but we didn't go with the same line of code. We did a separate one. So you can also create, two bar chart within the same diagram itself or figure itself. So that has a different syntax. Okay, you can label it. So for labeling it, the command which we use is legend. Here it is. Okay, so legend means it will help you to label something like this. Keep a legend. So that will help you to differentiate between what data or what is the name or title of the particular data you are projecting. Okay, you can also create something like xtick labels like this one. For creating this one, you can use this syntax. So the code and the programming is it's kind of very wide, right? It has a wider extent, and lot of commands are used. So one more example I would like to show you is regarding contour, right? Yeah. So let me check. Contour is there. So for creating the contour, quickly, if I'm just defining, we usually use the syntax called mesh grid. So mesh grid is one such command which we use for producing or generating a contour plot. That is also kind of a 2D plotting which we do. Let me give you an example if possible. Let's say x is equal to linspace. Okay. Let me take the values 1 to 5. 1, 2, 5 with an interval of 1. Then let me just define y value linspace. Again 0. Let me take an interval of 4. Okay. And I'm just giving the command like x, x, y, y. So this is a command for meshing. I'll show you like how does it looks like. Equal to mesh grid x, comma, y. So it printed something like this, right? So what does it ideally mean? Is like, see, you have a grid like this. Okay, let's assume this is a grid which you have. So each point will be having a x-axis value and a y-axis value, right? So let's take this is 0, and I have taken the y-axis till 2. So this is 2, and x-axis is 5. Okay. So if I want to know the point here, what will be like my coordinates? It will be, let's say this is 1, and okay, this is again 1. Just an example. So this coordinate will be 1 comma y, 1, right? So x coordinate and y coordinate will be 1 comma 1. So if I want to know the coordinates over here, what will be my coordinates? I'll be looking at what is the y coordinate and x coordinate. So x coordinate is 2 and my y coordinate is 1. So just imagine you similarly have a mesh in which you have to find out the coordinates at each point. So instead of writing the coordinates for each one, you can simply use this command, mesh grid, uh, and you can just produce the results, or you can produce the or print the values which represent the coordinates over that particular mesh. Why we are using xx? Because we have two coordinates over here, right? So that's the reason we are using two coordinates. That's the syntax we use for representing two coordinates. Okay, so yeah, so my x value is like 0.25, 0.50, and my xx value and yy value is something like this. Okay, so this is similar, like if I fill up all these coordinates, it looks similar to this. That's the another command which we use. So you can actually use contour plot along with mesh grid, along with linspace. So let me see whether quickly I can just tell you the program 1 minus 1 to 0. Let it be again. I'm just changing the values quickly. 0 or let's say 1, and let it be like 10 or 5. Okay, 10, I'll keep it 10. Okay, so my x coordinates, y coordinates, let it be the same mesh. Now I want to project. So contour is something which will be providing you as z-axis. So one more axis will be there, like it will be projecting the figure in a three-dimensional view. So for that purpose, I'm just initializing xx zz, and let me just give an equation quickly just to come up with a contour plot. So you can use whatever equation. So I'm using an equation for the circle. Dot cap. Okay, and I can use the program contour xx comma yy y comma zz. So I would like to show text. On yeah. Hopefully this should work. Okay, the values didn't come up. Okay, my y value, x value. Okay, this is 10. So now my contour plot showed up. I believe my contour plot is visible, right? So if I want to fill color, I can use contour as. Okay, I'll just write it as here. Run it again. Yeah, this is okay. So this has all the values from X, Y, Z that projected, and I could see, like, the darker color actually shows the higher values or coordinates. So I have Z, X values, right? And if I have to get a more smoother way, okay, I can also provide a color bar or surf. Okay, let me just use surf XXYY and CZ. Okay, I get a plot something like this. Like it's a three-dimensional figure, right? So whatever equations I have provided, according to that, the figure actually showed up. So I'm just dragging it, and I can just look at the data, like how it is projected in x-axis, y-axis, and z-axis. You can just copy down the code and you can try it from your end. So this is on contour plotting. Okay, so I am just teaching you few commands which you can use, right? So contour plot will be helpful if you are trying to find the efficiency of a motor, or if you are finding efficiency of a certain system. That way, if you have more number of variables added, usually we use contour plot, which is kind of a 3D plotting. So it will provide you the idea, like, okay, which area the efficiency is higher. For example, if you are plotting against torque and speed, if you want to find out the like area efficiency area, like maximum efficiency area in coding, if you are converting that torque and speed characteristics, or if you are adding those variables and writing a script with the help of contour plotting, you will be able to see which area you can choose, or which are the variables, or which are the value set of values which you can use, or range of values which you can use for torque and speed, so that the efficiency falls under a certain area. So that visibility you'll be getting from a contour plot. So contour plotting is a three-dimensional plotting which we do to find out this kind of application. Like usually I have done it for efficiency plotting. So if possible, tomorrow I'll show you like what does a contour efficiency plot look like. So it's just a command which I came through, and I thought like I'll show you an example. That's all. Rohit, torque and speed are only two variables. So I want to find the variable efficiency. That is a z value. So how do I find it? I should be projecting the range of torque and speed in x-axis, y-axis, and z-axis will be the maximum efficiency that actually align with the equation, like how much will be the torque and speed, the maximum torque and speed. If you are equating it, I can just visualize how much will be the efficiency in the z-axis. So from the program itself, we understood matrix addition, matrix multiplication and division, element-wise operation. Then we jumped into for loop where we try to switch off the light, and I'll give you more practice examples, don't worry. So while you practice, you'll get more logic of it. And later, as a second problem, we just saw like sum of integers, right? So if you want to add sum of integers, so sum of odd numbers, even numbers, all these things can be used in for loop. And this is another program like for loop, like you can plot as well from the for loop. So for loop we have seen, and then we actually went into the array, where how to write the array, right? So if a is 5, then that itself is a 1 by 1 matrix. Then you can just go ahead with overwriting the variable a, and then you can access whatever values which you need from that particular array with certain equation. So that we have seen. Then we went to plotting, how you can plot random numbers. Then in plotting itself, we have bar plotting, like you can create the bar chart. And then we talk about different syntax and commands which you can use to produce or generate different types of plot. You also have done an exercise problem with sine wave. You generated a sine wave.
Let's have a quick quiz question, guys. What's the key distinction between MATLAB and many other programming languages? MATLAB is a compiled language. MATLAB is a scripting language. MATLAB is primarily used for web development. MATLAB is open source. Please mention your answer in the comment section.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth.
So this is a shortcut which will be added into your screen once you have downloaded the Simulink package. If you do not find the Simulink icon over here, what you can do is like you can just go to your command window. Okay, I'm just showing my command window over here. All right, I believe you didn't find any difficulty till there. Now, before we start with modeling of any system, I would like to just take you through a little bit of theory part, where I would like you to understand the relevance of modeling. We have done MATLAB coding, right? And many of you were confused about, okay, why are we doing this coding? What is the relevance of this coding? Why am I generating a sine wave? Why am I using a for loop, etc.? Isn't it? So coming to Simulink, I discussed you about what is the relevance of model building, right? So while you are building a product in the software, first thing is that you are going to visualize your product as a block diagram. And you are going to add all the relevant component in the block diagram with the help of the library browser, which we explored. And then you are configuring it. Configure meaning that you are adding the values. If it is a motor, you have to add torque value, speed of the motor, rated load of the motor, etc. And if it is a power converter, then you should be adding diode, inductor, capacitor, resistor, and you should be adding respective values to it. So once you model or once you complete the system level or component level configuration, that becomes a system. So multiple systems integrated together, that becomes a entire vehicle model, isn't it? For example, please look at my screen. The first part is a battery, which is the energy storage, and there is a power converter or power modulator that is integrated along with the battery, right? Oh, I think my annotation just went by. Yes, appreciate your memory and appreciate your effort. You remember the system. So this is battery, which is the energy storage, which is connected to a power converter or a power modulator. Then there will be a electric motor. Then there will be transmission system, and it will be connected to the wheels, right? So let's say these are the wheels. And there will be sensor unit or sensors or control system, right? So who is monitoring the dynamics of the motor and will provide you with proper feedback. So these are the systems, or these are the main systems which you can find inside any vehicle, or particularly inside an electric vehicle. This is called a system level configuration. Now, if you want to build the entire vehicle model, where should you start? You should start from a component level integration. What do you mean by component level integration? You should look inside each of the system. Those who have joined late, this is battery. So you have to look inside the battery. Then you should understand how is the battery configured or connected, right? So this is a string of the battery. This is battery number 1, 2, 3, 4, etc., etc., right? That makes a battery pack, isn't it? So there is a cell. The string of cell connected together makes the battery. Again, multiple batteries connected together makes a module. Then multiple modules connected together make a battery pack. So where should you start building your product or system? From the very first level, which is the component level, correct? So you should be having that much vision or idea about which are the components that create this particular system, or which are the component that is included into the system. So this system, let's say the system 1 is completed. Now you build the first system. Now you can go to the second system. Now you look inside. Okay, what are the power components included, like diode, rectifier, capacitor, inductor. So you build this one. Now you integrate this and this together, right? Similarly, you work on component level modeling for each part. Then you create each system, that is system level configuration, and then you go for a product level, or in this case, it is a vehicle level configuration, or vehicle level, or let's say the final product, your product. Okay, that's how you build the product. So this is applicable even if you are going in the hardware side or in the software side. So this process is applicable for both, right? So in industry language, we call it as a V cycle of a product. Some of you might be aware about the V cycle, right? The system design V cycle. So V cycle and the life of the product, you will be learning more in your embedded system and model-based development module towards the end of the course. So when you want to build a product, the systematic design is very important, or systematic design along with the realization process of each step is very important in case of industries. So this is reflected as a V diagram. First, you define requirement, right? So if you want to start with a battery pack, if you want to build a battery pack, first you should define the requirement. Okay, what is the total voltage of my battery? What is the current capacity of my battery? What should be the load capacity of my battery? So first you define the requirement, then you go for the component level identification, meaning that you will identify how many batteries should be there, how many cells should be there in order to achieve this particular requirement. Then you go for the system level requirement, like, okay, you built the entire battery pack, then subsystem design is done, you integrate it together, and the integration test is completed and calibration is done, and that's how you complete the entire product. So testing and calibration comes under a simulated process. Testing is nothing but in simulation or in a virtual environment, you test your product, you run the product and see whether this is providing enough performance or whether this is meeting your defined requirement. If it is not meeting, what do? You calibrate the product, right? You just keep on calibrating it or retuning it or refine it or reiterate it till you get your specific output, isn't it? So this is the same process we do in industry as well as in hardware design. Okay, so calibration means you go back, you revisit your product and you make the changes so that it will be reflected in your output. You keep on retuning it. Example I can give you is like radio tuning. So you go into a channel, like you just tune into a channel, but it might have some noise or it might not be clear at some point of time. So you just there will be another button where you fine tune it, right? You just carefully change the knob where it is matches with your requirement. Similarly, there is a specific requirement which you already have. So when your product is running, if it is not providing you the output, you revisit the product, revisit the values or revisit the design. You make precise modification to it or you recheck your design one time and you make the necessary changes so that you are getting your output. That is called calibration. All right. Yeah. So this is the entire process in which you start modeling it. Okay. So even if it is EV, so I know that everybody is like very much keen to start modeling only in EV. If I'm giving you certain other examples that might not be helping you or that might not be, you might not be happy with that because everybody is looking forward for just building the EV product. So that's why I'm just specifically going for a EV example. Now, how does the EV look like? You know that there are five main components and system, and when you integrate it, that becomes the entire modeling or the drive or the powertrain is completed there. So we have to start from the component level, from the design or requirement analysis. Okay, so I'll show you a model where you can see a completed model of a electric vehicle. Please let me know if my screen is visible. So this is a model of a e-towing vehicle. This is a project model which I have done for a electric towing vehicle. Have you seen a towing vehicle in airport? So aircraft, there is a small electric vehicle, very small electric vehicle that will be attached to the aircraft, and that vehicle will be pulling the aircraft for the spacing, right? Or it will be always pulling the aircraft to the parking or hangar or not. So there it is. It's kind of a small electric vehicle. Or let's say if you have visited zoo, there is an electric vehicle that takes the passengers around and show around the zoo, right? So it's very comfortable to sit in that vehicle and it is electric. Or other example is the golf cart. So just imagine a golf cart vehicle. So this towing vehicle looks similar to that, right? I believe everybody has got an idea. See, how does that vehicle looks in a simulation environment is something like this. Okay, so this is what you have to practice and learn to build. So this is called a drive cycle. So drive cycle meaning it is an input or it is the pattern input which we have provided to the system so that it can run in a specific way. So drive cycle is nothing but it is speed versus distance. Okay, you can see drive cycle, there are certain set points where it basically show the driving pattern. You can change it to anything. I'll show you. Let me just try to attach a scope here. I'll show you like how does a drive cycle looks like. Drive cycle is nothing but it is a driving pattern. So you have provided a specific driving pattern at the input, and you can see here it's a longitudinal driver, meaning that the power converter or the controller part is taken into consideration over this block. If I'm just going inside, see, this is called a configuration setting. You can set it over here. You can provide the values over here, and this block say like act as a controller. Then you have the motor system. So we are talking about the small electric vehicle which you see around a zoo or a golf cart or a towing vehicle. Look at the complexity of the components, right? So if you look inside the motor system, you can see the motor system is consisting of n number of components, right? It's simply not a like a one block diagram. Instead, it is a combination of multiple components connected together, which is mechanical components and electrical components. Okay, which is connected together. So this is multi-domain components connected together. You can see this is the motor, DC motor. This is the block diagram for DC motor. So DC motor has an electrical part as well as a mechanical part. The mechanical part is shown as green color, or it is represented as green color, and the electrical part is represented as a blue color. Why? Because we have used a interface called Simscape. So that is the reason it is showing colored. Okay, and there is a voltage control source, there is an H bridge converter, and these are output, there is ground, right? So imagine for every system, you have to actually draw the circuit in component level, and then you make the system ready. And that system will be connected to the other system, integrated system. So if you look at here, the vehicle subsystem, this is the vehicle body part. Okay, so I can just go inside and show you. So here you can see 4 tires and the rear wheel, the gear part, everything, right? So this is basically a component level analysis. And you can see the vehicle body, drag force, the force is acting on the vehicle, rear right, front right. So everything is being drawn here properly. So this is the way you actually build your model in Simulink. That is why it is called modeling. Along with the main systems, you can also see certain other supporting systems, right? Scope. So scope is something which you visualize the result. Then you can see a display box. Then you can see an integrator. So all these auxiliary blocks which we are using supports your main system, or it will be either supporting an equation. Okay, so this is how you have to build the entire product. I believe you understood the concept of Simulink and why we are going for Simulink modeling, and why we are starting with a small model like example model. Because if you pave the foundation for the fundamental, if you actually know how to draw a circuit or how to do a component level modeling, then it is easy for you to build a system, because you build a system on top of component level, right? So once the component is correctly integrated, then that becomes a system. So that system can be integrated with the next system, because every system you are going to draw it as a circuit and integrate it. Okay, so this is how you build a product. This is an example of EV, and I also have few other examples which I could show in our later sessions. Like even we can build a, if time permits, I'll help you to build the entire vehicle also, like 2-wheeler, 4-wheeler, we can build it in Simulink. But for everything, first step is component level analysis, or drawing the circuit properly. Okay, I believe you got my point. What is the relevance of going for modeling, and why we are always going behind simple models is this reason. So if I'm asking you, or if I'm teaching you how to model this one, there will be 100 of questions coming from your end, right? Because you are not familiar with how to configure longitudinal driver, what is the relevance of longitudinal driver, why it is connected with vehicle subsystem, right? So the logic has to be developed slowly. Out of practice, you should be developing the logic, and I can also give you example models to practice on. I'll give you the entire model itself, like file along with description. So you can open the file and study the file, simulate it, and understand how this is connected. That is also possible. How to open the Simulink one more time. First, you open the MATLAB screen. Okay. Please just follow my steps. Please open the MATLAB screen, and Hitesh, let me know if you are able to open the MATLAB screen. By the time others, please put down your questions regarding what is the relevance of Simulink, why we are doing these examples, or if you have any questions, what we have discussed so far, please let me know. Like, we'll just take baby steps. Simscape is available. So if you have downloaded only MATLAB and Simulink package, then Simscape will not be there. You can download physical system modeling from MathWorks, like later after your trial is over, or after, if you want to reinstall it also, you can install physical system modeling package where it consists of Simulink, MATLAB, and also physical system. So subsystem is not a block, it's something which we create. So if that is something which related to the model I have shown you, don't worry, that is a model I created. So I'll help you how to create that model in the later session. If you are asking about help in opening the Simulink, just type Simulink in the command window, click enter. It will open a untitled, or it will open a page where you can click on the blank model and start. Okay, so please click on Simulink book. See, MathWorks itself is a wider extent where you can go and refer to the documentation part. Book in the sense, no, I'm not sure about book, but there are like open resources available. I don't remember the name of the book now, because how I did is like I kept on practicing and I took only reference from the MathWorks website itself. I'll check and let you know whether there is any authorized book available for the practice. But what you can do, Manjit, is like you can simply go to internet and check for MATLAB examples, Simulink examples, PDF file. That is an open resource where you can download it. Okay, few people are talking about crack version. How to open command window. So we don't have to open the MATLAB screen, and command window will directly appear over there. So if you are not able to see the command window, go to the toolbar, click on the layout, click on default. So there you can see a command window. What I have done is like I just extended the command window. Okay. So type Simulink and Simulink model will be opening. Okay, so let's just begin with modeling. I'm not going to give you any example of X plus Y because I felt it was not that much, participants were not like excited to do an X plus Y simulation. So let's directly jump into a small battery pack. Can we do that? So if you are ready, please give me a thumbs up. So Rajat, crack version, I'm not authorized to talk about the crack version. I'm really sorry. Please raise a ticket with the technical support. The technical engineers might be able to help you that because usually for software like MathWorks and MATLAB and we are not like ready to talk about the crack version. Apologies for that. But please raise a ticket with tech support. Okay. All right. So I'm going to teach you how to build a very, very small battery pack. Please hang on with me. So tell me what should be the first step I should take. If anybody wants to talk, what does it actually align? That aligns with the first step of our product building, which is what? Defining the requirements. Correct? So just before we have talked about, we have to first define the requirement of what the product which we are building. So for that, I have to think about what is the level of the voltage I'm going to build, right? So voltage level. Then I should be thinking about the current capacity. Okay. So what are these? These are my input, right? So these are the values which I'm going to give to my battery pack. Now, what should I expect? From this one, like what should be the output which I'm expecting? I should expect the state of charge of the battery, or the pattern in which my battery is discharging. Okay, so I have written something over here, like as one of my participant told, I should be looking at the design requirement. So I should be first thinking about, okay, how should my battery pack look like? Or what should be the voltage rating of my battery and the current rating of my battery. So let's assume this is my battery pack. So battery pack consists of battery modules, right? This is module. Now inside module, there will be batteries. What is a battery? It is a combination of cells. So my thought as a design engineer should directly come here and understand what should be the average voltage rating, what should be the current rating or current capacity. How do we define current capacity of a battery? Ah, right? Ampere hour. Okay, that is the design requirement I have thought about. Now, what category it belongs to? It is the input which I am thinking about. Now, if I have a battery, I have given this input. What I'm expecting from the battery, what is a deliverable, or what should I what should I interpret by giving this input? What should be the output? It is a battery, right? So ideally I should be looking at the charging or discharging cycle, or I should be looking at the SOC. What is SOC? State of charge of the battery. So those who do not have idea about SOC, just look at your mobile phone or look at your laptop. The amount of charge your device or gadget is currently holding, that is called the SOC of that particular device, state of charge of the device. So whenever you are trying to model a battery, that is the exact output you are looking at. So you need to know if you are driving your vehicle or if you are using your device, how much is the charge left in that particular device, right? And if you keep on changing your input, how it affect the charging pattern? That is what we are going to look at. So I have already written my inputs, which I should be like giving voltage and current capacity, etc., etc. And what I'm going to check is my SOC. Okay. So if you are wondering how I have written it, written all these text, so it is similar to the text which we have discussed yesterday, right? M scripting. So do one thing in your panel, in the left hand panel, please look at my screen. There is a option called annotation. Just look at my screen and look at my mouse pointer. Click on there and you can go to anywhere in the blank screen. Double click on it and you will be getting the access to write anything. Something like this. And you can also take help of the other options available regarding changing of your font, changing of your font size, whether you have to, give it in a different color, whatever. This is also basically you are writing a comment or writing a title, or you are helping the third user or other user to understand what you have built in your model. So if you want to annotate anything, if you want to write a comment in any of your system, you can do that with the help of annotation. I believe you have got annotation and you have tried with the annotation. Now I'm just going to delete it. So I believe you have followed me till the annotation part. So what I was just discussing is like there is an icon in the left hand panel where you can use for annotating your model. Basically, you are writing something. It is a text option. It is available. So go here, look at my screen. You can just click on the third icon, right? So first is the magnifier. Then second, we have again annotations or anything which you can write on. Then third is the annotation part. So click on here or enable this option. Then you can go anywhere in the blank text and write anything. Okay. So if you want to write the title. Okay, let's write the title of our today's model or example. So I'm going to write battery Otherwise, I can just double click anywhere, create annotation. So battery performance model. Okay, so this is the title of my model which I'm going to do. Let me know if you have followed me till here. So we'll just go ahead. Give me a thumbs up or please put down in the chat box. So I'm making it more visible. You can choose your font size, no worries. So drag, I'm just going to keep it. Perfect. Battery performance model. Super. Okay. Now the first step is like, okay, I know I have to provide voltage and current level. But where should I provide the voltage and current level? To my battery. So I should have a battery block in my model so that I can provide the input. Where should I go and check? Where can I see my battery block? Where is the place I should check for my battery block? It's library browser, isn't it? So I have to go to my library browser and then I have to look for the battery pack. Okay, please do along with me. I am going to the library browser. So I believe you have given the title for the model. Now please look at my screen. My mouse pointer is here. I'm going to library browser. Click on library browser, just one click. That navigates to the panel where I could see the entire library in my left-hand panel. I have a search item here. Go to search item and type battery. Click enter. My library is checking for the battery block now. Right. So I believe your library browser also have brought the suggestions for different types of battery. Can you see my screen in the left panel? Or you can look at your library browser screen. How many types of batteries are there? There are a lot of batteries, right? So this looks like a car battery, like lead acid battery. It depends upon your perspective. And this is data sheet battery. So this is not the battery which I'm looking for. Network battery. Data sheet battery, again, equivalent circuit battery, estimation equivalent circuit battery, and battery CCCV model, passive cell balancing, SOC estimator. Multiple number of batteries are available in the library block. If you just type battery, if you're not specific with the battery which you are looking forward, then it will give you wide varieties of battery blocks which are available. So for understanding each and every battery, you have to go through every battery and understand, okay, where this is applied, what is the configuration setting, how many input values it can take, right? So it's a very hectic task. For this purpose, along with your design requirement, you should be also knowing which type of battery you are going to take. Okay, so I got answers from few of you, like you have got only one battery. Can you see my screen? Maybe like in Simulink or due to the package you have installed, it is only showing one battery. So I believe your battery block is something like this. I'm just drag and dropping it to my blank model. Is this a battery? Oh, okay. So this battery block is a block which we use for state flow. It is not actually a Simulink model. So this is a problem. So the battery block which I have chosen is from here. This is the path. So it is from electrical domain under specialized power system and it comes under sources. Okay, so this is your panel. So what I'm going to do is I'm going to enter into electrical components in Simulink. Under sources. Okay, it's in electrical specialized power system. let me directly try electrical. Electrical systems under motor control block set. Motors, inverters, no. Specialized. So it comes under Simscape. Maybe that's the reason you are not able to access it. So those who have Simscape, Simscape domain only have it. So directly go to Simscape. See, in your library, please check you have Simscape domain. Simscape is over here. Under Simscape, electrical, and under electrical, specialized power systems, and under that, source. So here you will be able to find the battery which I'm talking about. I have two raised hands. Let me give you access for this. So physical system modeling. Yeah, so this is the product, right? So 30-day free trial. You can just download it. So this will give you or this will help you to download. So this MATLAB Simulink, everything will come under the same package. I'm not sure whether we can get it on add-on. Maybe you have to delete Simulink, but we need Simulink and Simscape together. You can try Sai Rajesh. I haven't tried with add-ons. Not sure whether add-on is available. Okay, I'm just resharing it. So this is the battery model which I have opened. This comes under Simscape, electrical, specialized power system, sources. In MATLAB Online, open Simulink blank model, then go to the library browser and then open the battery model. Whatever we have discussed so far, please continue the same thing. Okay. Yeah, for those who are waiting, I'll just get started. Okay, now I have a battery pack. Okay, so look at the figure. Okay, I'm just magnifying it. This is the positive and the negative end of my battery. And I have two connections, or I can make two connections. And I have one more connection at this side. So if I'm rotating the battery, so how you can rotate it? Click on the battery, Control R. You can rotate the battery like this. Everybody please try. Click on the battery, Control R. You can see the battery is getting rotated. So the battery can be rotated as per the diagram which you are drawing. So if you want the connections to be, the plus and minus to be on the left hand side, you can do that. Or if you want to start the connection from right hand side, that is also done. Like it depends upon your perspective. Okay. Now, first, when I'm taking any block, the first step is that I should identify the input port and the output port. What does it mean? I'm going to make a connection here, right? So I should know from where or which block should come to input, which block should come to output, which is the output side and which is the input side. Now, can you guys tell me which is the input side here, which is the output side of this block? If there is no input to the battery, from where does the current comes? How we are charging the battery?
Let's have a quick quiz question, guys. What type of plot is more suitable for displaying the distribution of data values? Line plot, scatter plot, bar chart, histogram. Please mention your answer in the comment section.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards the career growth.
M is the output and plus and minus are the input. So first step is completed. You identified which is the input and which is the output. Okay. Now, for simulating this one, yeah, so we have to see, just imagine a battery, right? So it has plus and minus, and you connect the wires, or if you want to connect a motor, what do? You take out the wires from the motor, you take positive and negative, and you just touch the terminals of the battery, right? Then it starts rotating. Similarly, This is the input side. Okay. Now, what should be the input that should be given to this battery? What I'm trying to get here is a SOC, isn't it? So what should be my input? My input can be the pattern in which I want my battery to discharge, isn't it? Or I should provide a load to the battery. In pure English, if I'm just connecting a load over here, I'm connecting a motor here, or I'm giving a data, a set of values in which my motor is working. So that is the speed value of my motor. According to the speed value, the battery will show me the discharging curve, isn't it? Are you following? Like anybody has doubt regarding the second step which I have written, pattern in which I want my battery to discharge, or I could say load. I have to connect my load here to the battery. Or I should give a data to the battery, right? Some data, input data to the battery, or the pattern in which the battery should be discharged. Plus and minus are input for this particular model, because input means the data which we are providing from our end. We cannot see the discharging curve of a battery if we are connecting anything to the plus and minus terminal, isn't it? So how do you just understand the discharging curve? If it is a hardware, you let's say if you want to understand the voltage, you just connect a multimeter, isn't it? Sai Rajesh, the context is you don't connect the load to the input. So load means what? Some data which should, or a system which drive another system, isn't it? Did you get the context of this? Load here is the system which drive the other system. So if I'm connecting a battery to a motor, motor is the load. Where will I connect the motor? To the input of the battery, right? Are you getting my point? Ha. So that is the same perspective we are giving over here. Okay, so if plus and minus are input, then what will be M? It will be the output, right? It will be the measuring port. So if you want to see the output, that is visualized, or that is seen from the M port. Okay. Okay. How we will charge the battery? So if you are providing an electrical source to this end of the battery will get charged. So that's what we are going to see. Okay, don't worry. Let's start with the modeling part. Okay, so here I am going to give a constant block as the input, where I am just giving a single data. Okay, let's say 5. Basically, I am giving a data given to the battery that I want 5 ampere from you, or you should discharge 5 ampere to the load, whatever load is connected. Let's consider this constant block is a system which is taking current from the battery. What is the amount of current that has been taken from the battery? 5 ampere. That is the meaning of this block. So please take a constant block and provide the value 5. So how can you take a constant block? You can just double click anywhere and you can just simply type constant and take the first one. Otherwise, you go to library browser and take it from the conventional method. Okay. And how can you give the values? Double click on it. The constant block will open up. Then you can give the value 5. You can ignore all these things. We are not going to interpret, vector or sample time and all. Just provide the value 5 and wait for the next instruction, please. Okay. Now see the constant block. Can I connect this constant block? Is there a suitable connection which I can make? Because the constant block has only one port. My battery has 2 port. So just because, I have one port over here, I cannot connect it Here also. Can you try connecting it to the output here, measurement port here? See, measurement port is supposed to be output port. Can you just try to connect it over here? Tell me whether it is connected. So how can you connect it? Just click on this point, drag it with your mouse pointer. You can just drag it. You can play it with. So the red line meaning that the connection is not established. Can you try connecting to the M port here, measuring port? Is it working? Anybody is able to connect? Please let me know. Not possible. Correct. So why is it not possible? It is not compatible, right? So integrating the blocks also need the level of compatibility check. If a certain block has 2 port, then it can be connected to a similar block which has 2 port. And if it is only has an output port, or this constant block is a source, right? It has only input. So I can add it only to the input side here. That's the interpretation. Now I'm clicking on it, rotating it so that it looks more neat. I can just connect it like this. Again, I'm not saying that I'm going to connect the constant block over here. It is just an input which I have defined. So instead of constant block, I'm going to write it like input current, meaning that I want 5 ampere to be discharged from this battery. That is the meaning of this constant block. Okay, constant block, you can see the compatibility. So if I am going to a constant block, let's say this one, right? So this is also the same constant block. It comes under, okay, block parameters are almost same. So when you look inside the configuration setting, that actually defines which block you want. So if you want to work on some sample timing, if you're working with a model or a component which requires fine tuning of the sample time, then you should be going with this block, like DSP block. Otherwise, if you're just looking for changing the value, it will be the same thing, right? So here it is provided infinity. We are not going to change anything over here. Only compatibility you have to check is like whether this is black in color. So all the blocks that comes in black in color is compatible in Simulink. Let me just show you something. Okay, DC. Let me see whether this comes under Simulink. So if you go for Simscape block, okay, let me take the battery itself. So table-based battery, right? So this comes under a different color. So this is not compatible. Why? Because this comes under a Simscape domain. So if I'm trying to do, or if I'm trying to connect the constant block over here, that throws an error. So that practice you will get once you keep on working on the model, that logic you will be getting. So till now, we have just taken a battery block. I have identified the input port and output port. Now I'm going to see what is the pattern in which my battery is discharging. For that, I have given an input current data of 5 ampere. Okay, I haven't given any ampere over here, but I'm assuming it is 5 ampere. I'm going to take 5 ampere, or I'm asking my battery to discharge 5 ampere. That's all. Okay, this is the context. Now, see, if I don't have any compatibility of connecting this to the battery pack, so there should be somebody who is able to communicate that, hey, battery, somebody is asking you to discharge 5 ampere per hour, or your capacity should be discharged as 5 Ah per hour, right? So somebody has to mediate to the battery saying that this is what happening at the input side. Now, for that, I'm going to take one more block, which is called controlled current source. Again, there are different types of controlled current source available. You can see the first three one. Believe my screen is visible with the pop-up screen of controlled current source. Or you can simply type controlled current source in your blank model. And, please wait after you type controlled so you can see the options. First one comes under the path of foundation library electrical source. Okay, now I feel like, okay, this is like matching with my battery block, which I have taken from electric and electrical source. Next one is control of source. No, that's not I'm looking forward. I need only controlled current source. I also have one more controlled current source over here. That comes under electrical specialized power system source. Okay, so I clicked on the control source, which I got the path from specialized power system. Okay, I'll show you like other measurement current control block also. Okay, so this is the second type of current control source which I have taken. I mean, which actually gave me option. Then I have current sensor, current control, electrical sources. Okay, it's the same. Now, let me check if there are any other source. So I'm typing controlled current source. Yeah, current sensor is there. No, I don't want sensor. So controlled current source. Okay, what is this one? See, three types of controlled current sources available. Okay, so which one I'm going to take? What do you think? Which one will be compatible with this model? Rajat, black one. Okay, yes, that is correct. First one with S. Second one is dependent source. Correct, correct, correct. Everybody is correct. Yeah, so you understood the requirement, right? And you identified the components. The first level is perfectly aligned with you all. So this I cannot use because it is a dependent source, right? So this dependent source is not going to do any good to my model. I don't want him. So in my model, I don't need him. But these two guys are almost similar. Only difference is that this guy has a configuration. Like I cannot configure anything over here. This guy also is not configurable, but this model actually is blue in color. That means there is something mismatching with the domain I'm taking. Okay, so this comes from Simscape physical modeling, which will not be compatible. I'll show you how. Even if they both look similar, if I'm trying to connect it, this will not get connected because it is different domain. So domain-wise compatibility is a necessary and component-wise compatibility is also required while you are drawing the circuit. So in that way, you will understand which block, which component is compatible with the design which you have taken. Okay, so I'm not going to use this guy also. I'm going to delete him. Okay, my final guy is this guy. Now, how should I connect it? He has three ports and my battery has only one port. How should I connect it? So the constant block, which see, why did we take this current controlled current source? We need a mediator to say that, hey, somebody is asking you to discharge 5 ampere, right? That was the reason we hired this guy, or let's say we kept this guy as a mediator. Now, for mediator to speak to battery, he should be having a connection with this guy, right? The first system. So that's perfectly correct. Uh, how does I should like connect it to like this? Will it be right? Okay, fine. See, what is this connection made? Positive to positive and negative to negative. Do you remember any type of connections which we have studied in our school days or college days? If I'm connecting positive to positive and negative to negative, what type of connection I'll call it? That's parallel connection. But if I am connecting it parallelly, the mediating or the communication will not be proper because parallel connection is not the way we are looking into, right? So parallel means what? In first string, the battery will be there. The second string, the current controller should be there, right? No, I want this to be in series contact. Then only this guy can properly communicate to the battery that, okay, somebody is looking forward you to discharge 5 ampere. So what I have done, it's simple. If you want to see the discharging arrow, keep this arrow pointer downwards. Make it as a series connection. Okay. So my guy who is the requirement, or let's say who is the client or customer or load or anybody who want the battery to discharge 5 ampere sits here. Somebody is mediating the requirement that, hey, battery, please discharge 5 ampere, sits here. This is the connection I should be making. Okay. So it just means that it's a current control device. It's a symbol. That's all. So I don't have any other comments on this. It's just a current control device. So see, you remember we writing a current control device while we are, modeling in circuit, right? How does it look like? It is a symbol of current control device. Let me just write it. See, when we are writing the circuit diagram, we write, these type of symbols, right? So in circuit network theory, what does it mean? It's a current source, something like that, right? Okay. Moving on. Right. So the connections is like almost completed at the input side. Now I want to see the results over here, right? This is my output side. I want to see the results. How should I see the results? Which block should I use? If you have good memory and if you haven't missed what we discussed last week, which is the block I should be taking? Can you please put down in the chat box? Super. So Yash, Ravindran, perfect. Okay, display actually displays the number, but here we are going to see the pattern in which my charging and discharging happens, right? So here it is discharging. What is in my context is like I'm going to only look at the discharge current. I'm going to model this entire diagram so that I can see the discharge pattern. I'll also just tell you like how to look at the charging diagram that we will, come into the later part of this model. So we will keep on calibrating this model according to different requirement. Okay, don't worry about it. So what I'm going to do is like, I'm going to add a scope over here. So everybody please take a scope. Here my block came. So Control R, rotate it. Okay, perfect. The connection has been made. So this is a very simple battery model, but this is not complete yet. So mono S is nothing but it is the port, or let's say it is the input port of the current control device, which actually can be connected into a source. Basically, it means source, like it can be integrated with the concept of source block. Here, I'm using a constant block as a source block. Done. Super. Okay. See, the first part or the initial part, only the 25% or 30% of modeling is completed. Okay, 40% is completed, not even half. What should I do? I should explore this battery block, right? I cannot simply keep this battery block and ignore the design inside. Let me just explore what is happening with this battery block. Double click on the battery block, go inside. What I could see, this is a lithium ion battery. So this is supposed to be a lithium ion battery, meaning that you should assume this is a lithium ion battery we are modeling. If you want to make it a nickel cadmium battery, you can click on this drop down, click on nickel cadmium. It will give you corresponding configuration. No, I want to keep it as a lead acid battery. It changes. I want to keep it as a nickel metal hydride, meaning that using this block, you have the accessibility or flexibility of modeling all these batteries. Like you can assume this can be a lithium ion battery, lead acid battery, nickel cadmium battery, or nickel metal hydride, NMH battery. I am going to see it as a lithium ion battery. You can also see it as a lithium ion battery. Now, I can simulate the temperature effects, meaning that your battery gets heated up. If I want to see what is the dependency of temperature, I can also try to do the temperature effects. Okay, for that, again, I should make the configuration settings. Like I should go for a different configuration settings. So this step, please keep it on hold. We will come back to this, revisit this step, and we will do it once we set the initial part of the battery. I can also do the aging effect, meaning that, how much time the battery will get discharged over a time period. That also I can check. So that also we'll see in the later part of the session. First and foremost, the first part, I'm only concentrating on the voltage level. If you remember, we talked about the voltage level, right? By default, there is a voltage level given here, which is 7.2. Okay. If you want to change 7.2, you can do it. If you want to change the capacity of the battery, that also you can do it. Initial state of charge, meaning that the battery is completely charged here. You assume that you assume that the battery has full charge. Okay. So we are going to see the discharge characteristics. So let it be full time. Battery response time is something related to the battery modeling part. You can create a variable here, but I'm not going to touch it. So if you want to, create some response modeling over here, you can do it, but not going there. It's not a fundamental way. Let me keep it default. Don't touch the battery response. Okay. Right. So few of you have questions about ampere and ampere hour. What do you mean by ampere? Ampere is a unit of current, right? Ampere hour meaning that for any battery, how do you define the capacity of the battery? That unit you call it as ampere hour. In other words, you have a battery which can store, get 1 minute, you have a battery which is capable of, and my battery is storing energy, isn't it? So it is storing energy in terms of charge. I'm discharging I'm discharging or using the charge that is hold in the battery with respect to time. Okay. So I should be running the battery, or I should be seeing the discharge characteristics in terms of how much is the current flow or current usage from the battery, from this load with respect to time. So within 1 hour, how much is the current which was utilized from this battery? That's how I understand the battery discharge. That is what called as AH, ampere hour. Basically, it's like current with respect to time. Okay. Yes. So go inside your battery pack and please give any voltage level which you require. I'm going to keep the same level, same default value, 7.2. I'm going to keep the same. So if you want to change the voltage level, please do that. You are free to do it. Let me share my screen again. Battery. Yeah, so I'm going to keep 7.2. That is a voltage. Voltage means the potential difference between the positive and negative side of my battery. Then rated capacity, meaning that this battery is capable of providing 5.4 ampere on standard rate within an hour. So if I am discharging the battery in normal way, like just keeping it discharged, then this battery can go into 0% within an hour if I'm taking 5.4 ampere. That's the meaning. Is there any battery voltage limit and capacity limit? Ravindran? No, you can just assume your value. For EV, basically, if it is a low voltage battery system, we go till 60 volt. 60 volt itself is like high. 48 volt you can use, or if you are using a high-end battery, if you are assuming that you are taking a high-end battery, then it will be like 200 to 400 volt. But while you are configuring your battery, while you are providing values for your battery, that should also match with the input value which you are giving. If you are providing the battery voltage like 200, and if you are only draining 5 ampere per hour, then it will take a long time for the battery to completely discharge, right? So have some compatibility with the input load value and the battery voltage level which you are keeping. So it will be easy for you to understand during simulation. Average size of the battery dimension, it differs according to the spacing and the vehicle size. The architecture can be anywhere from 200 volt to 900 volt. Currently it's 200 volt to 800. Now research and development is working on with respect to wide band gap device power electronic system, where the architecture can even be increased into 900 volt. So let's say 200 to 800 is the standard. Yeah, thank you. Right, so I'm going to keep it 7.2. So if you want to just keep it the same, fine, do it. Then go to the discharge parameter. So first I was checking the parameters, then go to discharge. See, the battery itself has a lot of, internal parameters: maximum capacity, cut-off voltage, full charge voltage, nominal discharge, internal resistance. See, while you're looking at a single component, there are a lot of values or a lot of dynamics which you have to understand along with that component. Okay, do one thing, go to the discharge. I believe everybody is looking at the discharge tab of your battery. There is a plot icon over here. To the bottom, there is a plot icon. Click on the plot icon. So I'll repeat. What I have done is like I went to the discharge tab, which is next to the parameter tab inside battery. Then I scrolled down, or I just came down to the part where I could plot it. So there is a plot button over here. I'm just sharing my screen. You can see where my mouse pointer stands. That is plot. So click on plot. See, basically, battery response time, it the value actually represents the dynamics of the battery when you go for equivalent modeling of the battery, meaning that while you're using capacitor and resistor to model the battery, there is a step unit time where you add over there so that each time the component responds in a certain step interval. So that is what is called as a battery response time. So here it is a scalar quantity which we are using. So usually we don't change it or we ignore that part. It's not going to do any much change in the entire model. But if you are inspecting the model or building it in a equivalent circuit level or and parameterize each and every behavior of the battery, like temperature, SOC, SOH and current, there you can change the value of battery response time and you can see a small difference in the performance of the battery, the equivalent performance of the battery. That's what it's called. It might be confusing to you. For understanding more about the battery response time, we should be modeling it from scratch. Like equivalent circuit modeling will be the right model where you can understand more about battery response time. Okay, so this is basically converting the values that comes over here into an equivalent current value. Same like plot, huh? Let me go back to my, let's just talk about our battery model itself. I'll try to make some sense from the battery model. See, I have given a value of 5. Now the battery doesn't understand what is 5 because 5 is kind of a demi value. Okay, it doesn't make any sense. If I go to battery and say 5, the battery doesn't understand. Okay, what do you mean by 5? It's just a value. But if I'm going through the current control block, that makes sense. Like what I am speaking is about current or 5 ampere of current, or the value 5 represents current. So this is kind of an equivalent block that makes sense while I have a demi value. So together it should be read as 5 ampere. Does it make sense? Say it now. Clear? Super. Okay. So let's move on. Few of you are very excited to see the SOC charge. Okay. Yeah. So we just connected scope and everything. So I was just talking about the plot. Not sure why you are getting an error on the plot. I'll just see whether I can just fix it. So your plot looks something like this, right? So if you have got your plot, I'm just elaborating my plot. This is the plot which I'm getting. So this plot, we call it as OCV. Open circuit voltage. You might have heard about it. What do you mean by open circuit condition? It is a condition that occurs when you have not connected any load, or your battery has an open terminal and you are simply measuring your battery. Okay, that's the meaning. So this curve actually represents the characteristics of a battery in an open circuit condition. So there you have the nominal voltage area here, which is the average value the average value which you can access from the battery. So I cannot access from 8.2. So this area is considered as a residual area where you will not be able to access the charge. Okay, that is a manufacturer trick. You will be able to access the charge only in the nominal area. That's called the average rating of the battery. And this is the curve, or this is the pattern in which the battery actually discharge. Go back to your battery block. You could see that there is an option called discharge current. Okay, look here, discharge current. Discharge current meaning that the value of current which you are trying to get from the battery or discharge from the battery. What is your total capacity of the battery? 5.4. But here you are trying to get more current from the battery because the load connected to the battery demands more current. Now, going back to the plot, that plot actually represents the way in which the current is being discharged. So look here, you can see what will be the condition of the battery. If I'm taking out 6.5 ampere, see the blue color, my battery will be discharging within 50 minutes of time. What I'm taking? 13 ampere of current from the battery. So if I'm taking 13 ampere of current from the battery, it will be discharged within 30 minutes itself. Okay. And what happens if I'm taking more current, 32 ampere, 32.5 ampere? That also will be resulting in the battery discharge within 10 minutes. Just imagine you're using your mobile phone, the gadget, if you are keeping it in idle condition, like you are not that much using it, if there is a call coming, you are using the phone and talking, then what happens to your charge? So the charge will be holding it for more longer duration of time. So assume that 6.5 ampere is the load current which you are using when you are opening WhatsApp, Instagram, LinkedIn frequently, and you are typing text messages to your friends. Now the battery gets heated up, or the requirement of different circuits that is displaying will be more. So more current is required, and more current is being retrieved from the battery, isn't it? So that becomes what? Your SOC will be dropping suddenly. In the previous condition, if you have not used battery that much, if you have used it only for calling, if that lasted for 12 hours, if you are constantly texting or using your gadget, that can reduce your SOC to 6 hours. Just giving you a demi number. And what happens if you are playing game? So you are calling, you are texting your friend, you are playing game, you are editing something in your phone, that becomes overloaded. Now assume that in that case you are using 32 ampere of current from your battery, existing battery. Your battery will discharge immediately. Even if it is not in 10 minutes, it can discharge immediately, right? Because the battery capacity which we are considering here is 5.4. Your battery is not laptop battery or mobile phone battery is not that much. It will be like more or less similar or more. So it will not discharge within 10 minutes, but this condition can happen, right? That is what you have to understand or read from this plot. That's it. Okay. So you can also have, you can also read how does a OCD plot looks like from plotting the battery. So I'm doing this to make you acquainted with the block. That's all, right? And now I'm going to, directly go and simulate it. So I have a input saying that 5 ampere, give me 5 ampere. I'm going to see if I'm taking 5 ampere out of the standard rating of 5.5 capacity, how does my battery discharge? So I'm going to simulate it for 1 hour. So when I'm converting it into seconds, so simulation time over here, the stop time represents in seconds. So I have to just give it as 3600 seconds. Now I have to run the button. Okay, I'm keeping a power GUI here. So power GUI is an interface which help you to check the compatibility with all the blocks which I have used, and create a similar action inside the simulation engine. That is the use of Power GUI. So you can also take a Power GUI over here. It's a GUI interface in MATLAB. Okay, please type Power GUI and you can take a block from there. Okay, so this is the block I'm using. It is called a solver. So if there is any kind of miscompatibility inside the equations or mathematical modeling of each block, which is not visible to us inside, then that will this will match the gap, or this will make the compatibility when you are solving it, or let's say when you are running it. Okay, so this guy who is sitting at the bottom side, you call it as a solver. Solver means that he will check each of the formula which is there at the back end of this block diagram, and the formula is being solved mathematically. Why I have changed the time is because I want to simulate the battery for 1 hour. So if I'm simulating the battery for 10 seconds, that doesn't make any sense, right? So I want to see what is the discharge curve. And for that, I want to simulate it for 1 hour. 1 hour converted to it seconds, equivalent seconds, it is 3600. So here stop time, it is taken in seconds. Okay. I believe Power GUI has been connected. So the model is not completed. It's 50% complete. We have to do a few more reconfiguration. We'll see. But this will run. Okay. Run it. And you can see it is compiling. That means that the solver is checking the compatibility and checking whether we have done everything right. Okay. It is mathematically solved by this guy whom we call it as solver. And the step size in which it solved it is 72, right? So everything like in Simulink, whatever you are doing as simulation, that has been solved mathematically. Okay, nobody is jumping into the performance of the block, or nobody is jumping directly into simulation. So how does simulation work? The simulation work with the help of solvers who actually do mathematical formulation and mathematical modeling and with the help of the formulas, right? You can use any kind of formulas. I mean, not any kind of formulas, like the engine itself have saved certain formulas. So they use that formula to solve each block and understand its performance, and then we'll give you the output. That's how it works. Okay, we'll have a session regarding the solver. So in that, it will be like more clear. Yeah, so Power Query is not connected. So it is just an interface, or let's say it is a block which will help you to solve your circuit. It is kind of a backup block we keep to solve your circuit. So if there is any kind of mathematical miscalculation or any kind of compatibility issue with the blocks which we have used, Power Query block will allow the solver, or it will help the solver to solve the equations or run the model smoothly. So it need not to be connected. I hope you have simulated it. Did you notice anything over here? Can you tell me what did you notice? Something changed over here between your battery and scope. 3 lines. Perfect. You are getting 3 output from the battery block. That's why you are able to see 3 lines that is coming up here. Okay, is it, I believe this is visible. Let me magnify it. Okay, this is 3 lines coming out from the battery. Means there are 3 parameters or 3 outputs that are coming out from your battery block. Can you open your scope and check like which are the 3 parameters? Click on the scope. Does it make any sense? Can you tell me which one is which? What, can you read your results, please? Doesn't make any sense, right? Yellow line, red line, and blue line. That's how I will read if I am a fresher or if I am very new to this model. I'll simply read it like yellow line, blue line, and red line. But somebody who is very intelligent have read it like SOC, voltage, and current, Abhinav. Great. But so the 3 results which you are getting over here, those are SOC, voltage, and current. But again, it's not in a readable format, right? You're not able to understand which one is SOC. Maybe if you're looking at it very closely, you can at least understand, okay, this is SOC, right? State of charge, because we have kept it for discharging. We are getting a discharge curve, linear discharge curve over here, constant discharge curve over here. Okay, something can be like read from the diagram or interpreted. But I want to make it very clear. So if I am teaching you like this, if I'm saying that, hey, this is the result, we are going to close the model, we have done the model, will you be satisfied? No. This results should be in a printable form or readable format. For that, first I should make sure that I have proper title for these parameters. Okay, so for making it into proper title, I'm going to take one more guy who is called bus selector. Participants, please help me to get this guy. So I'm going to take a block called bus selector. So bus selector is a block, or it is basically like a demultiplexer, right? So it will help to disintegrate or differentiate the signals from a single source. I'm going to keep this guy in between. So I'm going to delete it. Backspace. Okay, I'm going to keep this guy. Click on, it is auto rotate. So, okay, here I have one more problem. So, in my scope, I can only see 1 results or what? No, I can keep no more results. Just drag and drop it. The scope will automatically throw you the input port. If I need more, okay, I'll just drag it from here. Okay, it's not coming. Okay, let me just take only 2 signals as of now. I'll help you with the 3 signal. Let me know once you have got this guy. This guy is called bus selector. This block is called a bus selector. The first one, take it, keep it in between your scope and your battery and give me a thumbs up. Now, click on this bus selector, double click. Go inside. Look at this guy. So he is holding how many signals? 3 signals. Okay, I'm going to click on the selected elements. Delete. Because I'm going to add the fresh signals over here, right? So I don't want anybody who is from spillover. I'm just going and clicking and delete. Somehow my delete. Oh, okay, it is working. Okay. So click on SOC, which is state of charge. Click on SOC. Click on select. Now you can see selected elements is SOC. Click on current. Select. Current will appear. Click on voltage. Select. Voltage will appear. So coming back to you, Mono, if you do not want all the 3 parameters to show up, you can deselect any. You don't have, you can delete any of this. You just want to look at only SOC. You don't have to keep it under selected elements. So the case is like the battery is holding 3 parameters. The battery is providing you with 3 parameters. Okay, the output will be always 3 parameters from the battery block. If you want to view it, you can view it with the help of bus selector. If you want to view it only with one, if you want to work on only one signal, then just go with a single signal. Okay, you can, whichever signals you want to view, you can keep it in your selected elements bucket. You can see it in the right hand side. Click it and add it. Select. Okay, I want to see all of them. So I'm just keeping it over here. Now what should you do? Apply. Okay. When you apply it, go to your model and see what happened. So what I did, I selected all the components over here. And when I clicked apply, something over here happened. See, it actually named itself. The first signal, it's called SOC. And let me click on the voltage. Where is my voltage? Okay, if I'm just giving it, okay, this is my current, right? So my current is the third signal, voltage is the second signal, and SOC is the first signal. Oh, I'm going to just make it, more visibility. I'm just dragging it and making it in a form where it has more visibility. Okay. Yeah, let me know once this is done. So what I have done is like, I just selected the elements in my bus selector. I clicked on apply. My connection to bus selector still have 3 lines. See, why? Because the bus selector is a component which is used for that purpose, right? So this is kind of a demultiplexer. It has only one port, right? So this is one thing, and it will split the signals. So from the battery, all the signals are combined together in this line, and the bus selector is splitting it into 3 signals. Okay, so let's simulate it and let's see what is the result. So see, just making the changes in the model doesn't give you a result. Again, you have to simulate it. Okay, again, you have to run the model and check the output. So let's run it. Click on run button. Make sure your stop time is 3600 seconds, which corresponds to 1 hour. And look at your scope, please. Again, I'm not happy with the results. Why? Because I can see SOC voltage and current. Still, I don't know which one is who, right? For that, I'm going to split them over here in the scope itself. So go to this gear button. There is a small gear icon here, and there is a small key or arrow adjacent to this gear icon. Go to the third option, layout. Select 3 layouts, like in this layout or in this way, like horizontal or vertical way, whichever you would like to see. Select 3, click on it. Now you can read it more clearly. How does it looks like? Okay, my scope just went away. 1 minute. Where is my scope? So my scope is here. Yeah, so I believe you have followed me till now. What I did, I just went to this gear button and I clicked on layout. Okay. So I can also go to layout from the view. Okay. So I'm keeping a legend over here. So yesterday you remember what is legend, right? I can write something over here that represents what is a parameter. So go to view. You can also take the layout from here. Gear button was a shortcut. You can also go to legend. Keep the legend on so you can clearly see, read your parameters. And next part, go to this icon which is next to the magnifier. Click on the small arrow. I'm holding here. Please, everybody look at my screen. Look at the mouse pointer. Go to the scope. Next to the magnifier, under the help option, there is this icon which has arrows pointing upward and downward. Click on the small key and click on the second icon, which is scaling, proper scaling, or you call it as auto scale. Click on it. Please put a thumbs up if you are able to see a scope result, something like this. Here is our result. We will read it. We will read the result again. So this is visualizing the result. And if I want to change the background, I can go to the color option. Okay, what did I do? I just went into the gear icon. Second option, style. Okay, properties. I want this to be red color. Line visible. Yeah, that is fine. Axis color. Okay, figure color. I'll make it. Okay, let me try. How does it look like? Okay, axis changed. No, I want it red. This one. Okay, my axis is better now. And oh, this is very bad. No, I don't want this. So let me just keep it like this. Oh no, I'll just go back to same plot. Yeah, it's too much white. Okay, otherwise I can just keep this one. Okay, so I'm just playing with the color option in my style button in the scope. So where you can find the style button is like you can make your results, like the graph, more presentable. So go to the gear button, go to the second option, which is style, click on it and just explore it. We'll just explore it for 3 seconds. We'll see like how we can just make this more beautiful. Okay, axis color is fine. This is fine. Figure color. Okay, plot is auto. Let it be the same. I'll check. Okay, this will be too much, but let me try. Okay, too much. Okay, my SOC is fine. Active display, I'm changing it to 2. Let me change my voltage. Hey, I'm not doing anything very serious over here. I'm just changing the color of my layout. That's all. You can do it. You can just try along with me. You can give different colors. You can just play with this style scope. So if you want to see the charging plot, then you should be keeping a scope. I can keep a display. Display is the block which I would like to keep. So SOC current 5. I'm just connecting it along with the output. Yeah, simulating it. Yeah, so I'm getting some results over here, right? So this is the last value which is represented in my plot. So I can also keep display. I cannot see the way in which it is discharged, but it is possible. So this answers to Ashok. Shakti Dev, yes, I'm coming to that point. Why it is not failing. Now I'm going to read the scope results. If you have just, done playing with the results, let's get back. Even though my layout looks very bad, let me just make it default. Okay, so see, I want you to understand something. What was the value which we have given initially in our input? It was 5 ampere. What is the capacity of the battery? 5.4 ampere. So only if I'm giving 5.4 as my input, then the battery will be completely discharged, isn't it? If I'm giving 5 ampere, that means that my battery still have some charge after 1 hour. So this is the value of the current I have retrieved from the battery. This is my voltage graph or voltage plot, and this is my SOC. So SOC is not zero. It will not touch zero because I have not completely discharged the battery. If I want to see that, I should increase the time limit. So let me keep it 4000 and run it. Go back to the scope. Now my battery touched SOC, I mean zero value at around 3000 something, right? It didn't even touch 4000 before getting into 4000 or before simulating for 4000 seconds. My battery got completely discharged. If you look at my voltage profile also, it changed. It just drastically came down to zero. That means my battery completely died off. Okay. So it depends upon the input value which you are giving and how much time you are simulating it. So ideally, my battery was 5.4 ampere capacity, and only if I am giving what does it mean? 5.4 ampere capacity meaning I can discharge the battery with an input value of 5.4 for an hour. Okay. Now do one thing. Let's keep it 5.4. Okay. Everybody, you can change it to 5.4. Change the input into 5.4. Click apply. Okay. Go back to your simulation time, 3600. Keep it for 1 hour, run it. It's layout. View, go to layout, select the layout in this way or this way, click on it. Or gear button, it's both same. Go to layout, select, click on it. And if you want to keep this one, this is called legend. Go to view, legend, click on legend. And if you want to bring better view or scaling to your result, go here, auto scale option, scaling option, which you can find just under the help option in the toolbar. This one, click on it. Or if this icon is not coming, click on the small arrow down key and find this option. So I should be seeing 4 arrows pointing towards 4 direction. Okay, scaling X and Y axis. So in that way, you will get a better plot. Go to your scope. What I have done is like I changed the value of input to 5.4. I kept the simulation timing as 3600. Then I simulated it. Then I went back and checked my results. Now I could see that my battery has discharged perfectly to zero within an hour. That means my standard rating has been satisfied. See, the input which I have given is 5.4. That means I'm asking the battery to discharge 5.4 ampere in an hour. How it is in an hour? Because the stop time which I have given over here is 3600 seconds, which represents an hour. Okay. So that means I have asked the battery to discharge 5.4 ampere in an hour. So 5.4 ampere is the max rated capacity that is already given in your battery block. If I'm taking out the entire 5.4 ampere in an hour, what happens? The battery will be completely discharged. That is what showing in my scope. If you look at my scope results, look at the SOC part. The SOC starts from 100, meaning that from full charge, and it goes to 0 within how much of time? 3600 seconds. That means my battery is completely discharged. Is it clear? Now, change this value into twice the value of rated current. So I'm going to add asterisk 2, or you can directly go for 10.8, whichever works for you. Increase the value of input or the load. Simulate it. Go to the scope results. Now what do you see? So when I increase the load value, the battery got discharged within half an hour. Correct. That means the C rating has increased and within 30 minutes, my battery got discharged. I believe everybody followed. Okay, battery lasts for half an hour. That's correct. Kritvik, that's correct. Okay, now go back. Give the value. So let me divide it. 5.4 divided by 2. Apply. Okay. Run it. Okay, now can you read your results? What happened when I changed the input? The battery will take more time to discharge. So within an hour, the battery only discharged till 50%. And you can look at the current value over here. It's 2.7, which has been taken. The voltage profile changed. Now I want again to see the battery complete discharge. So what should I do? I should increase the simulation time, right? So I have increased the simulation time to two times. That is 2 hours. Now going back to my scope results. Now my battery will be completely discharged. Okay. This is how you have to read and interpret with the battery simulation part. It depends upon the design requirement, how much time you are taking or how much time you are actually assuming the battery to run, how much is the load capacity, how the battery will be discharged. So all these performance characteristics can be analyzed from the results by reiterating and calibrating the values. Prithvi, can you explain 5.4? Oh, it's simple, like my load has changed. Like I have given a load value of 2.7. Like I just simply divided 5.4 divided by 2. The rated capacity was 5.4. I gave the load as like half the rated capacity. That's all. So this is how you understand the battery performance. This was with a, what do you say? It is with a constant like profile, right? Or constant load. Now take this out. Let's keep a sine wave here. Type sine wave. This is the block. Add a sine wave. Simulate it. Okay, I'm simulating it for 3600 seconds. I didn't do anything. I didn't configure or I didn't do anything with the sine wave. I just kept whatever is shown in my sine wave. I kept it similar to that. And I got a very colorful scope result. So let me change. Let me change the intensity of the graph. Keep a sine wave, participants. That's all I have done. So just to ensure that it's not too much eye-catchy, I'm just changing the color. That's all. Color of my plot. Yeah, you guys can read your results perfectly. Yeah, apply. Okay. Now, how should I expand this? Go to the magnifier icon. In your toolbar, please go to the magnifier icon. Click on the small arrow. You can just expand it in x-axis or in y-axis. So let me get the x-axis. Drag a little. Perfect. So this is the result if I'm getting when I'm just giving a dynamic load, meaning that I'm assuming that my load is changing. It is like, taking a value from -1 to 1. So 1 ampere it is constantly taking. That's all. It's a dynamic value. It doesn't mean that I'm actually providing a sine wave to battery. If you do not understood the concept or if you do not agree with sine wave, I can also keep a different dynamic block which is called repeated sequence. Repeated sequence. Okay, so that is a block. If you are not convinced with a sine wave, let me just take a repeated sequence block. I'm just adding it over here. I didn't change any value. I'm not going to configure anything in the repeated sequence block. I would just like to show you how a dynamic response look like. So you can beautifully see how it is simulating. Okay, and where is my SOC? Huh. So my SOC is kind of linear, but again, it's not that linear, right? So see, my current usage, my current profile is changing. Like it keep on changing. My voltage profile is changed. And okay, let me just look at my SOC a little more carefully by zooming the y-axis and then zooming the x-axis. Okay, I can see a small steps here, right? It's not that clear, but okay, it has a slight difference. SOC is 0, current should be 0 or near to 0. No, see, current graph which we are reading here is just the input which we are giving. That's all. So current will not go to 0. It still keep on providing 5 ampere, right? So here we are not iterating the value of battery. Example, battery has 50 ampere hour. So each time it is drawing 5 ampere, the plot will not show you 50, 45, 40, 35. That will not be there. So that logic we haven't implemented, right? So we are not looking into that kind of a model. we are looking into a model where we are just understanding how much is the current retrieved every time. So this will not touch zero. But in actual case, yes, it will just drain off, and finally it will be like zero. Okay, so as I have told, it's like I haven't configured anything. I simply kept a block to show you, like, if you're not keeping a constant block, like how does it varies? How does a SOC varies, or how does a current profile looks like? That's all it means. Okay, so if I want to keep a more dynamic model, what I'll do is, like, I'll keep an Excel file here, or let's say I'll keep on adding something which is similar to a drive cycle. Okay, let me see whether I can take a drive cycle source over here. Let me connect it directly. Drive cycle, it is the data, right? So drive cycle is simply nothing but the pattern of driving, or I could say it is like speed versus distance, speed versus time. Okay, so directly I'm keeping a drive cycle here, but again, drive cycle data which I'm taking it over here is speed, right? This is not the right way to do it, but I'm just looking at a profile where it keep on changing, or a profile which will help me understand what is a driving pattern. Okay, please interrupt it in that way. The drive cycle data are speed versus time. If I'm connecting directly the speed value to the current source, that doesn't make any sense, right? Because speed can go up to 45, 60. That doesn't mean that the battery is actually draining 45, 60 ampere. But in here, I'm just giving you an example, like I'm changing the values, or input is continuously changing. Let me just run it. So this is FTP75 drive cycle, which is of 2474 seconds. So ideally, my result should terminate after 2474 seconds. Okay, now I could see a different pattern. Okay, look at my current profile. The current profile exactly match with the data which I have given in drive cycle. I also can keep a scope in order to show you how does my drive cycle looks like. Okay, this is how my drive cycle looks like. Okay, let's assume this is the current pattern which we are using to drain the battery. And now if I'm looking at my SOC, it is dynamic, right? It's like it has waves. It has ups and downs. So here I can assume that some recharging is happening, or regenerative braking is happening, right? Look at my SOC, it's not constant. It has a different profile as per the current. I can connect the signal to the same scope. So this replicates actually the current profile, right? So current profile and this one look same. Okay, so you can see the current and the drive cycle, coincided, right? Because I have kept only 3 layout. So both my legends show current and drive cycle. So let me keep 4 layout. So final is the drive cycle. This is the current profile. So drive cycle means that the way in which I'm driving the vehicle, or in this case, I will interrupt it like, okay, this is the demand of the current from the battery. And second one, the second current profile is like, it is exactly replicating my demand, right? So whatever I have given as the input, that is the same pattern in which the current has been discharged. And my voltage profile looks a little weird. It's different. So it actually coincides with my current profile. So when my current profile is 0, my voltage is again going back to the maximum level of 7.2. That's how you should read it. Then again here, when I'm not discharging any current, my current voltage profile is keeping it in the max. And looking at my SOC is having again a dynamic way of discharging, and finally it is discharging by end of 2474. See, it is all like by end of 1 hour, it's almost like how much? 10% charge left. It still did not completely discharge. It still have some charge left. But this is kind of a dynamic response which you can read.
Let's have a quick quiz question, guys. Which of the following factors is typically considered in a battery performance model? Voltage, current, temperature, all of the above. Please mention your answer in the comment section.
Just a quick info, guys. Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth.
Here is my blank Simulink model. It is a blank model. Go to your library browser. Everybody, you can follow the same steps which I'm just showing you now. Open a blank model, go to the library browser and scroll through the library browser. You will be able to find an extended tool set called Simscape. Simscape is the name. You can click on the small arrow button over here. These are the options or the components which are available under Simscape domain. Super. Okay. So initially, I would like you to understand what do you mean by a Simscape domain. As I have mentioned, this is kind of an extended library tool which we use for modeling. Modeling means what we have done in the last session. We dragged a few block sets. We assumed that those are the real components which helps us to build a system. Then we created a small system. Last time, it was about battery modeling. We tried to understand what was the charging and discharging pattern of a battery model with the help of certain components inside Simulink. Especially, we have used a battery block which comes under electrical sources. Then we took a controlled current source. Then we made use of bus selector, then a scope for visualizing the results. Then we did some presettings and configurations in the scope block itself for visualizing the graph more clearly, to read your results more clearly. We understood how to read your results, how to interpret your results. Then we changed the simulation time, we changed the input, and we observed like how output is changing. That the whole process comes under a common term called modeling. Modeling and simulation. So it is the same process which we are going to continue under this domain or this tool also, but there is a slight difference between Simscape modeling and Simulink modeling. So Simulink is more kind of a library which consists of tools which helps you in numerical calculation. Okay, but when it comes to Simscape, even though it comes under the Simulink version, or even though we can call it as an extended Simulink library, it is used mostly for modeling and simulating physical systems with multiple physical domain. So that physical domain means like mechanical, electrical, thermal. Rather than going or picking the blocks or components, we directly go pick the system itself. Okay, we are going to see it more clearly in the later session. So this is a basic difference, and Simulink actually helps in the signal flow, or Simulink block will be helping you to coordinate or integrate the blocks together so that there is a proper signal flow through the entire system. Or let's say the data, the numerical data for mathematical calculation is fed from one block to another while you are modeling with the help of Simulink block. But when it comes to Simscape, it is actually considered that the energy itself is being diverted or being fed from one block to another. That's the main difference, because you assume that you are using the physical blocks itself. Okay, so let's see like how it is going to work and what is the main difference you can see over here. So this is an actual model which you can see in MathWorks. We are going to open that model and inspect it. Next state. But just see the figure. These are part of Simulink modeling. And as I have told, the block connections represent signal transmission. All right. So signal has been transmitted, and that signal is transmitted from one block to another. It is more kind of a signal-based input and output modeling. Whatever you assume to give as an input, you assume it as a signal, and whatever you are visualizing in display or scope, that also you are considering it as a signal, right? And this method is more kind of a mathematical analysis, or you implement equations at system level. But with Simscape, if you look at here, you're actually using the physical component. So you create your model using the physical network itself. So this is the example for mass and spring damper in both cases. In Simulink, you have considered what are the equations that is governing mass and spring or mass spring damper model. But in Simscape, you have considered the actual components itself. For example, you have kept a translational spring, you have kept a translational damper, right? Here, you only implemented the governing equations that is considered to be this component. I believe you understood the difference between modeling in Simscape and Simulink. So continuing with Simscape, you create your model using physical network approach itself, and you derive the system level equation. Okay, so it is not necessary that you have to add all the equation, or it is not necessary this should be completely governed by numerical calculations. You can directly connect the components if it is available in the Simscape domain, and you can simulate it with the help of the values you are assuming. Okay, so this makes the modeling more flexible and easier to create rather than working on multiple governing equations, modeling it in a way that there are no errors, modeling it in a way that, okay, the proper mathematical computation is being properly integrated. This becomes more easier where you can understand and maintain the model in a system level itself. All right. So this is the basic difference between Simscape and Simulink. So in Simscape, the model built using the block is represented by physical components. The resulting model represents the diagram itself. While you are drawing a circuit diagram, the physical system on the Simscape model can closely resemble the circuit diagram. That's the point. Moreover, the fidelity of the circuit, the accuracy or the degree of accuracy of your result also is better while you are modeling with the help of Simscape. Where here it is more kind of prone to errors because we are using a lot of governing equation and mathematical assumption in order to build your system. That is the main difference between Simulink and Simscape. Okay, so I would like you to go to your library browser. I know that you are looking at the library browser. Just click on the foundation library. There is a small arrow. You can click on the foundation library. Please look at my mouse pointer. Here is my Simscape. So what I did, I'm repeating for the new participants who have joined. I have opened a blank model in my Simulink, and then I went to library browser. Then I scroll down in the library browser to find out my Simscape tool. And in Simscape tool, I'm just looking at my component level analysis. And first one is a foundation library. If I click on foundation library, electrical, let me see what are the options available for me. So you can also click on electrical library, foundation library electrical, and you can click on the electrical elements. Okay, so this electrical element is quite familiar to you because while we are drawing a circuit diagram, the components almost look like this, right? So there is a capacitor, diode, electrical reference means ground, then infinite resistance, open circuit, resistor. So a lot of components, thermal resistor, variable resistor, a lot of components are there under each category of electrical systems. Okay, I would like you to go through this library by your own. Please click on each options and explore like what components are available just for your understanding at the basic level. Here, you also have current sensor, voltage sensor under the electrical sensor option. Then you have electrical sources like AC current, DC current, dependent current, DC current source, right? And if you look at the color of the block, initially, while we were modeling with the help of Simulink block, it was all black in color because it represented a certain domain, or understand that as a separate domain or separate library under which those blocks can only be used for mathematical modeling. Whereas here, if you look at the components available, they are all blue in color. So electrical library is commonly found under Simscape domain in blue color. That's what you have to interpret here. So go through each one of this option. So I'm going to look at hydraulic now. So when I'm looking at hydraulic, you can see certain elements from hydraulic domain is also visible over here for me. But if you look at the coloring of the block or coloring of the components, that is again changed to brown. That means that under Simscape, since you are modeling it or since you are considering it as a physical component, there is a clear-cut division between which are the components that comes under electrical domain, which are the component that comes under hydraulic and mechanical, thermal, etc. That's what we have referred as multi-domain aspects in our slide. If you remember, there was a line written like Simscape is completely aligned with multi-domain components, meaning that there is a clear-cut division between which component belongs to which category, and this helps you more visibility while you are building your model. Okay, and see, this is our hydraulic, and hydraulic you can see kind of brown in color. So I would like to go to thermal next. I'm going for thermal sensors. So this is orange in color. Thermal components are orange in color. Thermal elements, you can see thermal mass is there, then insulator is there. So whichever component can be assumed that comes under a temperature dependent component or mass, that is been categorized into thermal components. And I could also go and check utilities. Utilities are the extra block sets which you will be using while you are modeling with Simscape. And we will look into it like where we are using this, especially like PS converter. We are going to see like where we are using PS converter and all. Look at battery, and these are some block cells which is available newly, right? So cell balancing technique can be used, thermal, electrical, everything is there, multi-body. And if you look at electrical itself, there are connectors. A lot of components are available as like a physical system. Okay, and if you go to mechanical also, you will see that the mechanical components are kind of green in color. So quickly go through this arrowheads and try to understand which are the domains that is available here. That will be fine for as of now, because this is very basic which we are learning. You can just understand which are the domains that is available and how you can make use of these domains. So in Simscape, as I have mentioned, it's not the signal that flows, it is the energy that is flowing. For example, if I just take a DC motor, which comes under, let me see, not sure. Okay. So if I take a DC motor, or those who have the Simscape domain, you can try taking a DC motor. You can see my DC motor over here, right? I'm just expanding it a little bit. See, DC motor consists of both electrical components and mechanical components, isn't it, Ravindran? So you can see the color coding clearly here that the mechanical components that is aligned with the DC motor, which we have to measure or integrate with the next block set, is colored as green. And the electrical component, which is assumed to have resistor, inductor, and EMF, is considered as blue. All right. So each block will have its own way of projecting which domain it comes under. Signal compatibility, meaning in different domain, you mean that, okay, whether if I'm connecting an electrical component to mechanical component, will it work? Yes, it will work, but there are certain rules in which you have to stick on to the port of connection. Similar to, let's say, if this DC motor has to be connected to a thermal component, that will work, but we should see whether the thermal component also have a compatible port for the connection. Okay, let me just pick up the modeling. So I want you to start, or I want you to understand how is it made. So go to your MATLAB command window, and I would see, just look at my mouse pointer. This is my MATLAB command window. Type mass and damper. Type mass and damper. Again, I'm repeating. This is my MATLAB screen. I just navigated to my MATLAB screen. The first screen which I see when I open the software, I'm moving my mouse pointer to my right hand side upper panel. There you can see a search bar. I'm typing mass and damper. You can see it over here and click enter. That will take you to a new page which look like this, and this is called the documentation page of MathWorks. So from here you can directly have access to open any models. If that model is already been built or created and added into the site, you will be able to open that. So the model which I'm looking at is the combination of mass spring damper model in Simulink and Simscape. So this is the model I wanted to open. Repeating, mass spring damper in Simulink and Simscape is the model which I want to open. Click on it. There is a blue headline, right? So the title has been given in blue color. If you just move your mouse pointer to that title, it will project by underlining the title. Just click on it. A single click will do. That will help me to open next page, which has all the description about the model. So I'm not going to read here. Rather, I'm going to open the model. Okay, click on open model. My model is opened. Please let me know if your model is visible. If you are very particular about opening the model only by typing the model name, or if you want a very quick solution for opening the model, instead of going through all the steps which I have currently shown, what you can do, you can write this name in the command window and you can click on enter. That will help you to open the model directly. Since I didn't know the name of the model, I went to the documentation, I searched for the model, and then I opened it with the respective command. Now you know what is the title of the model. You can directly go to your command window, and if you are providing the right name and click enter, it will help you to open the model. Super. Okay. Now I'll give you some time. Go through this blog. Whatever we have explained or whatever I have explained and we discussed, it has been shown here very clearly. So the Simulink model is shown with the help of the governing equation, as well as the Simscape model is directly being demonstrated with the help of the components. Now, this equation, right? So what is mass damper equation? A square x and bx. So that equation is being provided as a modeling part over here, and the component is directly connected in the Simscape. Okay, and you can also find out a few differences between the Simscape and Simulink. So this is a small exercise which I would like you to do for a minute. Go through the model, open the block. So when you're opening the block, it's simple equation. You can open this block and see like what are the parameters which has been given over here, and try to find out what is the general difference between modeling in Simulink and modeling in Simscape. So model name, you can see it over here, right? So this is the part where you give the title of any model. SSC underscore mass underscore spring underscore damper underscore SL. That is the name of the model. You can directly give the title of this model in the command window. If you are just clicking enter, it will help you to open the model. Okay, so everybody, you can just look at your, okay, this is throwing an error because I have cleared the variables, right? So I have to open it again. So if you have opened your model, what you should do is like look at your workspace, go to your MATLAB screen and look at your workspace, the B value and the K value, and also the P, K and M value, right? Mass M, spring is K and D is damper. That is being taken or that is mapped directly from the workspace. Okay. So that is something which we are going to see while we are modeling. So that is one observation that is perfectly correct. So here, if you want to customize anything or if you want to add any extra equation or mathematics into your model, or if you want to customize your equation in some way, in Simscape, it is going to be difficult because you are directly dealing with the component itself, the physical connection itself. So it is difficult. But in case of Simulink, the equations, the governing equations or any kind of extra equations can be added very easily, and that is why it is kind of a flexible model. So in Spring itself, you have to model the Spring, like what exactly are the parameters that is governing the Spring action. So while you are going behind the parameters, it is going to be a little lengthy. The block sets or number of blocks which you are going to use in case of Simulink will be always higher when it compared to Simulink. Great finding, Anju. And you are correct. There is an arrowhead, right? While you can see it over here, there is an arrowhead that is pointing out in which direction the signal is flowing. And also, if you remember, while we tried to model our battery, there were a lot of questions regarding, okay, why we are not able to connect the M port to the plus and minus, positive and negative signal, why we are not able to connect the bus selector in that way, this way, because there is a certain direction in which the Simulink actually access the signal. If it is an input signal, it should be going from the left, or let's say it should be going into the block. If it is an output signal, it should be coming out of the block. There is a definite direction, or the signal has been mapped in a certain direction, which is always unidirectional in case of the mathematical modeling in Simulink. While Simscape doesn't have that problem. Like it's like the energy flow. We are only talking about the energy flow. So we consider it as like bidirectional. Rather, there is one problem where if you look at the resistor or any electrical component, something which you can find here is what? Terminals, and there is the positive and negative terminal. So you cannot, or you should be having clear idea that, okay, where this should be connected. So if you are reversing the connection, then also the model will not work. So this is one thing in Simulink. Here, Simscape. So in Simulink, there was no kind of indication of this polarity of any component. So this is something which you have to be careful while you are modeling with Simscape components, especially in electrical. This has been of utmost importance, similar to a circuit drawing or similar to the lab connections which we are making, right? Because again, it conclude to the definition that Simscape domain is always used for physical modeling, or it actually represents a hardware component. This is a gain block. Okay, you can click on each block. This is a gain block. What does it do? It's just multiply. And this is a sum block which has minus and minus. Again, this is a gain block. This is K. This is an integrator block. And what is the signal that is coming from here? The signal name is A. Any chance that we will be able to read this? So this is how you build a model from the formula. I was not explaining the Simulink model construction. So what I was explaining is that, see, if there is a mass damper system, or let's say if there is a spring connected to a mass and you are expanding the spring, there the spring action and the mass integrated to it, the force acting on the mass and the force acting on the spring, and the damping action of the spring, everything works with the help of certain physics. Though that physics is converted into formulas which is readable by the learner, or let's say the user. That formula is being implemented as block, and that's how we create Simulink diagrams or Simulink systems. That we call it as mathematical modeling. Example, A plus B is equal to C. If that is a formula, A will be a constant block, plus will be an arithmetic block, P will be a constant block. Again, you connect it together and then you add a display box that will show you the result of C. So a simple formula like A plus B, when it is converted into a Simulink diagram or Simulink block, it is kind of complicated because you are majorly concentrating on construction of that formula, or let's say how you can convert that formula into a block diagram. So that's how Simulink is constructed. But in case of Simscape, it is more easy that there will be a physical component available under the name of mass. You just have to connect the mass and you can connect the spring, and that's it. The connection is over. So Simscape, moreover, points towards a physical connection of any system. Rather, Simulink will be concentrating on the mathematical modeling of any system. That's what we were discussing. Great. So I got a lot of answer from many of you. I will be like, yeah, so that is all the right answer. Correct. So reading the Simulink, if we have any more classes coming up, we will go ahead by reading or helping you to read how to interpret reading of a Simulink model. Otherwise, I'll try to provide you a reading material. In that, I'll explain you the steps like how to read it. Okay. So for now, I'm just closing this Simulink model. I want you to open a new model in Simulink, a blank model. How do you do that? Open, new, click on new, blank model. Open a blank model. You can close this model. I couldn't show you how to save a model, but many of you might have figured it out how to save your model. It is very simple. Similar to you save a Word document, click over here, go for save as. Then you can give a name and you can save it. So the name should be compatible to MathWorks, similar to how you save your scripting, M scripting. You have to provide the syntax properly without any space, or it will not allow any extra let's say extra letters you are adding. You can simply give a suitable name to your model and you can save it. Okay. So as of now, I would like you to open a blank model. I'm not going to save the model because it's just a practice model. Not going to save it. I'll just demonstrate it. So what we are going to do now, I wanted to keep it very simple, not to create complexity in the session, and you should not leave the session without understanding the concept. So understanding the concept is the best thing, which I'll be happy about rather than building a complex model. Let's go ahead with a very simple model and understand the functionality. Okay. So here, please look at my screen. So let's start modeling a motor. So motor will be something which is interesting. So let's start modeling a DC motor, a very, very simple DC motor. I have already shown you how does a DC motor look like. So those who have missed how does a DC motor looks like in Simscape, you can also type along with me. Click anywhere, double click anywhere in the blank model. Type DC motor. Those who have Simscape library aligned in your MATLAB, it will help you with this block. So you can, everybody, you can just drag and drop this block in your model. This is the model which we are going to use, but I'm not going to model anything with the help of this block. I'm going to just show you how you can go ahead with a simple equation model with this electrical component or electrical side of the motor. So a complete DC motor actually consists of what? An electrical system and mechanical component. That's what you are seeing over here. So this part is a mechanical component and this part is an electrical component. How could you recognize it? With the color coding, right? So electrical components are blue in color, mechanical are green in color, and thermal are orange, and hydraulic are brown in color. So let's just begin with the electrical part of this motor. It can be an appropriate simple model, or I'll just call it as a electrical circuit. Electrical circuit of DC motor. Of DC motor. Anything. So it simply looks like this. It has a resistor. It has an inductor. Then there will be a voltage source. Okay. Yeah. So I am not going to model this one. You guys are going to model this diagram with the help of Simscape block. Okay. So you can start modeling it. This is the diagram I want you to model now. I will also help you. I'll give you the hint and you can start modeling. Okay, I'll give you the values. So the values I don't want to directly give into the block or component. I want you to map it from your workspace. So let's see like how we can map that as well. So give it 200 ohm and this let it be 132 microhenry. I'm simply giving any value, like you can use yours. Let it be 24 volt. Since I have written in, I have drawn in brown, it doesn't mean that this is mechanical component, this is electrical component. Please start modeling it. Okay, so let's just start the exercise. You can also raise your hand if you have any doubt or if you cannot find any block, I'll help you out. So first, while you start modeling, what should you do? You should be identifying the components. Identify the components. So which are the components over here? Name the components. This is resistor. This is inductor. This is voltage source, which is a DC voltage source. So C is a port actually. So C is a connection port. If you're integrating with any other element like rotational element or something, it also will be having a C port. So it is kind of a common terminal. It is represented as common terminal. You can actually click on the box block and open it. So if you have doubts regarding any of the terminals, you open the block and go to description. There you can read what are those ports about. Okay, so total number of components that should be added over here is 4. Okay, so which are the blocks? I'm going to write it down. So, except for Sai Rajesh, if somebody has completed the modeling, well and good. Claps from me, applauds from me. Others, 4 components are there. How do you identify the components? Resistor. See, all these components should be from Simscape domain. That means it should be blue in color. Resistor, inductor, DC source, DC voltage source, ground. Four components. Okay, start modeling it, please. Okay, I'm going to keep this diagram over here. Resistor is here, and I have my inductor. Okay, I have my inductor. Then I need DC voltage source. Okay, I have my DC voltage source. Then I need my electrical reference. Okay, I caught up with you all. Okay, my model is completed. And, for your understanding, let's just name it as well. So how do you name it? Create annotation. Okay, that's not creating an annotation. How do you do create annotation? There is a small icon sitting over here in your left panel. Right, click on here and you can write it. Write whatever you feel like. No, not whatever you feel like. Write the name of the component. So let me write it resistor. So if anybody is from the mechanical background, this is inductor, resistor. Hopefully you'll be knowing it. No worries. In case like if there is any fresher, inductor. Okay, let me annotate it. Or I can simply write L. Okay, this is my create annotation ground point or earth point. This is my DC voltage source. I hope everybody have completed it. Okay. Try to run this. No, there is no switch right to it. So where? Oh, that was a tick. Okay. I'll just draw it properly. Try to run this. run them. Oh, okay. You haven't given the values, right? Okay, let me help you give the value. So first, we'll give it in the option itself. I mean, we'll configure it inside the block itself. Double click on it. Double click resistor. Resistance is 1 ohm. Click here. Click on the option. Provide 200. Click enter. It is auto applied, so you don't have to worry about saving it. You can close the window or close the prompt. Then double click on inductor. What is the value over here? 132. Micro is e raised to minus 6. So don't worry about changing the value. So e raised to minus 6 is micro. 132 I have added. Henry is already given. Nothing else have to be changed. You just have to add the value and close it. Go to DC voltage source. It's given 0. I'm going to change it to 24. Okay. Then I'm going to close it. My configurations are completed. So DC voltage source is 24, the resistor is 200 and inductor is 132. Add the electrical reference and please provide me a thumbs up if you have completed it. You can keep 10 as the simulation value. Don't worry. There is a switch. There is not a switch, Abhishek. So there is no switch to the ground. I have just added a resistor, inductor, and a DC voltage source. That's all. So no switches necessary. Try to simulate it. Let the stop time, which you can see over here under stop time, let it be 10 itself. Try to simulate it and see. Let me also try to simulate it. Okay, my model is not working. How many of your model is not working? Yeah, it will not work because we have to add one more block. That is an important block. That you call it by the name solver configuration. This is the guide. Okay, I'm going to erase everything out because my screen looks a little messy. I'm going to clear all my drawings and yes, so now my model looks more clear. Yeah, so your model will not work. The Simscape model will not work or simulate unless you keep this guide, which is called under the name solver configuration. So please take solver configuration and connect it to your model. I'll tell you why this is used for, don't worry. If you are not keeping a solver configuration block in your Simscape model, the model will not simulate. What could be the reason? So how to connect it? There is a port over here, right? So there is only one connection. You can directly connect it near to the ground. Always advisable to connect it near to the ground. You can rather than the positive terminal, it's better you connect it to the negative terminal or next to the ground. Okay, now try to simulate it. Okay, compile it. Right. So simulation is working. So what should we see? Where is the output coming? Have we kept any output visualizing block or anything which helps us to understand what we are doing over here? No, right? We haven't kept anything. We just simply modeled it. So what are we supposed to view here? What should we connect over here? Can we measure the current? Let's do one thing. Let's measure the current over here. So let's observe what is the current flowing through the DC motor. Okay. So how can we do that? We should be having a current measurement block. So in Simulink, it is called a current measurement block. In Simscape, it is different. See, just type with me. It is type current measurement. Current measurement. Look at my screen for a minute. For 10 seconds. Please look at my screen. Current measurement. Type current measurement. If you find it difficult to double click on any space, go to library browser, type current measurement in the search bar. You'll be able to find the current measurement block. Click on it. Okay, this is my guy. Is this a guy which whom I want to connect? Please tell me. Will this guy give me the measurement? Okay, let me just expand this guy for your visibility. See, If you expand it, you can actually see what is the model inside, right? So this is how the current measurement block has been modeled inside. Okay, right. Yeah, so you might have taken the current measurement block. It looks like this current measurement block. Okay, so then my next question will be why? Ground showing in black, not in blue. See, that is because you are going and taking a Simulink block. Please understand, Simscape is different. We are supposed to use an electrical reference. If you just type ground, definitely this guy will be coming, right? So this is a Simscape. There will be one more block which looks like this. This is also ground. Okay, what did we discuss in the initial part? We discussed many major points. So in Simscape, you have to go with electrical reference. That is the name. Go with a block called electrical reference. Just type current measurement, or if you are typing till current itself, you can see there is a drop down menu coming up for the blocks for you to choose. And under the name current measurement, you can see the path electrical / specialized power system / sensors and measurement. So this comes under a Simulink modeling. That's the reason it is not compatible, and you can also see it's not colored. Rather, what we have to do, we have to find something which can measure the current of the motor which we are assuming. So out of the drop down, which block can I use? Okay, I'm just showing you again. Go to Simscape, scroll down. This might be a little boring to few people who already know about the concept, but I'm just trying to help the people who are very new and who are practicing along with me, because it is not that easy to listen to a lecture and practice simultaneously. So I'm just going again, like repeating the things for them. So go to the Simscape, and under electrical, you have sources and sensors. Right? So this is the guy we are looking forward for. So he is the culprit. Let's just take him. He's not a culprit. He's going to help us. But for time being, let's call him a culprit. Yeah. So this is a current sensor, right? So see, look at him. He is also from the same family. Say that is correct. Sensor. So sensor and measurement, moreover, it is the same thing. Current measurement block measures the current. Current sensor sense the current, because we are actually dealing with who? A physical model here, an actual hardware part. So in actual hardware, we keep sensors, right? We do not have measurement. Measurement is something like a voltmeter, ammeter, where you measure the current in the load part. But in a system, will you be able to integrate this volt measurement and current measurement? No. We'll be keeping sensors to measure the parameters. So current sensor is a guy from Simscape Foundation Library under electrical. Then you go to electrical sensor. I have opened the panel in my left hand side. You can take a look at it. So what does this guy do? It measures the current in an electric circuit. So this block can be used in any circuit where you require sensing of current. Now, how do we connect it? That's the next question. We are going to sense the current. How to find ground in Simscape? See, the name of the component is called electrical reference. Electrical reference. Okay. So please type electrical reference. You will find the guy. Find the block. How do we connect the current sensor? Current is always measured. Shakti, that's great. That's the right answer, in series. Great. So where should I keep this? In between resistor or inductor? Or where should I keep this? Okay, I'm going to just sense the current in my electrical component, which I'm assuming to be a DC motor. Okay, again, let me familiarize the block, because, this is a block which has multiple ports. Yeah, so look at your current sensor. If I believe like everybody has followed me till now. So this is my current sensor, which I'm going to keep it. How many ports it has or how many terminal it has? It has positive, negative, and a output port, right? So I should not connect it uh, wrong, or I should be careful about my terminals as like a circuit diagram. So I'm going to keep it over here next to my DC source. So negative, so positive, I have connected over here, and I'm going to connect the negative to my resistor. Okay, and this is my current sensor. Yeah, so I have completed my model. Now I have how many components? 1, 2, 3, 4, 5 components, and solver configuration I have added. Yeah, so coming to that, I forgot to explain why we need solver configuration. So solver configuration is a block we prefer, or the solver configuration is a mandatory block which has to be used along with the SimScape model, because this actually specifies the solving parameters of your model. Before you start your simulation, the SimScape block diagram doesn't know, because these are all physical components, right? We haven't, it doesn't work like a Simulink model which already knows what are the mathematical formula. So this solver configuration will help the solver. So solver is somebody who sit over here to understand what is the need of this model, or what it should be done before simulating it. Okay. So that understanding is given by the solver configuration. Similar to, like almost similar to a Power GUI block, which we have used in Simulink, the solving or the mathematical simulation or numerical calculation is being done with the help of this block. Okay, I have connected. Again, I see sensor, I can keep it anywhere. So I'm just keeping it over here, because it's the same current that is flowing, right? It's measured in series, so it has only one leg, so it's basically the same current. Okay, when I'm keeping it after resistor, it changes. Yeah, I'm just going to keep it over here. You can keep it anywhere. If I want to keep it, if you want me to keep it at the end, definitely I can do that. So I can measure what is the current, whatever. Oh, let me keep it over here. Let me see, and then I'll change it. Okay, so you can keep it anywhere. Now there is one more port that is pending, or that is open. So I wanted to see the simulation, right? So how can I see the simulation?
Let's have a quick quiz question, guys. In MATLAB, which command is used to create a new variable or overwrite an existing one? Load, assign, define, equal to sign. Please mention your answer in the comment section.
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights, so visit the course page link given in the description below and take a first steps towards a career growth.
Right, so what should I do in order to view my results? Correct. Many of you, yes. So I think like where can we visualize? That's my question, Sai Rajesh. Anand, you are extremely correct. I should keep a scope. So scope, I don't have a scope of, using a different block. Scope is the same scope which I have to use. It's the same common guide, because it comes under which tool? Commonly used block. You go to your library browser and see the scope. The scope comes under commonly used block. Okay, so I don't have an option in SimScape for viewing it, because this is not a physical model, right? The scope is not a physical system like other components. It's just a supporting block which is helping you to visualize the result. So this, like it doesn't comes under SimScape domain. Only the physical components comes under SimScape. Other auxiliary blocks or the supporting blocks or the blocks which are used for the backup and other type of operation, it will be found under the foundation library commonly used block. That's the reason. Can I connect it? Try to connect it. What happens? Not connected. Correct. It will not connect. Why? Because again, this comes under Simulink and this is a SimScape. So I need a block which converts or keep a compatibility between SimScape and Simulink. I'm going to use the guide PS to Simulink converter. Type PS to Simulink converter. I'm just keeping my screen open for some time. You can see the first block that came under my suggestion. That is the block which I'm looking for. PS meaning physical system to Simulink converter. Take that block. Okay. Now this block will mediate your energy into a signal and that will be displayed in your scope. My model is complete and I have some extra blocks here. I didn't delete it. So there are some situations where when you are modeling or while you are working on a system, you keep on adding block and sometimes you want to remove the block and check the compatibility or check the test the system so far. Then you add it. Then you again remove it. So every time you cannot delete and take the block. You can keep it masked, meaning that you can tell the simulation engine that, hey, do not consider this block. He is he is not a part of this project, or he's not going to be a part of simulation. You can always tell that to your simulation engine, not by just looking at the screen and telling it. How do you do that? You select the guy. There will be 3 dots. Move your mouse pointer to the percentage symbol, similar to our M script, which says comment out. Click on it. Your block is masked or your block is invisible now. Similarly, I'm going to block this guy. Okay, select him. There will be 3 dots coming at the corner. Move your mouse pointer to the percentage symbol. Click on comment out. Okay, now these people will not come into my simulation. Otherwise, if you have an extra block, the simulation engine will throw an error saying that, hey, these blocks are not connected, it's floating. Okay, now that is done, simulate it and give me the result. Those who have kept the current sensor next to the voltage source, this is the result which I am getting. You can see. You can actually, so when you are simulating, it might be a very narrow band. What you can do is you can just go to the auto scale option over here. You can click on auto scale, or you can use a magnifier here and you can expand it. So use a magnifier over here. You can expand it horizontally and vertically. I'm keeping this open, zoom in and expansion of y-axis and z-axis, that is possible too. I'm keeping it open for now to make you understand which option I have taken to expand the graph. So this is the diagram I'm getting. Perfect. Let me know if your simulation is perfect and is giving you the result. So in MATLAB Simulink, the modeling and the skill, it is a skill, right? So the skill has to be polished every time. It has to be made sharper and sharper over the time. The maximum you practice, maximum models you read from MathWorks documentation, you open and simulate and understand how that logic works, that will help you to build your own, create your own models. That's how you learn. So first you try to understand how they have built certain project. What are the connections they have made? What are the blocks they have used? Why they have used that blocks? So from the default model itself, you try to get the concept of modeling. Then you try with simple models. That will work for you. So practice is the ultimate key where you have to invest in this process. Okay, so I would also like you to show one thing, which is kind of an option in SimScape. Go to battery block. Take the battery block from SimScape. Okay, that is called table-based battery. I think I jumped into solution. Let me see whether this works. Yeah, this also works. See, go to, take one battery block. This is different. Like this is not aligned with the model which I'm working. This is something which I would like to show you. Let me just keep him away from the screen. Take a battery block, which is from Simscape. I have lost the workspace data from the command window. If you clear it, you definitely it's not a permanent space. It is a temporary space. If you are pressing clear all and CLC, that will be completely erased. You can't see command window. Go to your MATLAB screen, Zaid, and please click on layout default. Go to your MATLAB screen, click on layout over here and click on default. You will be able to see the command window. Okay, going back to the model, battery block. I believe you have taken battery block from Simscape. It is blue in color. Okay. See, observe something. Now look at your panel, tool panel. I just look at the mouse pointer which I'm having. So you have a blue color, navy blue or dark blue color toolbar in the upper hand side, which states simulation, debug, modeling, format, and apps. Right? So you have 5 options in the navy blue panel. Okay. Now go to the battery block and select it. Click on it. What do you observe in your tool panel? Look at your navy blue panel now. What else have popped up? Have you noticed something? Unselect it and look at the tool panel, navy blue tool panel. There are 5 options like simulation, debug, modeling, format, and apps. Now go to your battery, click on it. We need good observation. Simscape block popped up. That is a Simscape block. That means this block has some hidden agenda. This block has some hidden features. Now let's explore that features. Double click on this block. Open it. This is a battery block, which is a physical system modeling block. Nominal voltage 12. Okay. Battery charge capacity. Okay. Thermal port. Let me check. Thermal port. Okay. Expose. 1 minute. This one, expose charge measurement port. What does charge measurement port means? SOC port, right? State of charge port. Expose charge measurement port. It says no. Click on here. Click yes. What happened to your block? I'll repeat. What I did is like I double clicked on the battery block. I went inside. I went to the 1, 2, 3, 4, 5th option, which is expose charge measurement port. It was shown no, but I have clicked on yes. Look at your battery block. What happened? One more terminal got added. That's correct, Sai Rajesh. This is the measurement port, SOC measurement port. Anju, that's correct. An extra terminal is visible from where you can add a scope to understand the charge. This is termed as Q. That means this is your SOC port. Okay, now go to thermal port. The option just below what you have changed now. So main options are main, dynamics, thermal port, initial target, nominal values. Go to thermal. Click on the small arrow near thermal port. Thermal port, it is shown omit. Click on it, model. Now what happened? Again, an extra terminal popped up, which is related to a thermal physical terminal, which is orange in color. And this is a terminal port or thermal port. That means this battery block is capable of providing you the signal or energy, or let's say the parameters or output, which is an SOC port, or this block is capable of giving you the result or showing you, demonstrating you the result of state of charge of this battery and also the temperature dependency or thermal effects of this battery can also be simulated and visualized with the help of this block. Simscape block. That's correct. Okay. Yeah. So this is something which I wanted to show you. That is a magic in battery block. So while you're using Simscape modeling, if you want to simulate this block and understand the thermal characters, you can just do the same process method and you can just work on it. Let's talk about the for loop which you have done. If you have saved the for loop, please open it. What we have done was turning the light off, right? Very layman concept program. If you have that program, please open it. Otherwise, it's fine. We are going to see one more program similar to the turning off of light, and I'm going to explain the turn off light again for those people who didn't understand. And after that, I'll just show you the contour plot programming with a real example. Okay. 5 minutes. I'll take 10 minutes to explain the for loop and then we'll quickly jump on to the contour plot. Okay, what is for loop do is like I'm going to draw a flow chart here. So while you are using the for loop, as I have mentioned, the for loop actually helps in repeating the same set of operation. The same operation which you want to do multiple times, that is where you use a for loop. So how you use it? Usually you use a variable for initializing that process and the variable keep on changing its size as it increments or decrements or the process move forward. Okay. Okay. The steps are like first you initialize the condition. Okay. What exactly you are going to do? Initializing the condition is the first step. So in case of our example, the question, if you remember, was like, I have 10 number of lamps. Let's say 1, 2, 3, 4, 5. Sorry, not 10, 5 number of lamps. I wanted to switch off lamp number 2 to lamp number 4. I'm numbering it 1, 2, 3, 4, 5. My condition was I wanted to switch off lamp number 2 to 4. That means this 3 lamps should be under a condition of turn off or it should be turned off. That was my process or that was the task I wanted to give to the simulation engine. Okay, or MATLAB. Now, how should I initialize it? I should first initialize saying that I have 5 lamp out of which I want 2, 3, 4 lamp to be turned off. That is my initializing condition. Oh, sorry, that is my initialization or that is from where I will start the program. So initialization is something like I have 5 lamp and I want to turn off lamp number 2 to 3. So I have given the initialization as well as the condition. What is the condition? My lamp 2, 3, 4 should be turned off. Okay. Now, while I'm writing that program, the for loop or let's say the program will check the condition first. So how did I write it? First, I have written something like, you can look into your program, light underscore 2, I believe that's what I have written, equal to 2, means that I have initialized that, okay, first thing I would like to turn off is lamp number 2. Then I have written the final point, right? So starting lamp and the final lamp, or let's say starting condition and the final condition I have given as the first 2 lines. Then I started the for loop saying that for the condition of or turn off the light from 2 to 4. Now, what is the for loop do? So it initialize the process like, okay, I have 5 lamp. What I have to do is like, I have to go to directly to the second lamp. I should not go to first lamp. I know that there are 5 lamp, but directly I should be going to second lamp and I should turn off from 2 to 4. Because my first condition is 2, or the first number of the lamp is 2 and the last number is 4. Now, I understood the condition. So I have given a variable like light, or let's say for I. I can be the variable which I am giving. Okay, I is the number of the light. What is the number of the light? It is 2. Correct? So my for loop will be checking whether this condition is right or wrong. So directly my for loop was intended to go to the second lamp and it checked the condition like, okay, whether this is lamp 2 or not. Yes, that was correct. It was lamp 2. For I is equal to 2, starting from 2. Now the for loop will execute the condition turn off. Because that was the condition, right? Or that's the task I have given the MATLAB. Okay, for loop executed it. Now it will again go and check. So that condition is completed, or that task is completed. It turned it off. Now it has a ending pointer as well. Not only the first point, I also have mentioned I want to turn off from light 2 to 4. Now it will go back again to the condition after 2, which is the variable, or which is the lamp, it is a 3. Now the condition becomes, or the for loop I value will become 3. Initially it was 2. As per the condition, it matched, so it turned it off. Now again it went back to the next successive loop, or let's say a successive variable, which was like 3. Again, the 3 was coming under this condition, or in between this condition. Now again go back and do the task, which is turning off. So again I got a result like turn off, printing turn off. Okay, that condition was completed. Again it will go back and check, because 4 was the final point I have given. It will go back and check. Now the I value becomes 4. Okay, this is matching. Now I have to turn it off again. Okay, now the loop is completed. Now again after I, again it go back and check whether the condition is satisfied. So after 4, when it go back and check, the integer was 5, or let's say the condition was not satisfied, because I have given I should only go and check, or I should only go and do the task within the range of 2 to 4. So 4 is completed. Now next is 5. So this is not aligned with the or requirement, right? Or this is not matching with the requirement. So the loop will terminate. So now how many times I will get the result printed? 3 times. This is how the for loop work. Okay. So if you want to write it in a better way, instead of writing lights off, light 1 and 2, professionally what you can do is like, you can first initialize the variable for I is equal to 2 to 4, because 2 was my starting point and 4 was my ending point. Display, what should I display? Light turned off, underscore turned off. And I should also display I, means that which is the number of the or what is the number of the lamp that is turned off, and then I can end the loop. So what does it do? First, the loop will go and check, okay, which is the starting condition for I is equal to 2. Okay, this comes under this range. So it will go and display light is turned off. It printed. Now again, once this is done, it will go and decrement or increment the value from 2 to next value, which is 3. Yes, this comes under the same condition. Okay, the task has to be done. It will again print turned off. Now again, it will increment to the next value. It will go and yes, 4. Yes, the task has to be done. Then it will print turned off. Again, it will increment. And yeah, so I value was 5. No, this doesn't satisfy this condition, where my starting point should be 2 and ending point should be 4. So it will terminate. Now I'll get the result printed 3 times. This actually happened in the program. So I'm going to find out the efficiency of my motor, like the range in which my efficiency lies, if I have the data of my torque and speed. So clear all, then close all. Oh, okay, I don't want to close. Okay, let me just give. Okay, write along with me. Clear all, close all, and CLC. That clears everything, hopefully. Okay, so write the comment like we have data of speed. I'm just commenting or I'm just writing as a text. So that's the reason I'm using the percentage symbol. So speed and torque input. I'm going to give speed and torque input as my x and y variable, and I'm going to predict the z variable, which is the efficiency. So speed I'm going to give under the variable w. So linspace is the comment which I'm going to give because it's an array which I would like to call. So linspace 1, 1000. That means from the value of 1 to 1000, I'm going to consider my range of speed, semicolon. I'm going to give the variable t to the torque. T is equal to, again, linspace. Here I would like to give 1 to 250, semicolon. Okay. Then I would like to mesh grid. I'll tell you what is mesh grid. So I'm going to use the command mesh grid. So what I do is like square bracket. I'm calling the variable which is already given as w, which is my speed value, comma t value, which is my torque, equal to mesh grid. I'm using mesh grid command. Again, calling w, comma t. Okay, let me try to run this. Oh, I think I need to save. Okay. Yeah. So what I have done is like I have initialized my two variables, which I'm going to predict. The third variable, the speed and torque, and I have given the command like mesh grid. So if I'm running the program, I'm getting a lot of values, something like this, right? So mesh grid is a command which helps me to create a rectangular, or let's say coordinates of different parameters which I have provided over here. If you're not clear, this will give me, or this will help me to build a point grid with variables which I am using in my program. Uh, if I have an option to draw this, maybe you will be clear. So I have a rectangle like this. This is 0, or I'll take it like x is equal to 1, which is my w, and this is 1000. And I have again torque over my y-axis, which starts from 1 to 250. Okay, this is my axis. So I am giving a linear spacing, which can be like how much? Let's say if I have to divide this into equal space, I will be dividing it like this, right? In x-axis vertically and also in y-axis. So this is called a mesh, or it's called a grid. Now, there will be coordinates at each point. If this is point 1, if this is point 1, what will be this coordinate? X and y coordinate, it will be point 1, comma point 1. And if this is point 2, if I want to write this point coordinate, then it will be point 1, comma point 2. Here it will be point 3, then it will be point 1, comma point 3. The x-axis, the x coordinate is point 3 and y coordinate, sorry, x coordinate is point 1 and y coordinate is point 3. Similarly for here, if it is point 2, this one will be, or this point will be point 2, comma point 1. right? So similarly, there will be coordinates for all the points, x-axis and y points. If I'm just assuming this is a rectangular mesh or it's a kind of a 2D plane. So this coordinates can be plotted or can be printed with the help of the command mesh grid. That's what happened here. So if I'm just looking at the data, I have given linear spacing, right? So it can be like 1 to 1000, it can be n number of values. Lot of values can be there. So all the coordinates have been printed. See, the x coordinates are printed and the y coordinates are also printed. How many columns are there? Lot of columns, right? So that's what happened. All the coordinates have been printed and it is all in like 0.01 spacing. So from 1 to 1000, it has been printed with the deviation or with a delta difference of 0.1. That's the reason it has this many coordinates over x and y. So that's what a mesh grid do. The command mesh grid do. So since I'm creating a 3D plot, or let's say since I'm going to assume or predict the x variable, I want to understand all the coordinates or complete coordinates. Yes, we can see it graphically in MATLAB. That's what I'm going to do next. Okay, so that's the reason I have used the command mesh grid. So I believe you have completed the program till now. Now I wanted to just, okay, I'll show you, there is already a program. If you want to see the plot, it looks something like this. If you want to plot it, it looks something like this. I have also used the command surf. If you comment it out, the contour looks something like this with all the coordinates. Okay, just an example, like somebody asked me whether we can see it. W is x-axis and P is y-axis, right? Yeah, so this is done. And I'm going to initialize the constants in the motor because, see, if I want to find the efficiency of the motor, what should I do? I should implement the formula. What is the formula for efficiency? Normal formula. Output by input, isn't it? So power output divided by power input will give me efficiency of any system. Now, when you consider power output is a combination of the input power plus all the losses. Anybody have doubt in this two formula? The grid value 0.1 spacing is defined because I have given linspace. That means it will take 0.1 values. If you want to definitely provide a step value in between, you can avoid linspace and provide the step value like 1 colon. If you want to take only 2, 1 colon, 2 colon 1000, that will provide you with the step values of only 2. Since I have randomly generated the coordinates with linspace command, I have not given any step values. It have taken 0.1 value. I believe that's clear. This is efficiency. How can you define efficiency? Power output by power input. And this power output is a combination of input power plus all the losses that is associated inside the system. Because each system is associated with a certain loss and the input, while it comes as an output, it will undergo certain drop due to this losses. Fundamentals. PI is power input. Yes. Okay. That. So this is the formula we are going to implement in the program also. So for next, I'm going to initialize all the constants in the like associated with the motor formula. Then only I will be able to understand how much is the loss inside the motor. So okay, let's tag along the constants. So one is copper loss, or let's say constant, right? Copper Kc, which is associated with copper loss. I'm giving a value of 0.2. You can give 0.1 or whatever value. 0.2 I'm giving. Then I have iron constant Ki, like I have iron loss, which there is a constant, which I'm giving the value something like this, very minimum. So the values I have referred it from a book in order to get a plot, clear plot I have referred. Now I have windage loss in the motor, which I am going to provide the value. 0.00001. Then motor constant value, I'm going to give it at 20. Okay, let me know once this is done. So next I'm going to calculate the total losses. Calculate the losses. So copper loss, let's say equal to, going to initialize the formula, which is Kc into torque square. Torque square, I'm going to keep it like T cap 2. Okay, this is the formula. That's all. Nothing much. So constant, the constants which you can see along with the motor modeling from the formula. This is all fundamentals. I have not added anything extra. Kc is copper loss, the constant which is associated with the copper loss. Ki is the constant which is associated with iron loss. Then vintage loss. And then motor constant. Now I am just implementing the formula for each. First one was copper loss. Second one was iron loss. Okay, iron loss formula, I'm just referring a book. Ki, that is iron loss into W. Then finally, I have the vintage loss, in which the formula is Kw, which is a constant, that into speed. Okay, that defines my losses. Now I want to calculate the total loss of my motor. Total loss, I'm just giving this TL. I'll explain the program one more time. You just have to look at it and type it. So I have to add everything together, that's all. And also I should add the motor constant. Motor constant is the ability of motor to convert from electrical to mechanical. And there will be certainly a loss associated when it is the energy is being transferred, or let's say the energy is converted. Okay. So again, going through the script, I'm going to find the efficiency of my motor. With the help of the parameters of speed and torque, I'm going to predict what will be my efficiency, and that too I wanted to see in a contour form, where I wanted to understand, okay, which range will provide me with higher efficiency. Okay, just not like a single plot, rather like I wanted to understand how the values are spread across when I have certain range of torque and speed, and how it should be. That's what I'm going to check. So for understanding the efficiency, or for finding out the efficiency, the formula is simple general formula: output power by input power. And the output power, while I'm considering, I should keep in mind that the total losses of the motor plus the input power the input power is output power plus the losses. I think I have written it ulta before. Apologies for that. So input power is a combination of the losses plus the output power. So I'm keeping these two formulas in mind. I have initialized the constants, the value of constants, which is associated with the motor equation, which I'm going to find out now. And then I initialize the formula for the motor parameters, which helps me to find out the power. So ultimately, all these steps are giving me the conclusion of finding out the power. Now I wanted to calculate the power. So how do I calculate? I have calculated the total losses. Now I'll calculate the power. Score output. Okay, P underscore output. What should be P out? P out is simple. Torque into speed. My output power formula is speed into torque. And what should be my input? My input should include. Now the formula for efficiency, you know the formula. P out by P in. Everything is matrix addition and matrix operation. That's the reason we are doing element-wise operation with the help of dot. I believe you remember. So efficiency, I have given a variable like Z. And now I also going to provide data for my V, which is the voltage. Okay, I'll give the value from 0.7, 0.75. Like these are few values from the book. So if you have any other reference, you can definitely go ahead with the reference values, no worries. So here I'm just referring to Tereja, and I'm just writing the values over here, which can be an array, which will help me to create a proper contour. So these values will help me to beautify my contour, or it will provide me a better understanding about the range. That's the reason I'm giving it. So I have also given an array which is 0 0.7, 0.75, 0.8, 0.85, 0.9, then 0.919293. Now I'm writing my program for the contour plot. So the parameters which I'm using is speed and torque. And I wanted to predict the efficiency with the help of other variable. Okay, so this many variables I'm going to plot. Okay, I'm going to give a color bar as well. So it will provide me a better understanding of the efficiency. I can check the color bar directly. Then I want it in a good shape. So that's the reason I'm going for box off and color grid off and all. Then I also wanted to title it. So I can title it something like contour plot motor. Contour plot motor. Then I should also write like, okay, it's up to you, whatever you wanted to like name. I'll just simply keep it like contour plot motor. I should provide quotes for my title of the plot. Then I can also just provide the X label, which is in quotes speed. That will be in radian per second. Then I can also provide the Y label in torque. Okay, again in quotes. Okay, I think there is no error as of now. Yes, got the plot. Okay, this is the plot I'm getting. So you can see the speed and torque parameters which we have given, and the color bar command was given to provide this, this panel of coloring. See, look at here, the area which has been colored yellow is having higher efficiency with respect to each of the parameters. Okay. So if you, let's see here, let's keep a point over here, move your mouse pointer to here. Your x-axis value or x value is 646. What was x? It was speed, right? So speed in radian per second, it is 646, and your torque value is 154. And look at the efficiency you are getting. What is the efficiency there? 93% efficiency. So over the range of 646 and let's say 61, right? So 61 to 646 speed and torque value 8.5 to around 149, you're getting maximum efficiency. Look at your efficiency. It's like 89, 95. And if you look at here, the efficiency has decreased. That means when the speed and torque was varying, it was increasing over the scale, your efficiency value got decreased. And if you look at the outer graph, again it got decreased. So finally, you are left with a efficiency of, let's say, around 91.7. Look at the level. Level is 1.917. That means efficiency is 91.7. And what is your torque and speed value? Speed value was 1000 and your torque value is 250.
Let's have a quick quiz question, guys. In SimCap, what are the main types of systems that can be stimulated? Continuous systems only, discrete systems only, continuous, discrete and event-driven systems only. Please mention your answer in the comment section.
Right? And it persists, right, till 237 and all. So this is how you do the contour plotting to understand the third variable with reference to two parameters. So V is here. The color bar, you have given it over there. Okay. I believe contour plot is clear, and you can also like keep your mouse pointer outwards and see. So here and all, it's 72 only, right?
Just a quick info guys, Intellipaat offers electric vehicle course in collaboration with IIT Roorkee. Through this advanced course created by the IIT Roorkee faculty, you will deepen your understanding of electric vehicle design and other related ideas. With this course, we have already helped thousands of professionals in successful career transition to EV industry. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. Repeat. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description below and take a first steps towards a career growth.